We are on live.
আপনি অ্যাডমিট করা বন্ধ করে দিন, আমি দেখছি পাচ্ছি।
Hello everyone. Good morning to the World Ocean Day. I hope we are here, all the ocean lovers, and we are slowly joining to the event. I'm seeing people from all across India and globe. Very good morning to you. To some of, oh, I see Sean here from South Africa.
Good morning, everyone.
Yep. So some good, very early morning, some good morning, some like a post-lunch session. And we take like a little bit of time here, like maximum of 2 to 3 minutes as people continue to gathering. As we continue to gather people in the meeting, we must not forget how this all started. The World Ocean Day was actually proposed in 1992 by Canada, while the Rio Summit was going on in Brazil. So that literally marks some sort of an effort and thinking process, which got finally recognized by the United Nations in 2008. Now, this could be just a day for many of us, but this is not actually a single day, because our life is, if you think very much in a way, it's being controlled by ocean, and this because like we have so 1/3 of the land and 2/3 of the ocean, and our oxygen and all the resources are majorly contributed by ocean. So we cannot breathe 1 second if we think not about the ocean, you know. So it's not only one day that we should be focusing on, rather we should be focusing on things which are going on every day, and regarding ocean and ocean resources, how we sustainably use and all these things. Coming back to the Estuarine and Coastal Studies Foundation, it's a young foundation. Like I see many young people are gathering over here to observe World Ocean Day. And I feel really good that people are enthusiastic, the young people wants to make a difference. That's why they are over here. And that should be the part of it. So what we need to do here is that so there are some technical glitches. I'm not a technical person, so I have to always take a hand. But that's the best thing of what is not there in the ocean. The ocean provides us resources. The ocean provides us livelihoods. The ocean provides us science. The ocean provides us the storytelling. The ocean provides us the mythology, and it's literally captures everything. So when we talk about the Estuarine Coastal Studies Foundation, many of you possibly don't know where it is situated and how it works, or what its journey and how it's actually like who are the members and how things are going, and what is our motto. So we are situated in India. We are situated in the eastern part of India, name a city called Calcutta. It's very close to there. Our priority ecosystem is definitely the estuaries and coast. And we do practice very multidisciplinary sort of studies. We have scientists here who are who could be biologists, who could be physicists, chemists, geographer. We have people who are like performing arts. We have people who are performing economics over here, and all sorts of like science, social science, and other domains. So this is very much interesting. The purpose of the of creation of this foundation was actually to make a platform for young people who can express their mind in terms of if they are interested in terms of estuaries, coast, self, and ocean. So that's how we go about it, and we are not restricted to any particular domain. It's it's up to you how you want to contribute the ocean and ocean sustainability, how you want to harvest the resources, and already the good wishes are coming up. Yes, it's thanks Amit. It's a World Ocean Day, and it's very best wishes to the wishes are coming from Kuwait, Middle East. So that's very interesting itself. Yes, many of you here are, as I see, are college students. Some of you are students of the universities. Some of you are just the early career professionals. Some of you have just like a mid career to the very much. The foundation is propelled by a group of directors, followed by the advisors, and then we have scientists who work on there, and then we have staffs who tirelessly work for this day, and they made it possible. This is sort of a magic these days, because celebrate in one single platform, and that's the best thing about it. Now, regarding this foundation, and we were talking about that how this foundation journeyed. It started its journey only in 2021, and it is created by mostly young people. And then from then onwards, it's created as an education and research body, which is mainly focused on estuaries and coasts. Since then, we have fathomed a lot. We have gathered the, recognition of UNESCO. In India, we are being recognized by Niti Aayog. We train a lot of people, because when we talk about ocean, generally the thing that comes up, is it something impacts me? In the World Ocean Day, I want to say one thing to all of you who have joined, that remember always that 70% of the world population actually lives within 70 kilometers of the coast. So that means if you think that your life is not impacted by ocean, it's possibly not much truth in it. So regarding that, then we do a lot of capacity building to make people understand how our lives are interconnected with the ocean and ocean resources. And we do research, we do hands-on training, we also do a lot of international and national seminars, and we remain in touch with a lot of pioneering institutions across the globe and India. We learn from them, and it's been so far a very kind of a sailing experience. I would say it's an experience of a sailor. It's a rough. Sometimes it's a rough sea. Sometimes it's a a smoother journey, but that makes the experience itself. And that if you are an ocean voyager, if you are an ocean lover, then I believe that you love that tough part and you will also like to sit calmly on the deck and enjoy the sunshine. So yes, that's kind of things that we are going through in the foundation. Already we have 80 odd members that across the India and the globe. That basically means the people are they get still pouring and pouring, and it's very interesting that that more and more people are being engaged. Now, this World Ocean Day is being now celebrated all over the world as a part of the inception world community. We are also celebrating the World Ocean Day. Just before we go to the technical session, this is kind of an introduction session. This is going on. I think all of you have got the itinerary. In case you haven't got it, I just want to remind a small things that this session, I mean, like I'm talking with you right now, and after that, Professor Vijay Nandan may join with us for his talk about 10 minutes or so. Sometimes, and then we would be heading towards. After that, we would be heading towards ECOP session. What is ECOP? It's kind of like as I said, that many of us are early careers, and this was a challenge for us to start up a platform and to celebrate and to dedicate our work to the ocean. So the young people raise their hands and they kind of put forward their energy to build this foundation and they are propelling it. Now, to celebrate them, the foundation actually will host a series of talks of the early career ocean professionals. That session would be mostly moderated by Ms. Devarati Sengupta. She is an ECOP professional recognized by UNESCO. And then we would go to the mid-career section where we have series of invited talks. In the mid-career section, part of that section would also be moderated by Dr. Chimli Mondal, who is a scientist, who is a TBT, Biocare Women Scientist, working at the foundation. And some part of it would be the senior talks, and I would also be presenting that talk with you. And one thing that I would love to tell all of you, this is a day of engagement. This is not a day of like a seminar only. So whenever there is some sort of like talks going on, most of the talks would be the ECOP, sort of the early career talks are kind of 10 to 12 minutes, followed by like 5 minutes of sort of discussion. And then the mid-career talks are around like 20 to 25 minutes, and then followed by 5 minutes of discussion. And the senior talks are kind of like a senior career talks are like 45 minutes, followed by like 15 minutes of discussion. So please discuss. It is imperative that we discuss. Unless we discuss, unless we talk about the challenges that we as a young community face, and what are the aspirations of this generation? What are the aspirations of different generations from the ocean? We won't be able to understand. So let's always engage after the talk. If you have queries, most of us are not pundits. We are all students. We are learning ocean because most of the ocean remains undiscovered. So that means we are students and we have to unravel those mysteries. This is also very important. Right now, Professor Vijay Nandan has joined with us, and I should not be taking too much of a time. Good morning, sir.
Morning, Dr. Saurabh.
I-
Good morning. Good morning. Can you hear me?
Your mic is, you are not audible.
Audible. Let me just check.
Okay, while Sir picks up his technical details, I must say that Professor Vijayanandan, he's kind of a guru in terms of India when it comes to the ocean and ocean the resources are concerned and Ocean Day is concerned. Like we look up to him as the teacher, and you know they. Is there any, okay, somebody is just, if I have an issue, I may be having an issue. Sir, can we?
Yes, yes. Yeah, I can hear you. Yeah, we can go ahead.
Okay, sir.
Yeah.
Hello?
Yes. Yeah, I can hear you, Dr. Saurabh. I can hear you. I can hear you. Yeah, I think you can hear me now.
Yes.
Yes, yes.
Yes.
Okay. Yeah.
I just want to say the sir is not only a dean, an HOD and the dean of the CUSAT who just retired from his duty, and he was officiating vice chancellor of the Kannur University. He is the lead ambassador of India, who is making a difference for our estuaries, coast, and the ocean. And it is he's also an advisor to many young people like us. He's guiding the foundation from its day of its inception. So we are very much blessed, sir, to have you over here. Our audience is ready. And if you kindly say a few words about the World Ocean Day, because we would be very keen to actually know from your mouth, like how you see the World Ocean Day transited in India, and the message is getting bigger and bigger as the time is progressing.
Yes, I'll start. Yes. Good morning, Dr.
Good morning, sir.
Good morning, Dr. Saurabh Paul. It's indeed, I'm so happy to be with you with the Estuarine and Coastal Studies Foundation for the 2024 World Ocean Day program. Celebrations, I would specifically call, because I'm really impressed by the activities of Dr. Saurabh Paul, the Director of Research and Education, and his collaborators at the Estuarine and Coastal Studies Foundation. And I've been watching you and this institution grow for the last several years. Other than your academic pursuit, your scientific temper, and your contributions to building a societal framework for the well-being of the oceans, the coastal systems, the ecology, especially various anthropogenic issues, the looming threat of climate change. All these are gathering up in this new world order. I think in the global south should be more concerned about it. In this scenario, I think what the Estuarine and Coastal Studies Foundation is doing is a yeoman service, and it should be commended by all. And I'm also happy that your institution has been. In fact, I'm one of the advisors of this institution, and I'm also happy that the Niti Aayog and the UNESCO has all recognized your valuable services to the nation and the international community in marine science. Now, I'll just come to the significance of today's importance of today's World Ocean Day, because as we all know, the World Ocean Day is really significant because the conserving and protecting our oceans is very, very valuable. Our oceans is very, very valuable because other than we know that globally the oceans are changing because of human activities, and we know that even today's 2024, the theme of today's Ocean Day is catalyzing action for our oceans and climate. When you look at the broad theme, we very well know that the way of catalyzation of our actions, and this year, just as we had in 2023, the importance of eradicating or removing the plastic, the recycling of plastics, the usage of plastics is in fact increasing day by day. We know that we have almost 330 million tons of plastic being produced globally, and we have only about half or quarter of it which is being recycled. And in fact, this is creating a great catastrophe to the human community, not only in oceans. Not only the oceans are getting filled with microplastics and all kinds of plastic debris, the marine litter and whatnot. Other than that, the land gets filled, the land changes. Even in the recent World Environment Day also, land restoration, the desertification, all these are important actions. And the restoration of land to productive ecosystem is one of the very important message which is communicated by the World UN body. Similarly, the World UN body, which has embarked on this journey in continuation to today's World Ocean Day today, is very, very relevant that the catalyzing our oceans and our climate for the well-being of the humanity is very, very important. And if you look at that, the greatest scourge to humanity is the looming threat of climate change, the looming threat of the anthropogenic interventions largely created by the large quantities of plastics and microplastics and marine litter dumped into our global oceans. And these are really something which needs to be a great concern by humanity. But if you look at it, we need to have significant national, international, and local action plans for the and also the corporate leaders for regulating and protecting our oceans. And one of this is most important is we need to have best use and of the existing climate solutions, and also you need to have you should go for clean and renewable energy sources. We have to stop. We also need to look at other modes of energy production, including the regulating the fossil fuel production, and also including gas, oil, and coal. Because even though we have proposed, India has proposed, has pledged with the global community in 2020 we will be net zero. The larger threat of climate change, as we know, the global temperatures are rising and the rate of warming is almost 0.91, 0.8 to 0.91 degrees centigrade. And also the sea level rise is phenomenally rising, and we could see many of our islands and low-lying habitats getting submerged due to various flooding and increased climatic issues, and also the heavy increase of carbon dioxide beyond the pre-industrial. Extremely many times we had about less than 200 ppm during the pre-industrial period, whereas it has risen to over 400, 440, 450 ppm during the current period. So this increasing of the baryonic increase, a phenomenal increase in carbon dioxide and methane and nitrous oxide is seriously a great threat to humanity. So we need to have the offsetting, carbon offsetting plans. We need to have carbon regulating plans, and we need to also look at how our global systems, including the polar regions. I was just going through one of the, with regard to this year, a very recent study which has been done in the Arctic region. You see, they are introducing pumping water to stabilize the thinning of sea ice, because and one of the group of Dutch American scientists are working on ways to to reduce thinning of sea ice, because thinning of sea ice is very fast, especially it thins almost 30 to 40% of the ice. The sea ice and the snow is getting thin, it is getting low, and it is creating a great problem for the polar regions. Especially, you could see that thinning of the sea ice has created and research and R&D initiatives. So it is basically a geoengineering concept. See, geoengineering technologies have to seriously come into regulating even our polar regions, because thinning of sea ice and losing our permafrost is going to seriously affect the larger community, because what happens in the polar regions, what happens in our Himalayas, what happens is going to have catastrophic events. It is going to have cataclysmic or catastrophic events which is going to create havoc for the humanity and in fact mitigating climate systems. So what we need to is we need to protect and restore the natural and coastal ocean systems. Definitely the coastal systems are greatly plundered and butchered, I would call, because of human unwanted release of great large amounts of human waste, large amounts of untreated human waste, untreated sewage disposals, untreated industrial activity, because we are in an era of growth and development and well-being of the humanity. And it has to be in tune with the Sustainable Development Goals, especially Sustainable Development Goal 14, Sustainable Development, because life below sea the water, Sustainable Development Goal 15, and so many of these Sustainable Development Goals of the United Nations are in tune with our development proposals. So even the Human Development Index, it's very, very important that your Human Development Index is raised and it increases, so that you look at the Indian Human Development Index. It's extremely low with around 0.6 or 0.7 around the range. So this Human Development Index has also to phenomenally rise, so that it takes care of the overall development of not only the coastal systems, the oceanic systems, how climate is regulated, and the climate mitigation phenomenon. Because I would not say climate mitigation, just I said, in the polar region where thinning of ice is one of the serious issue, through geoengineering process of pumping water or putting a layer of glass beads on the surface of the snow, and see, these are something new techniques which are reduced, so that and also seawater, thin layer of seawater putting on the sea ice. See, new technologies are coming, new offsetting regimes are coming, new mangrove plantations are coming. See, the Australian Coastal Studies Group, and which Dr. Saurav is representing and he is leading, has a wonderful action plan for mangrove conservation. So you see, through mangrove conservation and your other algal culture and algal propagation, you can conserve large billions of tons of carbon you can save. And see, your oceans are 35 or more than 335 billion tons of carbon it can store. But beyond the 35 or 40,000 billions of carbon, where does this carbon go? It gets ultimately released. Your plant is always in the state of photosynthesis. During the photosynthesis, what happens? It releases. You see, precipitation happens, it releases a lot of carbon dioxide. And also what happens is this carbon dioxide, it can absorb to a certain extent. Oceans can absorb, plants can absorb. Your carbon can be stored below ground, above ground, and trees and plants and oceans, the algae gets absorbed. So culturing seaweeds, culturing plants, propagating different kinds of algae, so enhancing the health of the ocean. Enhancing the health of the ocean to do the scientific temper, scientific inculcation, scientific temper, and the inclusivity for healthy oceans is very, very important. And what we would say that, and we could see that creating a strongly protected areas, at least 30% of our lands and waters have to be protected. At least we have to look out for 2030 or 2040, and we have to have best of science to create such a situation, so that all our services, what we offer to the mankind, maybe it could be in the form of your provisioning services, it could be in the form of your regulating services, or it could be in the form of your supporting services, or it could be in the form of cultural services. We have several kinds of carbon assimilation and fixing processes or offsetting trends. And you have a scenario in the world is changing where you are going to transfer to the good offsetting action. You're going to transfer the institutions are going to get the credit for it. And this is an era of credit transfer. And this credit has to be seriously considered because, see, everything, the environment is changing. Your oceans are a symbol of growth and symbol of health of the global community. And your oceans are rapidly also influenced by the huge nourishment because of oligotrophy is also a major issue. Climatic change related to the El Nino and the physical settings are grossly transforming because you see El Nino, you had a couple of years triple La Nina. This seriously affected the Maldivian mangroves, and you have great die-off phenomenon in these islands. You see, our Indian mangroves also are recurrently facing this die-off issues. But how much we have pondered and looked, you see about 40% of Sundarbans forests, the mangrove forests of the Mongals are situated in India. They have almost 70% in the Bangladesh. Even though we do a lot of research and scientific activity in the mangroves of Sundarbans, you see how much of the tribal population, the local population, the societies are getting enhanced, and how much of them get the benefits from the Sundarbans. You see, I looked into Sundarbans many years back, and now very recently when I looked up, you see how much of transformation Sundarbans has gone up. Inclusive, I'm not looking at the plans or even at the people's participation in the economy of Sundarbans. You see, it is a value addition system. It's a value-based system. A lot of stakeholders are there. I would say there are a lot of organisms. There is very rare, and alligators are there. There are very rare kind of mammals are there. Snakes are there. It's one of the repositories and cradles of civilization, which I would say Sundarbans. It is one of the most protected sites under the UN heritage sites. So you see, and Saurav representing this institution at Sundarbans is doing a yeoman service through his action plans at Sundarbans. So this model, where Sundarbans, and I would tell my colleagues who are online attending to this wonderful session of World Ocean Day today, I would install all of my colleagues to visit Sundarbans, because what you can do for protecting Sundarbans is protecting the world oceans. Don't think what you receive in the Ganges, what you receive from the Brahmaputra, what you receive from the Yamuna, what you receive from the other Hooghly, all these are nourished by your Ilsa, by your other fishes, all nourished and nurtured in the Sundarbans. You see, so Sundarbans is a way of life. All your estuarine systems are a way of life. So the life-sustaining ecosystems, these wetlands are global hotspots or cradles of biodiversity, cradles of, I would say, the biogeochemical processes. So when this is hampered, when the food chain is hampered, the ecosystem greatly transform. And this largely affects the ocean systems. You have, in turn, all cyclical events which is going to affect or harm the ocean systems. Your production, the primary productivity, the secondary productivity, the fishery production, all in turn seriously affecting, and you have top-down phenomenon instead bottom-up phenomenon really standing up to the top-down phenomenon, which is routine. Your food webs are altered. Your systems are in. So largely, I would say the climate phenomenon, as well as the global scourge or global curse of plastics and other marine litter, is one of the greatest threats humanity is facing. And this World Ocean Day, I will greatly extol or call upon all my colleagues, and that we need to devise new techniques, new solutions and we should create over and above the scientific temper, and the need of the hour is scientific value and the awareness to the global community, and not only in India, the globe. And I'm extremely happy that my colleagues who are presenting today's talk will really come out with fruitful suggestions for the protection of the oceans and the community at large who are depending the oceans for the sustenance. And have a great day, and wish to see you, Dr. Saurav, with a great message for the day. Thank you so much.
On behalf of the foundation, thank you so much, sir, for taking out the time. Extremely busy.
Your audio is muted, I think, Saurav. I can't hear you.
One thing I really like to know, and since a lot of the people here are from India, the young people, that you have journey in this scenario.
Can't hear you.
Saurav, you are not audible.
Yeah, I can hear you now. Now I
So
can hear.
I said that, sir, you have journeyed the Indian scenario for last 2 decades, and you are kind of championing our country. So how you think that the young people are they more motivated these days? You feel like the World Ocean Day, the people are getting more engaged, and this is creating a wave in the country also as the days are
Yeah.
progressing.
No, what I would say, Dr. Saurav, is they are motivated, they are getting inspired, they're getting to the knowledge framework. But what I see is the translation to action plans and new innovations and new thinking is not coming. That's what I just said, in the Arctic, very recent studies by the Dutch and the American group has come out with geoengineering technologies. You see, we need to have our own solutions. We have a lot of native technologies and traditional knowledge systems, especially in Sundarbans. I don't need to go to the Arctic. They are motivated. They are getting enthused by our talk or our societal or scientific temper initiating activities. But what I see is the coming to the ground level. You see the increasing of burning activity or the heavy increase of marine litter is increasing. Today you have the global the beach cleanup program happening all over the India today. Many of my colleagues are in the coastal segments in different places, collecting and grabbing with the litter. But do you have, India has to develop, I think the Indian scenario, you have institutions like yours, other than encouraging and motivating the youngsters and the seniors, what I would also say that they need to create action plans, so that it goes to the ground level. That is still lacking. Other than we discuss a lot, but translating to action plans and technologies. You see, that's why how you're going to regulate your carbon fixing, your offsetting measures, and how it's going to get translated to credits. And these are measurements which are going to be done. These are going to be check factors for the enhancement and the health. That's why I said it's going to get translated to the Human Development Index. And this kind of translation is seriously, they are motivated, they are aware, they know their situation, but actions are not really in place fully to the core. It's
But we will look up to you, sir. We will look up to you. You are inspiring us and many people in across India. So thanks on behalf of the foundation, sir, to be present and guiding us through. Please, in the due course of time, you remain with us, like if your time permits, and yeah, you are a pillar of this foundation. And I believe a lot of the young people looking up to this particular webinar, sir is always there to help young people. Just like me, one day I remember I met sir in one of the conference, and I said like, sir, I have some plans for the estuaries, and yes, being new to the India at that time because of my educational background, he has never shied to give me the proper advice and the channelizing me in a right direction. Thank you so much, sir. Thank you. It's a pleasure to have you with us. The next, I can just I request Ms. Devarati Sengupta. She is the ECOP session coordinator. So as a part of our commitment, sir, we are hosting a dedicated session for early career ocean professionals for giving them the platform to engage with the larger audience. So this is the session that is coming now. And for the time being, thank you, sir. Thank you very much.
Thank you so much. Thank you, sir. All the best.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
कैसे है ये लड़का यार सच में देख मत दीदी लगवा दी जोर से
Associated Biogeochemistry in the Eastern Arabian Sea, EAS. He was a NF Pogo Center of Excellence Scholar in 2016 to 17, has participated in 20 oceanographic cruises, published 29 research articles in international peer-reviewed journals, and currently works as a technical officer at the Central University of Kerala. Dr. Sudhesh is an associate editor of Frontiers in Marine Science Biogeochemistry, a core committee member of the Early Career Scientist Network, ECSN of IIOE2, a governing council member of the Ocean Society of India, OSI, and joint secretary of the Swadeshi Science Movement, SSM Kerala. Dr. Sudhesh, a very warm welcome to you. And the floor is all yours, so you can start. You have 10 minutes for your presentation, followed by 5 minutes for discussion. Thank you so much.
Thank you, Debarati. Hope can you tell me? You can hear me, right?
Yeah, you're audible.
So slides are visible.
Yeah, it is.
Okay, let me. First of all, I thank Dr. Saurabh Paul for inviting me for this wonderful webinar talk. And also I thank Jimli Mandal who contacted me first for the same. So today, as you know, we are celebrating the ocean, like the World Ocean Day. So there is a lot of presentation as we already mentioned. I'm going to discuss about mostly based on the observation field studies about the biogeochemical response to seasonal oxygen deficiency in the Eastern Arabian Sea. So in this talk, I will talk a little bit about the oxygen, or the general introduction, and the oxygen, then oxygen minimum zone, and the characteristics of oxygen minimum zone, especially in the Eastern Arabian Sea, where my study is mostly focused on. Hope the slides are like moving, all right? Could you please confirm?
Yes.
Okay, thank you. So we know there is a lot of oxygen in our planet, and it is the third most abundant element in the universe. And the most of oxygen is bound to the rock or soil. And
sorry to interrupt.
Sorry.
We are only seeing your introduction slide.
Oh, sorry.
I think it's not moving.
It's fine.
No.
So can I do like this?
Yeah, now it's moving.
Okay. So we know there is a lot of oxygen present in the Earth crust, and then most of the oxygen and bound to soil or rock and or the water, and very little oxygen is available in the free form. And we know the free oxygen is highly reactive. And if you consider ocean, it is it produces almost 50% of oxygen for the living organisms generally by the phytoplankton. And if you see the sources and sink, we know of course there is an exchange of ocean and atmosphere, atmosphere boundary. There's an oxygen exchange between the ocean atmosphere boundary. Then the solubility is one of the other factor. It's a function of temperature and salinity. The oxygen solubility depends on temperature and salinity in the ocean. Then photosynthesis, that is one of the most important production pathway of oxygen in the ocean. Then respiration that consumes oxygen, and there are different dynamic properties like horizontal adduction, then mesoscaleus. There are many different physical mechanisms that also affects the oxygen gradient across the ocean. So if you see the typical vertical profiles of respired element, that means we know the surface ocean, all the phytoplankton are forming like the carbohydrate. They are the planktonic organic matter. The organic matter formed in the surface ocean. It after certain period of certain days, it get decayed and it decomposes in the middle of the water column. So if you see the typical profiles of, for example, oxygen, then carbon dioxide and other nutrient. Oxygen, you can see high concentration of oxygen. You can always see in the surface layer. Then if you go down to the if you see the vertical profiles, it is getting keep on consuming in the mid depth, and there then again the consumption is less in the bottom depth after 2 to 3 kilometers after the vertical. If you see the vertical extent, and you can see the oxygen minimum zone in the mid depth. That means there is a consumption of oxygen. Is largely the biological organism consumes oxygen in the mid depth, and where when the mostly the we call the respiration happens in the mid depth. So when the phytoplankton get respired, it produces the carbon dioxide, and again it regenerates the nutrients. That is why the typical profiles of these elements happening in the ocean. So if you see the oxygen minimum zone, that means the minimum of oxygen, the mid depth. So the perennial oxygen minimum zone always occurs at the mid depth. That means the 101,500 meters in the open ocean region. That this oxygen minimum zone all are present in the Pacific, Indian Ocean, Atlantic, all over the world. So today's talk, I am mostly concentrating on the Indian Ocean, especially in the Arabian Sea. So my study is mostly focused on the eastern part. Why it is so? Because it is one of the most interesting part in terms of oxygen minimum zone. Because as per the study, there is a understanding that there is a eastwards maintenance of intense oxygen minimum zone in the eastern Arabian Sea. And if you see the bioargos, that is the most one of the greatest data set now we are getting mostly used for the World Ocean Atlas, the updation of World Ocean Atlas and all. And if you see the bioargo floors, there is no bioargo falling in the east, within the ECSF of Eastern Arabian Sea or the Western Indian Shelf. So, as a part of the marine ecosystem dynamics of Eastern Arabian Sea MIDAS project under the umbrella of Ministry of Earth Sciences, we have collected 10 repeated observations across the Eastern Arabian Sea between December 2017 and 29. That means within a 13 month, we conducted 10 repeated observations from the around 2 degree to south, 8 degree north. 8 degree north to 22 degree north. So in this presentation, I will mostly concentrate on the oxygen minimum zone, its dynamics, and how it affects the entire shelf. So this is the oxygen profiles. The oxygen profiles collected using a cyber sensor, and if you see the southern region, as that means here the Cape region, 6 degree north, you can see the oxygen minimum zone extending between near 110 to near 650 meter water depth. Then if you see across, if you see from south to north, you can see the oxygen minimum zone that we taken as 20 micromole oxygen in the water column. So if you see the extension of oxygen, the oxygen minimum zone extending from south to north. For example, in the south it extended up to 6,650 meters, and the south you can see up to 1,350 meter, the northern part. So what is happening to this oxygen minimum zone during the season? With respect to season, you see there's a one of the main process that control the oxygen minimum zone is a upwelling. So what is happening in the upwelling? This low oxygen minimum zone waters upwell to the surface oceans, also to the shelf regions. So these low oxygen minimum zones, once if you see the dynamics, you can see the January, it is in the shelf waters. This observation is from January to December in the shelf waters of Eastern Arabian Sea. You can see the red patches, it is the minimum oxygen levels. You can see in the shelf tree, it is slowly get uplifted vertically as well as horizontally. Then by March, April, May, by May, you can see the entire bottom waters of shelf region highly depleted in oxygen. You can see the red patches. and that is extending again progressing in June, July, and September. You can see the intense oxygen minimum zone we always see in the during the September months. Then again, October, there's a withdrawal of upwelling process. You can see by November and December, the entire water column is always, it get oxygenated because of the withdrawal of upwelling. So what is happening in the bottom layers? You can see across the Eastern Arabian Sea part, the oxygen minimum zone. You can see the May, June, and August, September. This August and September, the peak filling period. You can see the red patches is extending across the Eastern Arabian Sea. So even if you see the central part, north and southern part, you can see there's a highly oxygenated, oxygen depleted waters in the middle of the Eastern Arabian Sea. That means if you see, remember the this profile, you can see the this center part, the oxygen minimum zone have very intense, like in almost like less than 5 micromole oxygen waters. It is extending to the central part, and because of that, there is a high, and plus there is a biogeochemical or the biological properties also make the low oxygen waters into intense oxygen depletion in the Eastern Arabian Sea. So it is not what will happen when the low oxygen waters extend to the shelf waters. You can see the dissolved oxygen is from January to March, January to December. The time series observation, you can see the low oxygen waters, the red patches, and there's a decrease in pH as well. When the pH decrease, there's a high carbon concentration of carbon dioxide is also we are seeing. So that means it is not only oxygen but also low pH and high carbon dioxide waters is extending to the shelf waters during the hypoxic period or during summer monsoon when upwelling prevailed over the shelf. So it affects the calcite and aragonite saturation level. You can see the calcite and aragonite saturation levels. It is 4.8 or something during the January to March period, and it reaches up to 2.4 or less than 2. The calcite saturation level 2.4, and aragonite saturation levels it is less than 1.5 during the summer monsoon period when there is a intense oxygenation and acidification, I could say, because the low pH waters enter onto the shelf waters. So it also affects the greenhouse gases. So you can see what will happen when there is a low oxygen condition. It trigger the denitrification process. That means it trigger there is no oxygen. It go for alternative oxygen pathways. That means it takes oxygen from the nitrate or the nitrogen species. Then the NO3 become NO2, then to NO, and then it to become N2O. That is one of the potential greenhouse gases. So it impact when there is a low oxygen levels. It trigger the denitrification process. So there is a high influx of nitrous oxide we could see in the Eastern Arabian Sea shelf when there is a seasonal anoxia. At the time, it is not only the nitrous oxide. We could see high efflux of carbon dioxide during the seasonal anoxic events, though there's a high production in the surface waters, but it also, because surface high production, it take the carbon dioxide, but when there's a low oxygen condition, there's a high efflux of carbon dioxide as well. So the Arabian Sea is always, when, especially during the upwelling period, it is a very huge source of carbon dioxide as well as nitrous oxide to the atmosphere. So you can see the flux. It is very high during the May to September period, especially the carbon dioxide and nitrous oxide. But we could see there's a reduction in methane during the high intense oxygen depleted period. So you can see, especially during the highly oxygen depleted period, we could see there's a benthic fauna, especially you can see the benthic fauna, the benthic diversity, especially the macrobunthus getting diminished because of the low oxygen condition, and that affect the bioturbation and bioirrigation process. And because of that, the sedimentary methane is not getting to the water column, and it impact the methane efflux from the sediment. That is one of the major source of methane in the shelf waters. So because of that, because of the absence of benthic fauna or absence of macro benthic fauna organisms, there is a low efflux of methane is happening in the Eastern Arabian Sea shelf. Not only that, there's a because of the methane high nitrite content because of the denitrification. We could also see there's a nitrite dependent methane oxidation or the iron or manganese dependent, the metal dependent methane oxidation is also happening during the anoxic period. So we could say when there is a high efflux of nitrous oxide and carbon dioxide during the summer monsoon period, at the same time we could see a low methane oxidation, low methane concentration compared to the other season, because other season we could see a very high methane concentration in the during the anoxic period especially. Of course, the oxygen, low oxygen waters are affecting the benthic organism and all other living organisms, especially fishes and all. You can see the fish kills also happening during the seasonal anoxic events. What is happening is when there is a low oxygen waters completely filled in the bottom layers, all the fishes is getting transported or getting escaped to the surface layers in the coastal region. So it is sometimes this anoxic waters, it is just below 5 meters. You could see the hypoxic waters and entire the fish, it is only segregated within the 5 or 10 meter the surface layers. So it getting transported, it get trapped in the waves, and it is getting that when to get trapped in the waves and shoaled, it washed out to the coastal region. So we always see during the month, especially during the monsoon period, we could see a fish kills happening in this part. So that means it is not only the oxygen, it is one of the important parameter for the biogeochemical as well as the biological part. So it kills the biology and it trigger the different kind of potential greenhouse gases like nitrous oxide, and the carbon dioxide. So this is the a picture of biogeochemical control of the biological and biogeochemical process happening over the Eastern Arabian Sea shelf during the when there is a seasonal anoxic events. This I am stopping here. If there's any doubt, you are welcome to ask. Thank you.
Thank you so much, Dr. Subhesh. If anyone wants to ask anything, they can just unmute and ask him. Also, you are welcome to put your queries in the chat box so I can help with that question.
Hi, Suresh.
Hi,
Dr. Amit can go ahead. Dr. Amit, go.
I have one small question about this methane loss. So this methane oxidation by the nitrate or the nitrite during the anoxia, have you done any experiment on that, like by spiking methane and?
We did not do an experiment, but when it's correlate we could see some signals. For example, if you see the methane and nitrite and the correlation between methane and nitrate and the methane and nitrous oxide, you could see when there is a low methane and for example low nitrous oxide during the anoxic condition, this especially the very near shore, when we could see the sulfide condition, we always seeing a very low methane concentration in an anoxic condition when there is a sulfide formation. But it depends highly on the very within suboxia or anoxia, you could see there is big change. When there is a suboxia, we could see a high methane concentration, but when it turned to sulfide condition, there's a kind of situation happen. But I also observe some of your studies as well in the Goa region, you did not find kind of nitrate dependent oxidation, but in the southern part we speculate there is a dependent oxidation process as well. But it mostly controlled like a Bundik by the Bundik bioturbation effect, because of the low macrofaunal abundance.
Oh, yeah. Okay. So it's mostly connected to the benthic epifaunal community. So actually, just tell you what, we did an experiment in 2011, and where I spiked a labeled methane and also with a labeled nitrite, and we didn't see any methane dependent denitrification kind of stuff. So there's so that's why I was asking this.
Thank you. Like another important thing, recently we could see in the Benthic abundance, what we observed is especially during the monsoon period, the Benthic microorganisms, it is highly it is very less. The most of the microorganisms are completely absent sometimes, and then after September, October, November, and December. After December, we are seeing the active Benthic organisms, and we found especially in the very near shore region, we found there's after the active this active what I could say role of the Benthic organism when they twitch it in an active form, we found a high methane source, methane efflux concentration. So we suspect mostly because of this particular Benthic organism, but we also, especially in the sediment, we expect such coupled biogeochemical mechanism as well, because the methane, it is getting transported from sediment layer to water column. So it is getting more time within the sediment layer. So when there is an anoxic condition, of course, there are all this kind of metal oxidation or endamo process may happen. But still, we need a more Benthic chamber experiment or something from the coastal region.
So it is the effect of dual effect of anoxia plus the acidification during the southwest monsoon, that absence of the faunal community.
Exactly. It is not only the anoxia, but the acidification is also one of the most important part. Many of them won't talk about, because there is very little data about the pH measurements from the coastal region of our shelf. Because we have only a seasonal data, but there is a continuous information is very little. We doesn't have that much comprehensive information. So it is not only the anoxia, but it a combined influence of acidification as well as the anoxic, the oxygen deficiency. So I'm writing a paper on that, how it affect. But the problem is we have only 1 year observation. Then after that we don't have. So we need a continuous observation. But of course, National Institute of Oceanography, they have a long-term observation since 1997 in the as part of control time series, I hope.
Yeah, also there, we have mostly focused on the deoxygenation thing, rather concentrating on the CO2 thing. So that's something really new, and it's really important.
Yeah, of course.
Yeah. Okay, it's wonderful. Yeah, wonderful listening to your work. Have a good day.
Thank you.
Next, I think Dr. Sabyasachi is raising his hand. So yes, sir, you can ask.
Yeah. Hi, Sudesh.
Hello.
Yeah, it's a nice talk actually. It's pretty interesting for my subject area, and I work on benthos. And basically, what you are talking, it's a kind of true also. But the issue is that while I was studying through this Western Indian continental merging, since the 9 degree south to 21 degree north, so throughout the margin, I also got, sometimes it's a low, but I can't say that in oxygen minimum zone, where I also observed in 900 meter depth, there is a very low oxygen, like you can say 0.04 ml per liter. So in that area also we got very high abundance of nematodes and other microfaunal community. So in that case, so if you have seen, they are especially as a benthic ecologist, I can say they have very good capability to go inside the movement inside the sediments, like you can say the bioturbations process is happening. It is not that process is not happening, process is happening. And so we got the proof of the holes in the sediments. When you got collected the multi-core samples, we have observed there are various kind of holes in the sediment. So it suggests that maybe the methane's output also, I discussed with some geochemists at our NIO. They also suggest, I was surprised that it is a the whole by this our benthic community, but then we measured the whole, the width of the hole. It is not exactly the community. They said that could be the gaseous exchange of the like methane or any other kind of gases. So I think we need to go for further detail of the study, whether this benthic community playing not a good role in that, means like you are saying that very less community observed in that area, or maybe the other thing happening in that area. So that need to be studied further actually.
Can I comment on that?
Yeah, please.
If you see the shelf as well as the shelf break or the shelf break, the dynamic or the benthic community changes is completely different. If you see the shelf, you can see the biogeochemistry is completely changing because of during the season mainly. So if you see, for example, 900-meter water depth, you can see the oxygen concentration over the year, it is changing very little. But if you see the shelf region, especially in the near shore environment, or like in the within the inner shell of up to the 50-meter continental shelf, you can see seasonally there is a disturbance. So, but offshore or the shelf break or something, there is the such kind of biogeochemical, the oxygen disturbance is little less compared to the shelf. But shelf, there is a large kind of like a disturbance. For example, if you see the completely oxic period from January, February, March, April, sometimes up to May, then again October, November, December. So almost 7 months, it is completely oxic, and during this particular period, they are very active. But when there's a low oxygen condition, they try to escape out because they are not like really because there is a stress for them. So when there is a stress, they are used to escape.
No, actually, they don't move actually. The benthic communities are very little and they can't go, because you're talking about the seasonal hypoxia or seasonal oxygen minimum zone expansion in that region. And also I got the data from 20 meter to 4,500 meter all through the trajects, like in southern, middle, then western continental margin, like of Mumbai, of Gujarat, even of Kerala. So the changes is not that much in the benthic abundances. So I was also first, I analyzed one project. There was a like issues. Yeah, some adaptation strategies are there. They are very abundant. The diversity is not very well, but the dominance is pretty well. So in that case, also we are looking about their functionality. When we look the functionality, they have the burying capabilities in that region. So the burying capability hypothesis is not that way in the true, I could say. That it is not there, it is there actually, but maybe I also do not know about the biochemistry or the geochemistry in that region properly, but at the benthic community perspective, I could say yes, there is a abundance.
So if you see this particular slide, you can see that depends on the oxygen condition. So it is not always like a hypoxia. So sometimes it will go like below hypoxia. Hypoxia itself like a wide range. It is something like a people tell up to 64 micromole, below 64 for 3 micromole hypoxia. So people will tell 20 micromole is also hypoxia. But if you say like go suboxic or anoxic condition, it is highly kind of trouble for them. And that's what our data from CMLR, it is published in Professional Oceanography, also shows like the high kind of echinoderm and all, like it highly depends on the pH condition as well. So that kind of organism, that's the most like, of course, I do agree. There's a benthic organism like some of the polychaeta and all, they are opportunity species. They could survive within the low oxygen conditions. But some of the very active bioturbation organisms, they go like from that, or sometimes they die as well. So of course, like that depends on, because there is a threshold for each organisms. So that we need to find out which organisms thrives in particular, for example, that concentration, or which is the threshold for the other organisms. For that, we need
that is correct. That is correct. It's true. Nice presentation, Shwet. Thank you.
Thanks to both of you, and thank you, Dr. Sudesh, again for joining. We are moving to our next, that is speaker 2. And before that, I just want to give 2 mini announcement. One, that is we are already hitting 112 participants, which is huge. And I think that's the inspiration for World Ocean Day. And next thing is, please don't feel shy. And if you have, because I think still there was like few people who were raising their hands. So if you have any question, put it in the chat box. We'll try to reach, and even if not now, because we are running late, but after all the presentations, definitely. So our next speaker, I'm glad to introduce Dr. Bishwajit Roy. Dr. Bishwajit is an organic biogeochemist and sedimentologist with an expertise in stable isotopes. He has completed his BSc in geology from Durgapur Government College in 2013, and then joined ISER Kolkata to pursue integrated MS PhD in geological sciences. Bishwajit completed his PhD from ISER Calcutta in 2020. He joined IIT Gandhinagar in 2021 as senior research staff under Early Career Fellowship. And after a stay of 1.5 years, he recently joined National Center for Polar and Ocean in CPOR, Goa in 2023 as DST Inspire faculty and a visiting research at University of Kiel, Germany. Bishwajit has received several awards from national and international forums, of which the DST Inspire Award is one of them. He has published in 10 reputed international geochemistry journals, showcasing his research persistence in the field of organic geochemistry. Bishwajit has also been part of Indian Arctic Expedition 2023 and 2024. Welcome to you, Dr. Bishwajit Roy. Are you there?
Yeah, I'm audible to you guys?
Yeah, you're audible. Thank you so much. You can start.
I think my slide is visible to you all.
Yes.
Yeah. Okay. Thank you, ECSF team, for this beautiful introduction. And I'm very much obliged that we are speaking about today about catalyzing oceans and climate action, so which is in this international webinar. So I belong to an institute, it's National Center for Polar and Ocean Research, and we deal with mostly related to polar sciences and related to scientific issues that can impact the modern and also in the past system. So we have our presence in the Antarctica region in the form of 2 stations, Maitri and Bharti, and also in the Arctic region in the Himadri, and also in the Himalayas as Himans. So we will be, as Professor Vijay has correctly pointed out, that we need to identify several solutions to mitigate the climate change. And we know that the macroalgae, as he pointed out, the algal communities could be one of the major contributors to that. So through this talk, we will be seeing how we can, what is the fate of their biomass when they come or accumulated in the sediments. Do we have a potential of higher carbon storage through their usage or not? So before I start, so you can see that the global map clearly that we have a quite warming scenario in the northern polar region or the Arctic Circle region quite adversely, and this is warming at a very exponential rate compared to that of the other parts of the globe. Now, what we see as a respect of that, we see that because of this increased temperature, we are seeing a significant drawdown of the Arctic sea ice for the last few decades, and this decrease in the sea ice have allowed the entry of this marine in the marine system a huge amount of terrestrial contribution in the form of suspended load, as you can see here. And because of this extensive coastline of the fjord system in this Arctic region, what we are seeing is that there is a significant drawdown of the phytoplanktonic productivity because of increase in turbidity in this coastline region. So so that has a negative feedback to our system, impacting the carbon storage that was happening in this fjord. But with respect to that, what we are seeing in return to the increasing temperature is that we are also seeing a significant increase in the macroalgal presence in the Arctic region. As you can see, these red dots clearly indicate that the coastal regions are dominated by the macroalgal biomass. And what is the importance of this macroalgal biomass is that they are very good in storing of carbon, and they grow at a very faster rate, and they are usually accommodated in the high turbid conditions. So and their presence are also there in the Arctic region, even when we have 6 months of day and 6 months of night lights present there. So we can clearly see that they have a good biomass increase that is happening in the Arctic region, and that is what is also been contributed or been done by several funding agencies like India and also in abroad, where significant amount of carbon storage importance has been given. But the scenario is whether the carbon that is produced by the macroalgae it's significantly stored, or if there is some other process related to this. So for that reason, what we try to understand is how the carbon gets transported. So how the matter transported from one region to other. So as I mentioned, this macroalgae grow mostly in the shallow marine region or the coastal region. If you look closely, the macroalgae are divided into major three types: the green, the brown, and the red algae. What makes them different from the other organic fractions is that they have a specific features which we known as the gas bladder, and that actually helps this macroalgal community or the detritus of this macroalgal community to transport for a larger distance and get assimilated in the sediments for a longer period of time. So it has been estimated through several simulation models that around 200 million tons of carbon can get stored by this process, and that can be equivalent to annual emission of New York. So that makes us a very good estimation and makes us to study that it could be a very good carbon storage potential. But all these are estimation based on similar simulation models and all, but there are no realistic study to find it out. And for that reason, what we did, we actually chose an area in the Svalbard, as I mentioned, the Arctic region, where we have a station. We have a station in the New Alisand region. As you can see, this is the fjord system, and as you can see also in this figure, a lot of terrestrial, this debris are coming in this area, whereas several various studies have also shown on the left side image, as you can see, the presence of macroalgal bloom that is being there for the last few decades, and it has spreaded all across the coastline of the Kongsfjord. So what we did initially is that we tried to understand that how the transport is actually happening. So what we found out is that there is a prevalent signature of the marine macroalgae that is present almost to 3,500 meters depth. So that means some churning or some modification is actually happening within this coastal region that is triggering to such distribution happening or storage in those deeper sediments. So what we found is that through several studies that there is presence of significant macroalgal detritus all across the coastline, and that is mostly being done by the wave and also the ice covering actions that spreaded this fractions or the macroalgal fraction into a smaller fraction of it to get assimilated in different fractions. So when we see the organic fraction, what are the organic constituents within the macroalgae, similar to that of other, primary producers, we have a significant amount of carbohydrate that is present compared to that of proteins and lipids. When several micro or decomposition experiments have been done, they have found that almost 40 to 44% of carbon gets off within few months. So this clearly raises a question that whether there is significant, storing is happening once the degradation takes place. So what we did, we actually chose two different extent of molecules. So we took carbohydrate, which are pretty simple sugars, and it's taken up by microorganisms quite easily, and lipids, which are as a form, as you can see, they have very quite stable structures of hydrocarbon, and they are thought to remain in the system for a longer period of time. And these lipids of the carbohydrates are the structural and the storage components of the macroalgal biomass. So when we try to see how the behavior is there across the water column, we found that we are getting a huge amount of carbohydrate that are present on the top surface or top water surface, but as we move down the water column, we don't see the presence of the carbohydrate to be that significant, and that abundance reduces to a greater extent. Whereas it's opposite for the lipids. For the lipids, we see that a significant amount of lipids that are present down the water column. So that clearly indicates that there is a significant differences between the presence of different organic fractions like the carbohydrate and the lipids that is happening in the water column where the macroalgae communities are dominating. So does that mean that the lipids are doing best in those areas? So what we did as a second step, we also collected the lipids from the macroalgae presence out there, and we found that they are mostly comprised of the fatty acid, as you can see on the right side. And as the brown macroalgae are the most dominated biomass in that Arctic fjord, we found that their biomass is also getting reflected in the lipid fraction. So you can see clearly that all the fatty acids productions are pretty high. So we are now confirmed what the signatures of the biomolecules are there in the fatty acids. Now, when we did try to see that in the sediment, so when we collected the sediment across the fjord, we found that okay, my storage of the fatty acids, the saturated fatty acids are quite high across the fjord system. So that easily helps us, okay, there is a storage of lipids that is happening. But when we try to see the other forms of fatty acid, we see that the polyunsaturated or the monounsaturated fatty acid, there we see a significant drop of the concentration while we are checking the sediment. So we try to identify what could be the triggering factor for that. And we found out that wherever we are seeing a significant increase in this type of degraded or churned fraction of algal matter present, we found there is a significant presence of microbial biomass or microbial induced biomolecules that are present in those sediments. So with this note, we also came to know that this storage that we thought of a straightforward notion is not true. Even though the lipids, which are known to be very stable or not degraded by organisms, are being degraded quite easily within this fjord system. So that innovates our straight notion of carbon storage that could be driven by the macroalgal biomass. So with that note, it brings us to the these are our take-home messages. We came to know that okay, the warming is happening, so that can lead to a significant increase in the macroalgal presence in the Arctic fjord. We also came to know that this direct notion of this blue carbon storage or how they can impact the sediment storage of carbon for a longer period of time, it's really challenging. And we also found out that the lipids, both the saturated and the unsaturated forms are also getting affected by the microbial reworking processes. So yeah, I'm very much thankful to my collaborators and also my institute and the lab, organic immunochemistry lab that we are developing at NCPR. And I'm also thankful to my student, Mayuri, who has done this most of the work. And yeah, that's all for this talk, and I'm happy to answer your question. Thank you.
Thank you so much for your enriching talk, Dr. Vishwajit. And yeah, we are open for discussion. So anyone? I think Dr. Paul, he told me. So yeah, Dr. Paul, you can ask him.
Hello, Vishwajit.
Hello, Vishwajit.
Yes.
I first of all must thank you regarding all the bindings of your family and the very urgent medical attention that you have agreed to present us, and you have to rush from here, I know.
Yes.
I just have a very short, sharp question.
Yes.
You studied in the fjords, right?
Yep. Yes.
Okay. So this is itself is a unique opportunity. I get to see fjords, help people, but I didn't study myself personally. Many of us actually even do not recognize that the fjords are estuaries. Sorry?
Yeah, you carry on.
Yeah. Just to hear a lot of the audience is a young people. They are young people. If they want to study the polar region, okay,
Yes.
they are not necessarily marine scientists. They could be from very different subjects who may not even associate themselves with the marine science. Okay.
Yes.
What would be your like a short, sharp advice as a young researcher, how they can pursue a career also in sort of polar science? Thank you.
Yeah, that's a very, very, I think this is what demanding at this need, or you can see the need of the hour right now. See, what we found are the problems that we face. You can come from any engineering background or any arts background or any background. What we feel the problem is there's a holistic approach to this problem. See, as a sedimentologist, as an organic geochemist, I always see things as a perspective of an organic geochemist. But when a biologist comes into play, they can tell us or they can help us to understand what they know about those species or how their existence happens under that extreme condition. So it's not related to polar region, but also you can employ this similar information also across the Indian subcontinent. As you know, that huge amount of money is also been given by government agencies and to find out solution for carbon storage. So you can employ your biological perspective, your chemistry perspective, or a physics perspective to give you a new dimension of understanding a system, because this earth science or this whole geology process is also a mixture of all different components. So if you can come up with this little contribution from your side, like it can be a basic, as I mentioned, a carbohydrate. I'm just speculating things on the basis of observation, but you can add on a cherry on the top of it by adding this is an additional step that was happening in between it, which can lead to that signal that you're getting in the sediments. So that is what the need of the hour is, and where I think we are lacking behind. And definitely, I'm always open for this discussion that any students or any faculty members or anyone can come and discuss among us in this new venture that we are having right now. Yeah.
Thank you, Vishwajit. Thank you very much for participating in the platform.
Thank you.
Over to Debarati.
Thank you. Anyone else? Perhaps not yet. So yeah, thank you so much.
Thank you. Thank you so much.
Yeah. So yeah, it was really a nice presentation, I think, and that's how things are evolving. From there to our next speaker, Dr. Sri Lakshmi. She is our next speaker. Not only speaker, I would really emphasize on the word that is one of the women presenter for today, and that's also kind of a special thing for all girls here. So Dr. Sri Lakshmi, a marine biologist working as a postdoctoral researcher at the Department of Marine Biology, Microbiology and Biochemistry, CUSAT. Her focus lies in marine ecology, particularly mangrove ecology, and she serves as a scientific consultant for several national and international organizations. She is the recipient of the prestigious Kairali Research Award 2020 by the Kerala state government and has authored 18 publications along with 2 books. Welcome, Dr. Sri Lakshmi, and the stage is yours.
inverted comma এখানে ব্র্যাকেটে তোমার এটা লিখে লেখা যায় কি তোমার হোয়াটসঅ্যাপে লেখা যায় না তুমি লিখো যে ব্র্যাকেট অফ ইটালিক
Are you here?
Impact of cyclone inverted
Thank you.
Yes. You can carry on.
Okay.
On the at Historian and Coastal Studies Foundation on the topic this is certified by Dr. Shodat for the ECSF has delivered an invited lecture on Italic impact of cyclone inverted comma closed on the occasion. Oh no, on the occasion.
Sorry, there is some technical issues. Sorry. Is it up? You can see my slides?
Yes, it's visible.
Yes. And thank you. Thank you, Dr. Saurabh Paul, for the invitation. And today in this World Ocean Day, I'm going to present how do mangroves fit into the ocean solutions. And you may not consider mangroves as part of the ocean, as these mangroves are coastal wetlands seen in the interface of the land and sea in tropical and subtropical coast. And these mangroves have several unique aspects like high species diversity, high biomass production, and high standing crop. And they're also known as the blue carbon forests of the ocean, coastal woodlands, tidal forest, and oceanic rainforest. And as we all know, these mangroves are providing several ecosystem services like coastal protection, tourism. They're supporting fisheries. They are regulating the climate, and the carbon storage potential of mangroves is 3 to 5 times higher than that of the tropical rainforest. So, without mangroves, the ocean would be a much emptier place. So when we look into the economic evaluation, and these mangroves reduce annual flooding globally by more than 39% for 18 million people, and they reduce annual property damage by more than 16%, and the value of coastal ecosystem services in terms of nursery and habitat for fishes, then contaminant reduction, then carbon sequestration, all these ecosystems ranging from 100 to 10,000 US dollar per acre. And a recent report by the high-level panel, this high-level panel is a group of representatives from 14 countries across the world dedicated for the protection and sustainable use of ocean. And the recent report entitled Ocean Solutions that Benefit People, Nature, and the Economy. And this report clearly addresses how the ocean and its ecosystem, including mangroves, are underutilized as a tool to help for mitigating climate change and the protection of people, and how these mangroves are regulating the climate change. As we all know, these plants through photosynthesis, they will capture the carbon dioxide, and this carbon dioxide will be stored as biomass in different parts of the plant like stems, leaves, branches, propagules, seeds, and roots. And once these carbon containing leaves, stems, and other parts of the plant fall down in the soil, and they will accumulate in the sediment, and they will eventually, when the oxygen level is decreasing, these organic carbon containing litter of these mangrove plants will slowly decompose by the bacteria, and they will eventually buried in the soil, and these buried deep into the soil. So this buried carbon will remain in the soil for centuries or longer if not disturbed. So this long-term storage of carbon in the form of in this biomass, or in the deep in the biomass of the plant, or deep in the soil, is known as sequestration. So once the system is disturbed, and this buried carbon, the sequestered carbon will remineralize to carbon dioxide, and this will get back to the atmosphere. So this is a study we have conducted in our lab, that is the carbon flux in Cochin mangroves. As you can see, through photosynthesis, gross primary production will occur, and some portion of the carbon dioxide will get back to the atmosphere through shoot and root respiration, and from the plants through litter fall, 7.12 ton carbon per hectare will come into the soil, and they will get decomposed, and a small portion of the carbon, that is the particulate organic carbon or dissolved inorganic carbon, will exported to the nearby water bodies, whether it may be a estuary or it may be an ocean. So the rest of the organic carbon will buried, and it will get sequestered in this ecosystem. So as I already told, a small portion of the dissolved inorganic carbon as well as the particulate organic carbon will export to the nearby ocean. So the effect of this dissolved inorganic carbon created a measurable localized increase in the coastal ocean pH. So therefore, mangroves can partially counteract coastal acidification in the tropical waters. And as we all know, that mangroves are enhancing the fisheries by providing food and shelter to the fishery resources. And this is the details of the mangrove area and mangrove dependent marine fish catch in various states of India. And these mangroves are vanishing at an alarming rate. As per the recent report, the annual loss is 0.6% per year. And as we can see in this graph, from 2000, when we look into the 2000 to 2016 graph, the mangrove loss is decreasing considerably. And these are the major threats of mangroves, that is logging, then agriculture, aquaculture, pollution, coastal development, and climate change. Climate change is the most important thing in this scenario. So this is some photographs where the mangrove destruction in Kerala is happening. So sea level rise can be considered as a future threat, as the projected sea level rise is 100 meter to 200 meter over the next 100 years. So what happens when the sea level rise? These mangroves will migrate towards land. So in Kerala, the land margins of the estuaries and backwaters are limited due to human encroachment. So there is no scope for further expansion of these mangroves, which eventually led to the decrease in the area of this mangrove vegetation. And this is one of the recently reported mangrove dieback in Maldives, and we have and our team in QSAT, we have investigated the issue in Maldives. So this large-scale dieback of mangrove species, one particular species, that is Bruguera cylindrica, is dying in the northern islands of Maldives, and this phenomenon was noticed in March 2020, and the first cases were reported from Kerala and Mekurundu Islands. And we studied 7 affected islands and 1 control island, and we have taken samples from 1 dieback site and 1 non-dieback site in all the islands. So the major outcome is the highest mangrove dieback was occurred in this Kerala island. So it was observed that the dieback was occurred in basin mangroves. Basin mangroves is a rare type of mangroves when we look worldwide. And the control island was pond-based mangroves, where no dieback was occurred. The dieback was occurred in basin mangroves or interior mangroves. So when we look into the structural analysis, we can see a total of 44,267 number per hectare of Bruguera cylindrica trees were died in 20 and 2021. So we have done the land use land cover change also to know whether any human intervention has occurred which led to this mangrove dieback, and we could see several roads were constructed in some islands, and a slight increase in settlement area was also observed. But Kelakun was an uninhabited island where there were no significant land use changes were observed. Hence, we come to a conclusion that the human intervention might not be solely responsible for the mangrove dieback. When we look into the basic environmental parameters like DO, pH, oxidation reduction potential, etc., and there was no evident difference in environmental parameters between the dieback and non-dieback, and the range of these parameters were matched with the reports from other mangrove ecosystems of other parts of the world. And when we look into the pore water salinity, we could see that the dieback islands are showing high salinity, or the dieback zones are showing high salinity, which is very close to the ocean salinity, that is nearly 35 PSU we could observe in the dieback zones when compared to, but in non-dieback zone it was around 12 to 15 ppt. So we have looked into the sea level change also, and we could see that in the dry phase, that is from December to May, the sea level was rising. After that, a drop in sea level was observed. So, and when we look into the climatic factors like atmospheric temperature and rainfall, we could see in 2020 and 21 relatively high atmospheric temperature was observed when compared to 1991 data, and for rainfall also very low.
We are having such a part.
Sorry?
No, you can carry on.
Okay. And when we look into the rainfall, it was observed that in 2020 and 21, very low rainfall was observed in Maldives. So when we look into the climatic influence on the dive, we can see earlier studies revealed that the El Nino and the positive Indian Ocean dipole phases are linked to greater precipitation in Maldives, while the La Nina and negative IOD are associated with lesser rainfall in Maldives. But during this die-off period, a moderate La Nina and negative IOD were reported in that period. That is, the triple La Nina was reported, and it was prevailed up to the mid-March 2023, which corroborates the high atmospheric temperature and reduced rainfall in the Study Islands. And the PCA analysis also revealed that the mortality percentage has strong correlation with the salinity, atmospheric temperature, as well as the sea level anomaly. And the rainfall showed a negative correlation with the mortality percentage. And the linear mixed effect model also showed that the mortality model showed significant relation with the the salinity and atmospheric temperature. And in a nutshell, we can say that the La Nina and the negative Indian Ocean dipole has resulted in the high atmospheric temperature and reduced rainfall. Similarly, sea level rise also occurs during the die-off phase. So saltwater intrusion may happen in the wetlands of these Maldives, and this dieback was affected in the basin mangroves. So basin mangroves is a rare type of mangroves worldwide, where occasional tidal inundation occurs. So which leads to the enhancements of the soil salinity, which in turn cause salt stress in this Bruguera cylindrica. This Bruguera cylindrica can tolerate up to 25 PSU. The salinity was beyond 25 PSU there. So in pond-based mangroves and fringing mangroves, where regular tidal inundation is occurring, so there is no enhancement in soil salinity was observed. So there is no mangrove die-off. And the COP26, which was held in Glasgow, November 2021, has suggested to accelerate action to tackle climate change and global warming to 1.5 degrees Celsius. But the recent 2019 UN emission gap report suggests that the world is currently on course of 3.2 degrees Celsius of global warming. So establishing a regenerative ocean economy focused on restored and protected low carbon sinks like mangroves, and for zero or low carbon production of food, energy, and transportation is essential to attain that goal. And as we all know, several acts are there to conserve this mangrove ecosystem, but environment law enforcement in India is continuous as a challenge. So we have to create awareness among the coastal population about the importance of mangroves. We have to protect or conserve the existing mangroves, and we have to restore or rehabilitate the degraded mangroves. So there are several methods for mangrove restoration. One is the community-based ecological mangrove restoration, where we have to go and research a local mangrove site, and we have to analyze the environmental condition there. Then we have to dig channels to the nearby from the restoration site. We have to dig channels to the nearby healthy mangroves, and we have to restore the tidal hydrology and facilitate the natural mangrove regeneration. And the community involvement is a must for the proper mangrove restoration. And we have to monitor regularly for evaluating the natural seedling recruitment. Another method is the nursery-based method, and we have to do species-preferred habitat restoration program. And once planted, these planted saplings have to be regularly monitored. And here also a community-based mangrove management we have to follow. Thank you.
Thank you so much. So everyone, it's time to discuss anything if you want. Otherwise, I have a question. Yes, please, Dr. Amit. Yes, please unmute yourself and ask.
Dr. Lakshmi, it's a wonderful presentation, and it's no doubt that mangrove has a huge impact on the human life, settlement, and also on the environment. I have one little concern about the carbon sequestration. You have shown your experiments where uh, you had done the carbon capture and also the emission thing from the mangrove ecosystem. Do you have any time frame on that and quantification that how much carbon is actually sequestered? Because as per I know that mangrove system is a net heterotrophic system, so it's like it produces more CO2 compared to the amount of this captured. So that's my question. Do you have some time frame, like how much CO2 has been captured by the probe, and at what time and at what capacity it has got sequestered, or like it's the after the decomposition is that basically the CO2 production? So how much CO2 has been produced, or
Yes, yes, I have shown in the slide that our time period was from 2012 to 2016. We have run the carbon sequestration. That is, we have evaluated the ecosystem carbon stock as well as the carbon sequestration potential. So the carbon sequestration rate we have calculated from Cochin mangroves.
I'm saying not the potential, but the actual fact, like how much has been sequestered, or like the whole amount has been decomposed and the CO2 is degassed. So that was my actual question.
Yes, the ecosystem carbon stock was nearly 1,42,168 ton carbon for the entire Kerala we are extrapolating, which is equivalent to 5,21,759 ton carbon dioxide equivalents.
And what was the respiration rate over there?
No, we haven't. Yeah, we have calculated the above ground biomass carbon, below ground biomass carbon, the litter fold carbon, as well as the soil carbon.
So we have not calculated the respiration or a bacterial decomposition rate after sequestration.
No.
Okay. Yeah, I think Dr. Ashish, you can go ahead.
Yes.
With the question.
Okay, thank you very much. Thank you for this presentation, Dr. Sri Lakshmi, because it sort of gets to what I have in mind, and I do not come from an academic background. You have to bear with that fact. So, one of the things that came to my mind is there any data on specific mangrove species which sequester the maximum amount of carbon? Because I think a lot of this monocropping is going on, or monocultivation is going on in certain areas, at least in the Sundarbans where I am active, that 3-4 plants are being this is being promoted by local NGOs as a part of the community participation that you spoke about. And community participation is important, especially in the Sundarbans, which is, like it's very remote, it's very cut off. So unless local communities are involved, nothing is going to happen. And the only catalyst in promoting mangrove is basically the local NGO or the NGOs that are present there. But unfortunately, as I was saying, that there is this concentration on 3-4 varieties of mangroves because they survive in the conditions. A lot of species are getting wiped out. That is one part of the question. And we also need to know, what is the sequestration rate, if there is any, of one particular species over another particular species. I think you had spoken very briefly on that too, because there are certain plants which obviously survive and sequester more carbon than others. That would be logical in the grand scheme of nature. That is one thing. And the other thing is that, see, we are now getting obsessed with mangroves. Right, but are we thinking about the weeds, the reeds, the plants that support the entire mangrove system? Because everyone seems to be planting mangroves, but no one's talking about the reeds and the weeds that enable the process of natural regeneration of the mangrove. Thank you. Can you sort of shed some light on that?
Okay, regarding the species-specific sequestration, I think in India, all the mangrove ecosystems are multi-species mangrove ecosystem. But in Maldives, we could see monospecies mangrove plantation. But in India, I think it is difficult to know the species-specific carbon sequestration rate. since it is a multi-species mangrove ecosystem. That's the we haven't done specific carbon sequestration rate. Second question is another thing is my humble advice is when we go for a restoration, we have to analyze the local environmental condition. That is, before selecting a species for planting, we have to analyze the local environmental conditions, basically the salinity, the soil texture and all. So some species will flourish well in high saline zones, and some species will flourish in low saline zones, and some species will flourish well in muddy areas. Some species will flourish well in sandy areas. So we have to do restoration based on the environmental condition, not based on the carbon sequestration rate. I think that's my almost 90% of the restoration efforts are flopped in worldwide. When we look into worldwide, that is mainly because of this. Without any scientific exploration, we are simply going and planting the plants. That's why most of the plantations are not successful in when we look worldwide. And I forgot the second question, sir. Sorry.
The second question is about local ecosystems for mangroves, like traditional grasses, localized grasses, weeds that support the regeneration of mangroves by trapping their seeds naturally, right? And so that is something that is being neglected. Are you aware of any kind of scheme that the government or anyone else is promoting in this regard? Because otherwise, I fear what is going to happen is that a lot of these species will slowly die out because we are madly planting mangroves and nothing else.
I think we have to we have to dig channels for the proper hydrology. That's most important, I think, for the natural regeneration of mangroves. I think the government now, the central government is announcing a Mishti project for the restoration, and the state government also. And I think in Kerala, the major challenge is more than 50% of mangrove is in private property, which is a huge challenge for the government to protect these ecosystems. So now the Kerala government is, I think, they are paying for ecosystem services. That is, they are giving money to the landowners for protecting these mangroves. So such kinds of activities are I have seen from the government side.
Okay, thank you. Because see, this is something which doesn't happen here. Most of the mangroves are either on forest land or on government land or unclaimed land. Most of the mangroves in the Sundarbans. But thank you very much, because this can open up other avenues of thought.
Thank you, sir.
Thank you.
Thank you so much to both of you. And again, thank you so much, Dr. Sri Lakshmi, for being here. And it was really a pleasure to hear from you. Thank you.
Yeah, I have one small queries to ECSF. You guys had done some plantation about the river bank, as I remember, long back. The mangrove plantation around Chandanagar side, along the river Ganges. Was it you or some other group from West Bengal?
No, can I answer this question?
Yeah, I have seen like some of your posts long back that you guys were planting some mangrove about the bank of river Ganges.
Yes.
What the fate, like what happened to them?
Okay. So yes, the ECSF and one of its partner organization called Purbasha Eco Helpline. Together, we have planted mangroves along the banks of Ganges. This was an experimental the part to kind of to see whether these mangroves can actually survive or not under sort of a kind of freshwater condition. Now, the mangroves and the Chandanagar area are very much thriving. Right now, their height is something around 2 to 2.5 feet. Okay. And the ones in the Kuti Ghat, some of them are surviving, some of them are not. Now, I don't know the scientific name actually, but the local name of those mangroves are called Kaura. Some were Sundari, but one of and then the other local name was Chak Kaura. So I'm very sorry that I cannot I just cannot right now recall the scientific name of those particular species. Sundari is Heritieriformis, I understand. Anyway, yes, that plantation is still on. Those mangroves are thriving. One of the incidences that has happened is the human intervention, which we lost some of the mangroves, and also because of the hyacinth. During the high tide, sometimes the hyacinths actually comes to the bank, and they kind of like get on top of the mangroves, and that's how we lost some of the mangroves. But natural dying off of the mangroves so far not being evident. So this is quite a interesting story, and we are collecting monthly data on with the help of Chandanagar College, because that's the proper monitoring body. Okay. So we are excited that this is possible. Let's see how far they can grow. Thank you.
Oh, that's wonderful that they're growing. That's great here.
Okay, thank you so much. Let's move to our next speaker, Mr. Kale Weather. First of all, I want to really mention this, that Kale and me, we are presenting Youth Advisory Council for the World Ocean Day. And just a minute. There is one technical difficulty. Just a minute. Yes, sorry. And we are presenting the Youth Advisory Council for the World Ocean Day. And Keld was waiting. Actually, Keld is having another event. And that's why we have to give him the stage right now. Keld, are you there? Hi, Keld. Are you there?
Just join.
Keld, am I audible to you? Can you please confirm?
Yes, sorry. Yeah.
Yeah.
Is my audio all right?
Yeah, you're audible now. So just give me 1 minute. I have to introduce you.
Yeah. Okay.
So Kale Weather is studying marine sciences, ecology, and behavior at the University of Utrecht with a great interest in the ocean, animal rights, and climate justice. Fueled by the thought that every animal has the right to live, he has already worked at multiple environmental organizations like the Dutch National Youth Council, Eurasians Youth, and the World Ocean Day Youth Advisory Council. Currently, he is part of the Sustainable Ocean Community of the University of Utrecht and the Royal Netherlands Institute for Sea Research. Moreover, he is fighting for climate justice through the International Court of Justice in the team of World's Youth for Climate Justice. At last, he is developing the Dutch Note for the Early Career Ocean Professionals program. For him, it's all about the combination of study and implementation. Yes, Keld, over to you.
Thank you so much for the introduction, and hello everyone. I'm in a bit of a hurry because I need to go to my own World Ocean Day event. but I have still some 10 minutes left to give this presentation. I will share my screen right now. Please let me know when it's working. Okay, so I am sharing it right now. Okay.
Yeah, it's visible.
Is it visible? Great.
Yeah.
Okay. Okay. Is it working?
Yeah, it's perfect. Please.
Perfect. Okay. So I'm going to talk about working on ocean conservation as a student. So it's not like a really scientific presentation, but more sharing my experiences on working ocean conservation. And maybe I can also give you some recommendations on how to include more youth within organizations. And if you are a young mind yourself, on how to get more youth together. So I am Kjell Burder. I am studying at Utrecht University, as Deborah already said, in a bachelor's of biology, and I'm focusing on marine sciences, behavioral sciences, and ecology. And moreover, I am working at a lot of youth organizations because I'm very interested in how we can implement all those scientific papers and that the ocean needs to be protected, that we need to do more to protect it, how we can implement those papers into real life and into policy being made in the Netherlands, in the European Union, and also worldwide. And I do that at a lot of organizations. Here are some examples. And in the Netherlands, we have a lot of youth that are interested in the ocean. I think in India as well, if I see all the incredible attendees today. But the youth in the Netherlands and in the European Union aren't as connected yet. And I thought that needed to change because it's very important that youth are connected to work on ocean conservation together. Not only to do advocacy and to do projects, but also for a part of like a community building and also some mental health awareness as well. It's kind of hard to be faced with all those devastating facts about that the ocean needs to be protected and that it is in great danger. So I wanted to get more youth together. And one of those organizations were the early career ocean professionals. As this is an ECOP webinar, I won't be explaining a lot about the ECOP program itself, but it is founded by the Ocean Decade, and its goal is to connect ocean professionals all around the world. And Deborati told me about the Indian node, and it is really thriving. But in the Netherlands, we didn't have a node yet. So no ocean professional in the Netherlands could go to the group to be connected. And that's when I started to found the ECOP Dutch node myself, because I thought it was very interesting and it just needed to be done. And after the Dutch node, we, as nodes in Europe, wanted to found a European steering committee because in a lot of continents, there are a lot of nodes already established, but in Europe, we're a bit behind. So currently, we're working on a European steering committee to get more European countries to be involved as well. And in the Dutch node, we are already organizing events. One example is the National Ocean Sciences Conference being held on last Thursday, where we got to connect with a lot of ECOPs. So that was very nice. And I'm also working for the Sustainable Ocean Community. The Sustainable Ocean Community is a community of the Utrecht University, where I study as well. And it's not for connecting ECOPs, but it's for connecting ocean scientists. And I wanted to give this example as well to show that it's not only about ECOPs, but also about the ocean scientists from like all ages that need to be connected. And the Sustainable Ocean Community is organizing a lot of events. For example, today is World Ocean Day, of course, and today we are organizing a student symposium on island nations and their connection to the ocean. So yeah, that's very interesting. And if you want to be active as an ocean scientist or just as an ocean enthusiast, you do not have to like do science. It's not the only thing you can work on as an ocean enthusiast. I myself also work for a Wheelchair for Climate Justice, and the goal of WYCJ is to make countries responsible for their inaction against climate change through the International Court of Justice. And luckily, the International Court of Justice is situated in the Netherlands, so we've been there a lot. And currently, there is a really big court case being held, which will we're currently in the oral submission. So a lot of countries are coming to The Hague in a couple of months to really give their opinion on what countries should do against climate change. We're also in India, so for all the students and other enthusiasts who want to be involved, yeah, please go look for Wheelchair for Climate Justice, and I hope that I can welcome you as our Indian colleague. And because of the time, I think I will skip. I will shortly tell a bit about WWF. I think everyone knows a bit about WWF, the Worldwide Fund for Nature, World Wildlife Fund for Nature. And at WWF Netherlands, we didn't have any youth included yet. We had them included in campaigns and in like really shallow things, just campaigns and strikes and stuff, but we didn't have them in like the most important layers of WWF, where all the big decisions are being made, like the management team, for example. And the reason why I wanted to show the example of the Youth Advisory Council is that if you are interested in the ocean or nature in general, you don't always have to be, you don't always have to go to an organization that is already existing. It's also possible to found your organization yourself. Because when I heard that WWF didn't have any youth in their management team, I stepped towards the management team myself and said, okay, it's very nice that you are working on nature, but you need to include youth as well. And that's how the Youth Advisory Council was being made, being established. So if you're interested, yeah, just go for it. Okay, then to conclude, some general improvements in youth inclusion. What could you do as an adult, but maybe as youth as well, to include more youth within your organization, within your scientific research? I have thought of some improvements. The first thing is, don't only invite students to your event to like tick the box. I always call it tick the box, because it's like when organizations are organizing events, they think, okay, we want to make it as inclusive as possible. How can we do that? Okay, we need to include elders, we need to include artists. Oh, but we also need to include youth, but like with no goal at all, just to tick that box. Okay, we have included youth. We can give ourselves a tap because we have included them, and we're inclusive. Really have a purpose with the youth that you are inviting, because otherwise they're just doing nothing, and that's such a shame of their time. Then the second thing is let youth be involved in the processes after the brainstorm as well. So if you're brainstorming with youth and they have great ideas, then really let them be an owner of that idea as well. Not only take it and implement it further, but really take them along with that process. Then also let youth be in charge of their own organization. I experienced that myself at WWF. WWF had tried to include youth earlier on as well, but they wanted to be in charge of their organization themselves. So like adults were organizing things for youth, and the result was that the youth became really passive, because that's totally logical. If everything is being organized for you, then yeah, you just sit back and relax. And you want youth to be active and really be the owners of the organization. So when I founded the Youth Advisory Council, youth could really like be involved and do things themselves. So I think that's another improvement that could be made. Then support youth with donations for their work, because youth need to study, need to work. We have a lot of things to do as everyone, but youth are currently being like maybe used for their time without being paid in some sort of way, and that's something that it's just important that if you want an inclusive group, so also youth from less wealthy families that just need to have some sort of an income, pay them. It's very important. And at last, let a small group be in charge of the steering and include a bigger group via events. Because if you want to include like 30 youth for one organization, that's not going to work, because a lot of youth are busy. Just find the most enthusiastic ones, include them, make them a part of the organization, and include the other youth via events. Because if you want to include all the 30 ones, then at the end it's very hard to organize and people become passive, and yeah, that's not what you want. Okay, it's a bit fast, but I need to go to my own World Ocean Day event. But thank you so much for listening to me.
Yes, thank you so much, Kel, for your excellent presentation, and thank you for being here. I know you're extremely busy with your event and everything, but thanks so much. So anyone wanna ask Kel a question, please? Yeah, please, sir.
Yeah. Are you talking to me?
Yeah, please.
Okay. I think he gave a lot of very interesting and constructive suggestions. One of the things that maybe the youth need to focus on, or whoever designs the program for the youth need to focus on, is to be issue based, because not everything is going to interest all the youth. Certain things will obviously find their resonance among a certain group of people. That's obvious. I mean, that's also true for adults. So otherwise, I think you gave a lot of very constructive suggestions. Thank you.
Thanks so much. I think I have to go now, because otherwise I will miss my train to my own. But thank you so much. And Deborah, if you can share my email, contact info and stuff. If there are questions, please contact me. I would be glad to answer them. Thanks so much.
Thank you. I really do. And yeah, best wishes for your event. Okay. And this is our last segment and our last speaker, Ms. Shreya Dash. And this time she is actually representing the organization ECSF itself. Shreya is currently pursuing a master's in geography and working as a researcher with ECSF on the islands of Sundarbans, focusing on Moushuni Island. She has presented papers at national and international conferences and received an Outstanding Paper Award at the 5th Regional Conference organized by GST in 2024. Shreya, are you here?
Yes, I'm here. Thank you. Thank you, Debarati, so much for giving Prof. I will thank ECSF for providing me with the platform. So today I'll be presenting on my research paper part, which is done. So is it visible?
Yes, it is.
Okay. So good afternoon to all the delegates present here. Myself Shreya Das, and I would be presenting on the following topic, and our focus would be on the vulnerabilities and how it can be managed through sustainable measures. So Indian Sundarbans is the breeding ground of tropical cyclones as being exposed to Bay of Bengal. If we compare the global vulnerabilities with that of the Sundarbans vulnerabilities, we can see that both sea level rise and the surface water temperature increases at a much higher rate in part of Sundarbans. So Sundarban is considered as the global climatic hotspot. So moving on to the next slide, we have shown that how risk is the combined impact of hazard and vulnerability. Whereas vulnerability is that state where one is affected at their worst condition. So mainly we will be discussing on natural vulnerability which occurs due to the natural hazards and destroying the physical landscape of an area. So due to the effect of rainfall, this photo was taken after 2 days of rainfall, and we can see that how the fields are affected and the salt water has intruded here, destroying the crop fields. On the other hand, in case of social vulnerability, it is mainly occurred due to the anthropogenic interference of the locals. And this was the condition of the resorts where it is almost washed off the main, just the structure is remain. And next I will be showing a clip. So this clip is mainly how the coast is continuously eroded to the wave dashing and the banks are destroyed continuously. It was during the high tide after the rainfall, so we can think of the idea during the cyclone they had faced. So moving on to the next slide, our focus is on tropical cyclones, and as tropical cyclone is the most prominent disaster leading to vulnerability. So we can see that successive cyclones, namely Bulbul, Amphan, Yas, and recently Remal, has passed through these islands, hampering their livelihoods. So Moshune is a small island. It is located at Namkhana in the block of West Bengal, and it is being one of the most vulnerable islands of Indian Sundarbans, which is continuously exposed to the waves of Bay of Bengal. This map on the right hand side focuses our study areas where we have conducted our fields. So the objective of my work is to assess the vulnerability of Moshuni Island and to combat them with sustainable measures. To fulfill my objective, this following methodologies were taken, the results of which will be discussed from the next slide. The satellite image mainly shows the effect of pre and post cyclone. The vegetative cover here is reflected with the red part, and the blue cover and the blue area mainly shows how there is saltwater intrusion in the islands, and it has mainly occurred during the cyclone. So it is seen that the vegetative cover has started reducing from 2021 after the effects of Amphan and Yas mainly. For the effect of Amphan, they have faced a lot of vulnerabilities, and still they are trying to recover. This image was taken after the effects of Amphan, where the saline water has totally intruded in the farmlands, and this was captured during that time. This was the effect of after Remal, though Remal did not affect them as much as Amphan could do. But we can see that some of the structures of the resorts are totally destroyed and some are partially destroyed, and they are trying to combat them. So next, we have done an erosion and accretion map. So the red portion is mainly the eroded area, which is eroded due to the wave action, and the yellow part is the accreted area where land is added in the Moshuni Island. So erosion is mainly seen dominating in the southern and southwestern part of Moshuni, that is Baliara. So previously there used to be a salt, there used to be the Baliara was protected by a natural sand levee, which is mainly lost due to the anthropogenic interference for tourism activities, which has led to a massive rate of erosion. On the other hand, there is the Kakramari Chor on the northwestern part of which is showing accretion. So the extension of river Murigonga with Pete's Creek is clogged with sediment, which is brought during the high tide. Thus, inland sedimentation is mainly seen, and which has led to the formation of sandbars over the past years. So Kakramari Chor is slowly developing or is slowly adding to the mainland of Moshuni. So next, we will be focusing on the change of embankments over time. And embankment, let me just say what is an embankment. So embankment is basically a hard wall-like structure, which is mainly built to resist the waves in the Moshuni Island. So we will be focusing on two types of embankments. One is natural, that is the geojute earthen embankment. And another is the Isla Bar, that is the concrete embankment, which is built in some of the areas. So this was the condition. The first image was taken before the pre-monsoon period, and this was the condition just after some 4 months during the monsoon period. So this geojute is totally destroyed, and our study site was totally inaccessible. So after that, we had to change our study site, and we moved towards the north part of Baliara, where the geojute were recovered by the locals, by the resort owners. And then this is the condition during high tide. So we can see that during high tide only it is almost full, with the water level is full. And then if we focus, this is the Isla Bar, this is the concrete embankment, which is guarded by tetrapods, and it is so guarded because to stop to prevent it from wave erosion. But during high tide, it almost remains submerged, and this is the recent condition of this the same place, where we can see that the tetrapods and even the bamboo embankment is also submerged during high tide. So all the conditions are really vulnerable in Moshuni for during any cyclonic intervention. This was our study site for the beach profile and embankment design. So beach profile is mainly the measurement of the elevation of beach surface to see how much the land has lowered, mainly caused due to the wave erosion. So the following are the cross sections of Moshuni that reflects how beach responds to retreating itself to maintain the morphological balance. But sea defense, which we talked about in the earlier slide, that is the embankment and sea wall, they restrict the process and leads to increase in beach lowering. We can also see a bit hump in the right-hand corner of a graph, which is mainly the remnants of the plant species which used to exist in the earlier times, which has now totally been destroyed. So the next is we have shown the long profile, which is measured parallel to the beach, and we can see that slowly it gets flattened towards the beach as the resorts are built. So extreme end of Baliara, it is getting lowered due to much anthropogenic interference for building the resorts. So a Likhart's opinioner scale was prepared based on the rating or perception of the locals. And most of the results we can see are negative or are poor because they face vulnerability almost throughout the year. So the cyclone and intrusion of salt water has disrupted their agricultural land, and agriculture is one of their primary occupation, which is now they are shifted to fishing. So the agricultural land has turned into salt pan. So most of the trees are seen uprooted, and also the cyclone and flood shelters were not accessible to most of the people during the time of hazard. And we have suggested some coastal sustainability action plan, since technology cannot alone solve the advancing river or tidal waves. So tidal river management basically focuses on the natural healing of land. So we just suggest that if it is possible to relocate the people in a safer place where they can build a safer area and give time to nature for healing itself. So the rest, bioengineering techniques like planting of the local plant species, mainly mangrove plant species, can be planted to stop the wave erosion, as they can hold the soil very in a good manner, and they can help preventing the soil erosion. And in fact, since it's a tourist attraction site, so coastal regulation zones should be strictly followed to prevent further loss of the area. And the measurements which are already being implemented, they should be totally strictly followed by everyone. Both government can also help, and local NGOs, they are doing their bit. And I have suggested a measure. This is called the Risho's erosion lattice. This technique, if possible, can be implemented in shallow waters, where they reduce the wave energy to almost by 30 to 50%. So once the sand volume is total, it started building up, the lattice can be reinstalled, and the beach can again retreat to its natural beauty and the non-eroded state. So as we have come to my end of the presentation, so I would like to thank my professors for guiding me throughout, and also my research institution for providing me with the research facilities. So since today is the World Ocean Day, so I would like to conclude by saying that let's all come together and raise awareness about the importance and conservation of coasts through sustainable practices. Thank you. Thank you very much.
Thank you so much, Shreya. Anyone here who want to ask a question, maybe? Yes, Dr. Paul, please.
Hi, Shreya.
Hello, sir.
Yes, it's a very nice presentation, and I just have two questions for you. First, how it feels like to work on a cyclone day?
Sir, actually, it was my first time experience when I just went after the effects of Remal. And Bay of Bengal is generally silent sea. I mean, not a silent sea. I mean, it is not so much, waves are not so much dashed. So that was my first time experience when I saw the waves in that vibrant stage. So yes, and so I was just thinking that how they have felt the effect during the cyclone if it was after 2 days. So yes, I'm just started experiencing this thing. So it feels nice to explore with those people who are actually facing the problems. Like, I cannot face the problem sitting in my home, so I can relate when I visited the field. So yes.
And my second question is that some of your friends here are maybe not from marine science, they may be from geography or maybe from social sciences. And since you explore lives, livelihoods, and the physical system, do you feel connected with the ocean or you do not?
Yes,
and what could be your message? What could be your message to your friends of geography who are reading geographical sciences or social sciences, like economics, like community development, like women's studies, and so many developmental studies? Do you think they have a role also to play in terms of ocean science and the World Ocean Day and for these sort of events?
Yes, so definitely, because it's I believe in a fact that it's both way work, that the man and the nature has to work together. We both contribute for the development. So yes, definitely, those we are maybe working as a human resource person, but we have to involve ourselves with nature. Until and unless then we don't understand what's our role we are playing. We cannot only manage the human part, because we are accessing with the nature. So it's a both way interaction, and we must follow that.
Thank you. Thank you.
Anyone else? Okay, Shreya, I am having a question because it's you're the last speaker, and I didn't ask anyone till now because we are running late. But I just want to ask most important question as young people, like what you feel, what can be the key point, because we all have some of our like own findings during our research work or course of work. So what do you think? What young people can do, or Indian they are motivated, or what we should do? Are we enough motivated to safeguard the ocean?
Yeah, we should spread awareness more and more, and like we should encourage the young people because we are the next generations, and we should encourage our next generation to like protect the oceans because they are our like to save our future, at least if we think from our side. So, and mainly if I talk about my study area or my project, so as a young people or as young ones, maybe we cannot have so much fun to install all the technologies, but at least we can plant some local plant species, or we can involve the locals one to plant the species, because it is not much more cost effective. So it's eco-friendly also, and it's cost friendly also. So from our part, we can at least do that deed and spread awareness among everyone, and at least teach them that the basic things we need to incorporate. So I think this.
Thank you so much.
Thank you.
Please keep up the good work.
Thank you so much.
We are wrapping up the ECOP part, and it's really great to have from Dr. Sudhesh, Dr. Vishwajit, Dr. Sri Lakshmi, and Shreya, who are very much like research oriented, and Kelt, extremely communication and that ocean literacy part oriented. So I think there was a good balance. I would love to invite our next moderator, Dr. Chimli Mondol, and she is DBT Biocare Women Scientist of the Foundation. So, ma'am, are you here?
Am I audible?
Yes, ma'am. Yes, all over to you. Thank you. Thank you, everyone.
Thank you, Devarati. So, good afternoon to all. I welcome you all to the invited lecture session of International Webinar on Catalyzing Ocean and Climate Action. For the session, our first speaker is Dr. Anirban Akhan. Dr. Akhan is Associate Research Fellow at Blue Carbon Lab, Deccan Marine Research and Innovation Center, Deccan University, Australia. He is also attached to ECSF as a visiting scientist. Dr. Akhan's research interests focus on low carbon ecosystem dynamics of climate change. His expertise extends to carbonic chemistry and the carbon cycle, both organic and inorganic, in estuaries and coasts, as well as their air-water flux of greenhouse gases in estuaries and marine ecosystems. He is also interested in phytoplankton ecology, epiphytic algae, aquatic pollution, and broadly marine biogeochemistry. Over a decade of research and experience, his blue carbon research, backed by over 50 peer-reviewed publications, which has taken him to India, Japan, Hong Kong, and Australia, where he has conducted laboratory analysis and fieldwork in tropical, temperate, and boreal sites. Today, he will be talking on low carbon and its climate change mitigation potential, with special emphasis on Indian Sundarbans. Dr. Akhan, your talk will be for 25 minutes strictly, and followed by 5 minutes of discussion. So over to you, Dr. Akhan.
Thank you for the introduction. I'm not now sharing my slides. Is it okay now?
Yes, we can see. And you are also.
And is it in the sharing mode?
It's not in full screen, but we can see your presentation.
Okay. Now?
Now also is not in share full
screen.
screen mode, but you can present, I think, because others are also present in some of early speakers are present in that mode only. So you can
Okay,
present,
okay.
we can
I'm
visualize it
okay. I'm
properly.
trying now again. Just a minute.
না 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 তোমাকে যেখানে দেওয়া ইংলিশ
Actually, it's fine. You can go ahead with it. No issue.
Okay. First of all, thank you, Dr. Saurabh Pal, for inviting me in this excellent occasion. And today my topic is blue carbon and its climate change mitigation potential, with special emphasis on Indian Sundarbans. And thank you for the introduction. So I would like to tell a bit about the greenhouse effect for the younger students. So about half of the incident solar light, solar radiation is absorbed by the Earth's surface, and infrared radiation emitted from the Earth's surface in all directions by the greenhouse gas molecules and clouds. So this is called greenhouse effect, and greenhouse effect is very essential for our world and for our Earth. But the problem, we all know that now the greenhouse gases are increasing than their natural levels. So we all know that in 2017, we have already crossed the CO2 level of 400 parts per million. And in the last year, in 2023, we have crossed 419 parts per million of CO2 in the atmosphere. And there are other greenhouse gases like methane and nitrous oxide. During the pre-industrial revolution in 1750, the CO2 was 278 ppm, methane was 0.72, and nitrous oxide was 0.27 parts per million. And during 2020, the recent years, the CO2 increased to 408 parts per million, and methane increased to 1.85, and nitrous oxide increased to 0.33 parts per million. And another thing is this methane's global warming potential is 28 times higher than the carbon dioxide, and of nitrous oxide, it is 298 times higher than the carbon dioxide. So these are more detrimental greenhouse gases than CO2. And as we know, this has been increased because of the fossil fuel burning, agricultural activities, land use change, industrial processes, and so on. And as we know that the effects are Earth is rising, the temperature, Earth's pole is melting, glaciers are melting, sea levels are rising, animal migration is happening, increased in rainfall and snowfall, and more damaging wildfires are happening throughout the world, and more intense heat waves, drought, etc. Total heat content of the Earth, that is land plus ocean plus atmosphere, has increased many-fold over the past 50 years, and the Earth will continue to trend the increase even if we reach the target of the emission reduction. Even then the effect will continue for a long time. So here I explained how the oceanic carbon dynamics is related to climate change. Carbon is the fundamental building blocks of all the life forms, and carbon is an important component of different biogeochemical processes, which in turn regulate the present day climate. The human beings are capable of altering the carbon equilibrium in our planet, and we already altered it by the anthropogenic activity and other things. Carbon is one of the principal components of several greenhouse gases, which I already told. The carbon cycle. Yeah.
Doctor, can you change the slides? Is it or some technical issue is going on?
So, which slide?
You are on the first slide.
Oh.
Okay. Yeah, you are on the first slide.
Oh.
So you can start the slideshow mode. That will fix it.
Okay.
Yes.
So first I'm stop sharing now. Is it okay?
No, sir, no need to stop sharing. You can just click on the slideshow option, which is there at the
I
top
have
of your screen.
already clicked the slideshow options, and I am changed the slide and I went to up to 7th slide.
Can you bring that 7th slide? Can you bring that 7th slide to the sorter?
Yeah.
Yeah, just click on that 7th slide. Yes, at least you can do that. Yeah, at least you do that. Okay, thank you.
Okay, is it now? Can you see it now?
That's all right. That's all right.
And the changing, I changed now. Can you see?
No, sir. Actually, you have to click on every slide in which you have to change. Like after 7, it's 1. So then it's 1 here.
Okay. Just a minute. Here I showed what are the different, how the carbon exists in the seawater. There are different carbon species in the seawater. For example, particulate organic carbon, dissolved inorganic carbon, dissolved organic carbon, and particulate inorganic carbon. And these carbon forms are interconvertible to each other. For example, the particulate organic carbon and dissolved inorganic carbon can be changed to other forms, each other forms by primary production and the reverse process respiration. Similarly, POC and DOC can be changed using the bacterial heterotrophy process and ectoenzymatic process, and DIC and PIC, that is particulate inorganic carbon, that can change within each other by carbonate, calcium carbonate formation and calcium carbonate dissolution. This is the principal pathways of carbon exchange in ocean. There are different processes of carbon input and output. For example, runoff, ocean atmosphere, exchange of carbon dioxide, upwelling and downwelling, and biological pump, there are other pumps like solubility pump and recently added microbial pump and subduction of sediment, etc. Here I shows the different inputs and entry points of the carbon to the oceanic cycles. Rivers are the main contributor of the terrestrial carbon to the ocean, and rivers contribute approximately the equal amounts of dissolved inorganic carbon and dissolved organic carbon to the ocean. And DIC shores from the terrestrial part is weathering or erosion of aluminosilicate and carbonate rocks. Before industrial revolution, it is noteworthy that before industrial revolution, the ocean was a source of CO2 to the atmosphere, whereas now ocean is a large absorber of the atmospheric carbon dioxide, that is 2.2 petagram carbon per year. Here are the inputs and entry points. Oh, sorry. There are other outputs and exit points of the carbon from the oceanic cycle. For example, the organic matter preservation by sediments in the abyssal plain, refractory dissolved organic matter deposition in the ocean floor, sequestration in the form of blue carbon, and carbon deposition in the coasts and continental shelves. Here I will explain different colors of carbon. For example, there are black carbons, which are the shooty particles formed by the incomplete combustion of the fossil fuel and biomass. Green carbon, all of us know that the terrestrial green plants sequester the carbon by the photosynthesis, and that is called green carbon. And there are brown carbons, which are the organic carbons in the aerosols. And at last, there are blue carbon, which is today's topic. And blue carbon refers to the biomass and the carbon sequestered in the marine sectors and in the biomass and sediments in the marine sectors. By definition, out of all the biological carbon captured in the world, over half, 55%, is captured by the marine living organisms, and that is why it is called blue carbon. The term has been coined by Nelman et al. In 2009. And as we know, the ocean is blue, so the term has been coined as blue carbon. In 1 acre of salt marsh can sequester 1,940 pounds of carbon. Similarly, mangrove, 1 acre of mangrove can sequester 1,450 pounds of carbon, and 1 acre of seagrass can sequester 74 pounds of carbon. Here I showed some recent estimates by Lovelock and Reef 2020. They showed that the world's mangrove area is 1,38,000 kilometers square, salt marsh is 55,000 kilometers square, and seagrass is 3,25,000 kilometers square, and they can sequester as much as carbon, followed the highest carbon is sequestered by mangrove and followed by salt marsh and seagrass ecosystem. The blue carbon, these three ecosystems, mangrove, salt marsh and seagrass ecosystems, can bury 30 to 50 times faster than the tropical rainforest, and the carbon sequestration rates of the blue carbon ecosystems are even higher than the Amazon rainforest. And other boreal and temperate ecosystems, and from the terrestrial part, which also sequester carbon. Here I showed some statistics and some magnitudes, as you can have some idea how much important is the blue carbon ecosystem is. The three ecosystems, namely mangroves, seagrass, and salt marsh, I already mentioned, can sequester 50% of the sequestered carbon in the ocean sediments, while they cover only 0.2% of the aerial ocean floor. And 25% of the anthropogenic emitted CO2 can be captured by marine ecosystem as blue carbon per year. The overall climate change mitigation potential through the blue carbon has been estimated to be 30,000 teragram carbon, which could avoid emissions of about 300 carbon dioxide equivalents. And 1 teragram is 10 to the power 8 gram. Restoration and extension of blue carbon ecosystems can sequester an additional 841 teragram CO2 equivalent per year by 2030, which is about 3% of the overall global emissions. Other ecosystem services of blue carbon ecosystems, other than climate change mitigation and adaptations, include protecting coast from the frequent storms, rising sea level, and coastal erosion, trapping particles, sediment stabilization, etc. Here I showed the stabilization and destabilization process and the balance between them, which decide whether the carbon which reaches to the blue carbon ecosystem will store for millennia or it may degrade between a few minutes or a few hours. So it depends on the input of carbon from the allochthonous sources in the blue carbon ecosystem and outputs and autochthonously produced carbon. It can be respired, or by erosion it can be degraded, or by other environmental factors. The stabilization and destabilization depends. That may be nutrients, that may be microbial composition of the soil, etc. I mentioned three ecosystems like mangrove, seagrass, and salt marshes, but is it possible to include other ecosystems as under blue carbon ecosystems? Yes, there are already many proposals that whether other ecosystems like mud flats, oyster reefs, coral reefs, phytoplankton, macroalgae, etc. can be included under blue carbon ecosystems. And Lovelock and Duarte in 2019 made this study. They proposed that some criteria whether these other ecosystems can be included under blue carbon inventory, such as scale of greenhouse gases removals or emissions are significant, long-term storage of fixed CO2, undesirable anthropogenic impacts on the ecosystem, management practice, whether the management practice is possible or not. It is a very important point because in the open sea ecosystems, we cannot manage everything, but in the coastal sites, we can manage many things like restoration and other policy and by other policy. So here you can also see the yellow parts where the many questions are unanswered yet. So there are essential needs to study more whether these other ecosystems can be included or not. Here I showed this slide because it is a very interesting thing that the whales are also proposed to be included in the blue carbon ecosystem in the from the Meineke et al. 2023. So there are different pathways like whale pump, living biomass, whale fall, and whale bioturbulation, etc., by which whales are a big contributor to the oceanic carbon cycles, and it has been proposed to be included in the blue carbon ecosystem. Now, I am entering into our Sundarban. There are some facts and statistics regarding Sundarban. As we all know, I'm not going to deeper into it. The Sundarban is the largest mangrove forest of the world, and 40% is shared by India. And according to the latest estimate, 15.2 million hectare is a mangrove cover. This is not recent. This is from 2010. And this region is known for its high biodiversity, like 60 true mangrove species, 96 mangrove associates, 1,600 animal species, and it experiences a typical humid tropical climate. Clay loam is the predominating soil type, and so on. In this slide, I explained that carbon flow in a typical mangrove ecosystems. The carbon can be sequestered in the sediment of the mangrove, and the air, atmosphere, and biosphere carbon dioxide exchange may occur in a typical mangrove ecosystem by net ecosystem exchange. And after sequestering the carbon, the biomass can be consumed by the fauna, or it can also be exported to the coastal and open ocean in the form of particulate organic carbon, dissolved organic carbon, and dissolved inorganic carbon, or it can be transported to the other ecosystem where it can be further deposited in the sediment or mineralized and go back to the atmosphere as CO2. There are three kinds of carbon dioxide fluxes in a typical mangrove ecosystem, like mangrove soil to air carbon dioxide efflux, air to mangrove vegetation carbon dioxide influx through the ecosystem exchange, and mangrove water to air carbon dioxide efflux. In this study, I summarize the magnitude of the carbon dioxide exchange through these fluxes. And although the soil, the sediment part, and the water of mangrove is a net emitter of the CO2, but due to net ecosystem exchange, mangrove is a net sink for carbon dioxide. And the air-water carbon dioxide exchange in the mangrove ecosystem of in a typical mangrove ecosystem depends on the carbonate chemistry and carbonate system of that ecosystem. And in this study, Akhond et al. 2021, we showed that in Sundarban, the global average, the Sundarban is a much less emitter of CO2 from the water, mangrove surrounding water than the global average. And we showed that the low partial pressure of carbon dioxide and high total alkalinity by DIC ratio enriched water is coming from the Bay of Bengal, coastal Bay of Bengal, and it lowers the CO2 emission of the creeks and the mangrove surrounding water in Indian part of Sundarban. In this paper, our next speaker, Dr. Kunal Chakraborty, is a co-author. This is my recent study, which is still unpublished and under review. Here from the secondary data and secondary publications, I have showed using the structural equation modeling, we found the different driving factors of CO2 fluxes. For soil to air CO2 fluxes, decay of dead biomass, breakdown of soil organic carbon, microbial respiration, and soil temperature are the significant factors which contributes to the CO2 efflux from the soil to air. And this upward red arrows means the CO2 efflux towards atmosphere, and the downward arrow, red arrow, means the flux towards the mangrove ecosystem. And in the net ecosystem exchange, we have found that carbon assimilation potential, photosynthetic activity, light use efficiency, etc., is proportional to the CO2 influx towards the atmosphere, towards the ecosystem, mangrove ecosystem, and atmospheric temperature is the main contributor towards the flux towards the atmosphere. And regarding air water carbon dioxide fluxes, the partial pressure of CO2, heterotrophic respiration, microbial activity, and water temperature is the proportional to the water to air CO2 efflux, and CO2 solubility is proportional to the influx towards the ecosystem. And we found in every sector the temperature is the most common thing, and temperature can contribute towards the efflux of the CO2 towards atmosphere. Hence, the climate change will affect climate change and global warming will affect more in near future to Sundarban by increasing its carbon dioxide flux towards atmosphere from the mangrove ecosystem. In this slide, I showed some magnitudes and figures from collating different studies and different papers on the Indian Sundarbans. It has been published in 2023. For example, 36.7 teragram carbon per year is the photosynthetic carbon uptake, and 33.6 teragram per year is the respiratory carbon emission. Hence, the net carbon uptake is 2.8 teragram carbon per year. Litter fall is 2.07 teragram carbon per year. Below ground biomass stores 5 teragram carbon. Soil carbon content is 5.5 teragram. Above ground biomass stores 16 teragram carbon. The present mangrove forest area is 1,382 kilometers square. Mangrove loss in last 2 decades is 110 kilometers square, and mangrove gain in the last 2 decades is 81 kilometers square. Hello?
It's a humble request to wrap your talk within 2 minutes, please. It's already 27 minutes.
Okay.
Thank you, sir. Sorry for the interruption.
No problem. And the total blue carbon in the Indian Sundarban has been estimated to be 26.5 teragram carbon per year. Here I showed some adverse effect on the mangroves along the eastern and western flanks of Indian Sundarban and along the central part of the Indian Sundarban. In the central part of the Indian Sundarban, the mangroves are suffering from the freshwater scarcity, sediment starvation, lack of nutrients, high salinity levels, etc. And following these traces, we have found that low canopy density, low leaf area index, and stunted growth in the central part of the Sundarban, Indian Sundarban. Here is a schematic representation of the pollution level in the Indian Sundarban. We have found there are different studies on the heavy metal pollution and the microplastic pollution. And as we know, the heavy metal is absorbed by the mangroves and it translocated from the root, and the bioaccumulation occurs, resulting in the hampering of the physiological growth process of the mangroves. This is my study published during 2016, and using the remote sensing technique, we found that 107 kilometers square of mangrove has been lost during the period of 1975 and 2013. Among the total loss, 60% was washed away by the water, by erosion, and 23% was converted to barren lands, and the rest were anthropogenically transformed to other forms. And about 1,567.98 gigagram carbon has been emitted back. That is a potential CO2 emission from this loss, which may account to $64.29 million in terms of social cost of carbon. So my recommendations, our recommendations on the Sundarbans, how to preserve and restore the Sundarban blue carbon stock, is to estimate a comprehensive study on the total blue carbon stock in the Indian Sundarban. To combat cyclone-induced damage to the mangrove floral stands, the Forest Administration should strengthen the team to cater the damaged trees by pruning them, and planners and policymakers should explore avenues of channeling fresh water into the central part of the Indian Sundarban through different channels from the Hooghly River. And channeling fresh water from the upper reaches through underground canals can alleviate nutrient and sediment deprivation. And to combat the salinity-driven changes in the mangrove species assemblage, locating suitable areas and planting oligohaline species like Heritiera fomes, Nipa fruticans, and Soneraceae, etc. As we know that too much Avicennia species are there, but these plants, these species should be emphasized. Thank you.
Thank you, Dr. Akhan, for very informative talk. Now we will have a question answer session. If you have any question, please unmute yourself and ask the question. I think Dr. B. Gautami has a question.
Hello, sir. That was really a very wonderful presentation, and the presentation was eye-opening. Thank you very much for the presentation. Sir, in your presentation, you also mentioned about salt marsh. And again, you did mention that 1 acre of the salt marsh can sequester more carbon in comparison to the seagrass and mangroves. So I had a question, it's not just about the India, but if you look at the global context also, this blue carbon concept is more explored with mangrove only. And to some extent, they are also talking in the context of seagrass, but very less people are talking in the context of salt marsh. So why there is such sort of difference? May I please know?
So now many people are also thinking about seagrass and salt marshes. But you are correct that most of the people worked on the mangrove, but salt marsh and seagrass has been emphasized later in a few years. They has been studied more. Maybe because that in totality, that is in per acre, the per unit area, the salt marsh sequester more carbon, but in totality, as the mangrove area is higher, so the mangrove sequestered the most carbon, most blue carbon, followed by seagrass, and then third is salt marsh in totality.
Okay, sir. Okay, that's okay. So one more question I had, like you talked about remote sensing integration with your mangrove of Sundarbans. So how did you exactly do that? Is it that you did it with mangroves only, or you also considered the soil part?
No, actually, I am not a remote sensing expert. Although I am the first author of that paper, and my collaborators are remote sensing experts. But I can say that the mangrove parts has been evaluated, and the mangrove and soil parts, I mean bare soil part has not been taken into consideration, and we estimated the total mangrove cover area, and we estimated the change from 1985 to 2013.
Okay. So, sir, I just have one more question. Is it, do you think that will it be possible to estimate the blue carbon using remote sensing? Will you be able to, will we be able to do that in future?
Yes,
Blue
of
carbon
course,
store?
of course, because but we have to estimate first the carbon by ground truthing. For example, we have to estimate the biomass, we have to estimate the above ground and below ground biomass, we have to
Exactly.
estimate the soil carbon, and then we can correlate it with using or extrapolate it using remote sensing techniques. And
Okay,
then
sir.
there
That's
are obviously there are many papers who are estimating blue carbon using remote sensing techniques as well.
okay. So, sir, because you did it on Sundarbans only. So, what is exactly the status of blue carbon in the context of India? Like,
Uh, Yeah, we also did a review paper which has been published in 2022 in the Sustainability Science. We estimated the whole area of
okay.
the blue carbon in India and what are the social costs of that blue carbon. So I can send you the paper if you email
Sure,
me.
sir. I will be
Mhm.
very grateful. I will be very
Yeah, and it
grateful.
has been also published in a newspaper, Times of India.
Oh, that's really nice. So my last question is,
Yeah.
recently we have also seen that these blue carbon ecosystems are also turning into the source of, the carbon. So how do you look into that matter?
So can you please repeat your question?
Yes, sir. So I said it's not exactly that this blue carbon ecosystem when we are talking about estuaries or wetlands, etc. They are not just sequestering the carbon dioxide, but after removal of the vegetation over there, they are also acting as the source of carbon. So how do you look into that?
That is the only thing uh, we have to jump into restoration, and we have to uh, increase the forest area by the reforestation, as we did in case of terrestrial forest. We have to look over on the mangrove forest, seagrass and salt marshes and there are many restoration projects are also going on. So that is the only possible thing we can do.
Okay, so thank you so much. Thank you so much. That was really a very wonderful presentation.
Yeah, thank you for your
Thank you, sir.
questions also.
Anyone else is having question? We can take only one quick question. Okay. Thank you, Dr. Rakham, for your
Thank you.
nice presentation and your time. Thank you so much. So now
But
we
I
will
could
move to
not
our
understand why I cannot present in the presentation mode. It is a misery.
no issues. Like we can see your presentation, so
Hmm.
like it's fine, sir. Thank you so
Thank
much,
you.
sir. So now we will move to our next talk. Our next speaker is Dr. Kunal Chakravarti. Dr. Chakravarti is scientist at Indian National Center for Ocean Information Service in Kuwait, India. Dr. Kunal Chakravarti's research interests focused on the development of a high-resolution operational ocean-focused and reanalysis system, which integrates ocean simulation, observation, and analysis to study the ocean physics in the marine environmental health and ecosystem functioning in the coastal ocean and adjacent deep sea. Over a decade of research, he has published more than 100 peer-reviewed articles. Today, he will be talking on Indian ocean acidification and its driving mechanism. Dr. Chakravarti, your talk will be for 25 minutes, and I request you to please stick to the time and followed by 5 minutes of the discussion. So, over to you, Dr. Chakravarti. Thank you.
Yeah, so good afternoon to one and all, and thank you for the nice introduction. I hope I am audible.
Yes, sir. Yes, sir.
Good. So let me first share my presentation. Can you see my presentation?
Yes, sir.
Is it in full mode?
Yes, sir.
Okay, so is it moving?
Yes, sir. Yes.
Thank you for the confirmation. Okay, so before I start my talk, let me first thank ECSF and particularly Dr. Paul for inviting me to deliver a talk to celebrate World Ocean Day. That is, we are celebrating right now. At the same time, let me thank Dr. Akhand also for providing me a platform where I can immediately start today's topic, which I'm going to speak on. He has already spoken about the impact of ocean carbon and then followed by its variability, specifically in the coastal areas. But I'm sure you can get an idea how it's actually impacting overall open ocean as well as coastal oceans. So I'm going to speak specifically the impact of this ocean carbon variability in the ocean and its impact. So the title generally it comes like Indian Ocean acidification and its driving mechanisms. Before I speak on the topic, let me tell you today's talk will be more on the scientific points of view or the analysis. Rather, it's not based on the policy perspective. So you will get more scientific content in this talk. So I think you need to bear with me for this. And let me go ahead with the next slide. So the presentation is listed with the following topics, or rather the subtopics. So I'm going to first tell about the present status on Indian Ocean acidification, our understanding. Then I will take you to regional carbon cycle assessment and processes, that is recap 2, which we have completed recently. And then I will take you to the modeling system that is developed to study and understand the Indian Ocean acidification. Then we will see the present status of Indian Ocean acidification as well as the status in different sub-regions within the Indian Ocean. And then we'll try to come up or we'll try to see the connection between the climatic modes, specifically the El Nino and the IOD with the Indian Ocean acidification, how they are connected or how they are actually driven or acidification is driven by those climatic modes. And then finally, I will conclude with some sort of conclusions from that analysis. So to start with, belongs to INCOIS, it's and research lab which works under the Ministry of Earth Sciences, Government of India. And you can see in this slide, like our motto is the scientific knowledge for the societal benefit. So probably you are aware of, we have some scientific part as well as an operational wing, which actually provides several services. So without going more details into it, let me directly get into the topic. So if we talk about acidification, it's needless to say that the ocean plays a major role in mitigating the global climate change. And how it is actually doing, it is basically sequestering almost 30% of the anthropogenically emitted carbon that is mostly produced by the humans. So as per the estimates in 2018, it's like 30% it is absorbed by the ocean itself. And the most immediate impact of that specific uptake of anthropogenically emitted carbon is that ocean is become relatively acidic. I'm using the word acidic with relatively acidic. So you need to speak with a caution when we talk that we are going to study Indian Ocean acidification. So we cannot live in an acidified ocean, but it's becoming relatively acidic. That we need to understand. So as per the other estimates, those are available like 2004 onwards, there were estimates which tells like Indian Ocean, which is actually smaller compared to the other global oceans like Pacific Ocean as well as Atlantic Ocean. But 16% of the total ocean uptake that is being taken by the Indian Ocean. And in terms of a number, it is like 16.6 petagram carbon. So although Indian Ocean is smaller compared to other ocean, it actually absorbs a significant amount of carbon. So automatically it's a reason that it's becoming, there are certain parts which becoming relatively more acidic in the Indian Oceans. Now, if you see the available estimates, the Western Indian Ocean, it's becoming more acidic based on a study that was carried out by our colleagues in IITM. That is the estimates are 0.07 pH units in the last 50 years. And don't consider think that number is very small. You need to actually convert into H+ ions, and that will give you an understanding how impactful that number is. And if I talk about the entire Indian Ocean, there were estimates from LOBSET 2015, and they come up with an estimates that Indian Ocean is acidifying with 0.027. That is the rate per decade. However, here, I would like to mention that their estimates were based on limited number of observations. So there were SOCAT-based data. It is seep-based observation called SOCAT, S-O-C-A-T. It stands for Surface Ocean Atlas, CO2 Atlas. So if you see that SOCAT database from Indian Ocean, the number of observations are literally very few.
Any questions from the audience?
So it means that either everybody understood very well or nobody understands. Anyway, so feel free to write me if you have any questions, probably in a later stage.
I have a question, Kunal.
Yeah, please tell me.
Okay. This is a question for the students. I was listening your talk.
Yeah.
Now, see, that's your one of the things that's I would say ocean modeling or ocean science in terms of physical science. It's not a mainstream in India. As a mid-career scientist, what do you think that India may do slowly to introduce this sort of science in a more mainstream fashion
So more and more like people take up this opportunity as a result. Why I'm saying this fact, because I remember tsunami, and after that India started developing its or observational systems slowly. So these days both the casualties as well as the weather predictions are much more accurate, and people are getting directly benefited from that. Ankade. So I think this needs to if it goes to the common mass, because it is benefiting directly to the common mass. So why not more and more Indians can join to it to give hands? So this is a platform from where if you have a personal message also to academicians and the academic structures, okay, what would be your personal message in that case?
Okay. See, you have actually correctly pointed out in one, like if I just say one line, the message what you wanted to convey, we are really lacking in terms of ocean modelers specifically. We may have ocean scientists, but the people who can actually work on models, we really don't have enough in numbers. So we need to understand one thing. In terms of subject, these earth system science or categorically ocean science, atmospheric science, it's an interdisciplinary research area. So you can't actually have only a degree to work on this specific area. So the people, like in our institutes, if you see mostly in MOS institutes, the people from basic science, let's say physics, mathematics, chemistry background people, they are working on. In terms of marine science, they work, like there are several people working on, they have the background from physical oceanography, chemical oceanography, biological oceanography. So they used to work on this. Specifically nowadays, the people from meteorology also, they used to work on the ocean science. So it is an area which is purely interdisciplinary. Now, if you just talk my background, I come from a mathematics background. Before joining, I was not aware of anything which really like how ocean size actually is dealt with, or really we do have this kind of an forecasting system and all. So my understanding is that we don't have proper understanding or awareness. These are the areas where student can also venture. Indeed, they require some sort of good understanding in the physics, maths, as well as probably the areas which deals with ocean and atmospheric science. So they can see it is not like soon after getting into this field, you will become an expert. You need to spend time, you need to understand the interdisciplinary research that is being going in this particular area. And I believe in India, it's a country where there are lots of people available, or specifically students available, who are really very good in physics, maths, or even that specific physical oceanography or chemical oceanography. And they can really venture into this specific modeling area, and they can grow much faster compared to the other areas where I feel the career progression or the development will be much lesser compared to in this specific area. But indeed, you need to take a firm call. You need to probably see a physicist. You need to take a call whether I will go for a PhD in physics-based some area, or I would like to venture atmospheric physics or ocean physics. So that a firm call that needs to be taken during after the completion of your masters. And if you can take that kind of a bold decision, probably you will be able to survive quite well in this specific area.
Thank you. Thank you. Yes, it's sometimes like the students who are reading in the undergraduates and the postgraduates, they feel not much connected, because these are not conventional subjects that we are talking about. This is something that starts at the higher research level, not even at the many entry level. That's you emphasize. So yes, a lot of the participants here is students. So maybe you have a road that you can also build your career not only in conventional physics but maybe also in ocean physics. Thank you so much. Over to Chimli. Thank you. Thank you, Gunalda.
Yeah, thank you.
Thank you, Dr. for your and enlightening talk. Thank you so much.
Yeah, it's
So
my
now
pleasure.
we will go. So now we will move to our next talk. So our next speaker is Dr. Sabyasachi Sathya. Dr. Sathya is a senior scientist at CSIR National Institute of Oceanography, NIO, Mumbai Regional Center, India. His research interests focused on benthic invertebrate taxonomy, modeling on marine benthic ecosystem functioning, conservation of marine biodiversity, exploration of deep sea habitats and their associated benthic community, marine pollution, environmental impact assessment, coastal process, and their relation to benthic communities. He has published about 50 peer-reviewed articles over the decades of his research. Today he will be talking on the hidden world beneath, exploring benthic biodiversity in the Indian Ocean, coastal to deep sea. Dr. Satya, your talk will be for 25 minutes, followed by 5 minutes of discussion, and I request you to please the time strictly. So, the platform is over to you.
Hello. Yeah. Am I audible?
Yes, sir.
Oh. Thanks for a short, brief introduction about me. And I would like to first thanks to Dr. Saurabh for giving me this opportunity to speak a little bit about benthos and oceans. So today is a World Ocean Day. So can I share my slides now?
Sure, sir.
Oh. Is it visible?
Yes, sir.
Okay. So first of all, happy World Ocean Day. And though it is, we say happy, but nowadays this world ocean is not in the happy state. So before we go directly my topic, I just would like to introduce little bit the fact about the oceans. We all know about that the oceans cover more than 70% of the Earth's surface, and 80% of the all the life on the Earth we can found in the oceans, and more than 300 crore people rely on the oceans for their livelihood. That is very important. And but though those are a huge number of people, they rely on the oceans for their livelihood, but still the ocean has been protected only the single 1% legally throughout the world. And then it's a very important factor that what we get for our survival, that oxygen, more than 70% oxygen basically comes from the oceans. And there's a few facts. So I will directly go to my today's topic. It's not going. Yeah. So I'll be talking about that benthic biodiversity. I works on benthos, and today I'll be talking about the benthos in the Indian Ocean. And this is the outline of my talk. The first I'll talk about the very basics about the zonations, and this talk actually I structured for the people, mostly for the generalizations and because most of the people, I believe, are not very much aware about that benthos, especially for the coastal area and the deep sea. Coastal area, maybe the few people know, but the deep sea. So that basics I will talk about, and I will explore about some benthic community from the different coastal habitats as well as that deep sea ecosystems. And then I'll talk about then how do you study the benthos like that way. So not directly the single topic exactly we discuss over here. It's a quite a generalized topic. So we talk about the oceans. We all know that oceans are the 5 major oceans we are having, and we talk about the zonation pattern because ocean, the geophysically, the geomorphologically structures is like that. And they having the continental shelf, continental slope, that mid-oceanic ridges, trenches. And if you see the right side of the picture, the zones lies about epipelagic, then mesopelagic, bathypelagic. So there are different systems or zonations in the oceans, and based on these zonations, the organisms they diversify, they classify also, because when the depth increases, the pressure also increases, and that difficult for the various animals or organisms to sustain in that different pressure. So the kind of pressure is adaptable, those organisms are present in those depths. So my topic is marine benthos. So benthos is basically the organisms which living on or bottom of the body of the water, and they have the different strategies for their life. Like they sometimes they attached, sometimes there's free movement. They can freely move from here and there, and then burrowing in the sediments. So these are the three the main benthic life strategies, and they also play a role like secondary producer in the trophic structure. And then they have a very good ecosystem functioning capabilities, which we talk about the sediment reworking capabilities, and which is a very important factor for the nutrient recycling on the sediments to the water column. And then they can also consider as one of the pollution indicator, and very much useful for the biomonitoring program in the various environmental impact studies. And they classified based on the various sizes, like very small sizes less than 63 micronits for a microbenthos. Then their classification 63 to 500 we call as a mio, then macro, mega, like that. So what basically the importance of these benthos, why actually we need to so much interest to study about it, because they have a very big functional role in the ecosystem functioning as a secondary producers in the ecosystem, this pyramid, food pyramid. This they have a very good functional role to be played. They are like a they have very much burrowing capabilities, few organisms having the tube dwelling capabilities. Some can crawling. So why I'm talking about all these their capabilities, these called functional traits. So different organisms, they are having the different functional traits, and those functional traits basically play a different role in the ecosystem functioning. Suppose some burrowing organisms or maybe the tube dwelling, they are having the system to regenerate the nutrient recycling in the sediments, and similar way then other organisms and other ecosystem functions they are playing. So that's why the different organisms have the different capabilities. So we first we what we do, we identify the organisms. It's very basic. We do the very basic science. We do identify the organisms, and after that we understand their functional traits, means what are the characteristics they are having, and based on those characters we try to understand their ecosystem function process. And after that we do different modeling studies and to understand the how the ecosystem process happening in that region, so we can also predict the future for next 5 years or 10 years, what will be the ecosystem structure in that area. So now I will show you some example of coastal habitats. So what kind of benthic organisms sustaining in these coastal habitats? Coastal habitats having the different type of habitats like muddy intertidal region, then subtidal region, which having the depths around 10-15 meter we consider, and then we have the rocky intertidal zone. So this is a example of muddy intertidal. And muddy intertidal, I believe most of the people know here, like in Sundarban they have visited. So it's a very much muddy substratum you can see, and there's a mud skipper, Boliphthalmus, and then a lot of gastropods you can see. Then we can see Windopan Wester, then mud crab, and those things also. The different people, they collect these mud crabs, bivalves for their livelihood, and then there are different of avifaunal communities present in very much like a high diversity in this ecosystem. And then this is some example of sandy shore habitats. So sandy shore habitats is a different area along the 8,500 kilometer coastline area in India. We have the side like Gujarat to western side, then north to south we go, Kanyakumari, then this side eastern side to West Bengal coast. So we have the very different what you say in sandy habitats in a different region. So based on that latitudinal and longitudinal variations, there are a lot of community structure variations available in those sandy shores. And then how this rocky shore habitat look like. These are some examples of Mumbai and along the Maharashtra and Gujarat coast. So the habitat of rocky shores are very much different along the different coastal regions. And these rocky shores are pretty much, you can say that productive in terms of biologically very much high diversity found in these rocky shore habitats. I will show some example of these rocky shore faunas. So there are plenty of like arthropods, then you have gastropods, you have molluscans, bivalves, then anemones, cnidarians, other groups, and like you have bryozoans, you have corals, and then you have a lot of different communities available in this intertidal region. All comes under this benthic community, and this is a subtidal region looks like. And okay, so those are some examples. Now we see how what are the like intertidal after the subtidal looks like. So then we when you go for the diving, and we see the pretty colorful world in this subtidal region. So the subtidal region also very much I mean it's like very highly diverse in terms of corals. If you see in west coast of India, there are a lot of coralline region, Gulf of Kutch, the first marine national park in India. And for the coral sector, if you see the more than 450 species in India have been recorded, while the Andaman having the highest record species of the corals like 424, and while Lakshadweep is 104. And these are some examples of Gulf of Kutch corals we visited a few years ago. And then this right side we can see the Mumbai coast. Mumbai is a very highly urbanized city, but still we are having the corals like 7 to 8 species corals we found. Though these corals are known to be very much adaptable to these harsh conditions, but still we have the coral diversity here. So now I come to this deep sea ecosystem, and how this ecosystem, what are the different ecosystem in the deep sea and the life. The deep sea, as we know, it's very much food limited, and the largest ecosystem in the earth food limited because they are away from that mainland, I mean like the terrestrial areas. So the carbon carrying is very much less in these areas, and the species diversity estimated to be very high, while the density found low. And the different adaptation strategies we found in the deep sea, because also we have observed very bigger organisms in the deep sea. And if you have learned about this giant isopods and giant crabs, they are quite big. So now the background of the Indian Ocean expeditions, if you see, during the year 1881, we have started that Investigator 1 during the Royal Indian Marine Ship. And then it has been started after that 1908, then expedition continues, then British Challenger expeditions took place in 1872 to 5 years, 76. It has a very huge expeditions throughout the Indian Oceans. They have been collected lot of data sets like physical, mostly the physical and chemical data sets they have collected, and for benthic and other biological data. Mostly they collected pelagic communities data compared to benthic, but still they have collected many benthic communities along the Indian coast in the sense like most of the depth it was limited up to 200 meter. So apart from that, Mavahis, then German expeditions, all these you can see in this slides. These expeditions happen in the Indian Oceans, and they have started reporting these benthic communities along this Indian coast as well as this Indian Ocean. So now I'm showing some example of our past studies. We have studied in that oxygen minimum zone. As you know, that India, Arabian Sea is a very much influence about that oxygen minimum zone, and morning, I think Sudesh was talking about some oxygen minimum conditions in that area. This study also related to the same. Regarding that, we studied the benthic community structure, and then we found some kind of adaptation strategies. And it was found that shelf area and before the shelf, that benthic communities were quite higher, while the oxygen is lower, not much lower, means like above the OMZ region. But while the OMZ regions, that community diversity was very low, but then the density was not much lower in that conditions. But that we have observed that some adaptation strategies in this region, like some polychaetes, they have the well developed branchial structure, that because of this oxygen consumptions or the respiration rate. So this is the YMZ region, and then there are some studies found in this oxygen minimum zone, and these studies from our recently we had the expeditions, and then this is the meofauna. Earlier studies was the macrofauna, and this is the meobenthos studies, and that there we found also the similar study, the macrofauna, the oxygen minimum zone having the lower diversity, while the other upper and lower oxygen minimum zone, while the deep sea is very higher diversity we reported here. And now the different habitats in the deep sea is a seamount. Seamount is another very interesting subject, and we do have the seamounts in the Indian Oceans, because the seamount mostly we can see where the mid-oceanic ridge channels, mid-oceanic ridges are present, and those ridge areas, the fault areas, the mountain comes. So we see the mountains in that our terrestrial region like Himalayas, Western Ghats. The similar way, the mountains also available in these oceans, and mostly the mountains like Arabian Sea and Andaman Sea are available. So some studies we did in Andaman seamounts, and we found very interesting communities along the Andaman seamounts, and many of the organisms were new to the science. So this Back-Arc Basin region, this is as you see, this is the Andaman Island, and this side is called a Back-Arc, and this side, that left side is called as a Fore-Arc. And this Back-Arc region, this is a CSM seamount. The CSM is a cratered seamount actually. This recently our colleague studied, and they have published a paper. It shows that this seamount is still in hydrothermally active. So it is a gas flare they have reported, and geochemical people, they have also suggested that evidence of this hydrothermal anomaly. So recently we also had expeditions, and we collected few samples over there, and this process it's under processing. But earlier we studied in these regions, we are having a very high diversity in this crater area. This the top of this seamount, it's called a summit, while the flank and the basin having the very less organisms. So why this is a very higher? The reason is that this Andaman Sea is an oligotrophic region, but we do not have much productivity like water column productivity. But still the benthic community is very high because of this hydrothermal activity. There are highly productions of this microbial community. So that basically suggests that other community to thrive in these conditions. And these are some example of how this seamount through the world oceans, the bird nest sponge we reported, and the different type of data we generated, and the community we added in the world ocean map. So that this top two graphs showing that how that seamounts in Indian Ocean, and this 41 and 20, 42 and 21, this number of species we added to the Indian Oceans, while the community of poriferas, we added this Indian Oceans to this global map. And then this Pheronema is a very, bird nest sponge is a very interesting sponge species, and we are working on it still. That is also collected from this seamounts area. And also this amounts why it is a very interesting area, because we do have very endemism means very like specific to that habitat those organism present. So the endemic species are means pretty much available in that seamount. So seamount, we got the new species, and many new species like 4 or 5 new species we discovered from these amounts, and still we are working many more, and hope those are also new, some new genus, some new species. So the area is very much interesting to study for the benthic point of view. So now we talk about this mid-oceanic ridges. Mid-oceanic ridge, basically that seafloor maintain system formed by the plate tectonics. We have a major 5 major plates all over the oceans, and this Indian Oceans also having this ridge pattern where we are having that ridge fault, and there you can see this is a triple junction ridge, and this area was also called the Carlsberg ridge. So these areas are very much highly chances of this hydrothermal vent presence. And this area also we have studied the megafaunal community along this ridge area. There we used underwater images and videographic survey because the area is very much of rocky, so we cannot operate our different type of gears like for collecting the samples like grabs or any kind of box scores. So we use that underwater image systems, and we have observed different type of organism, more than 100 organisms we have identified from these regions, and it was the firstly quantitative explorations we have done these areas. And there also we found many new genus and species from these areas. And now hydrothermal vent. So hydrothermal vent, it's a geological and geochemical features. While there is a fault, when there is a fault, then water recedes inside this through this fault, and after that sometimes they comes to the different way, and they form a they carry a lot of sulfurs and other minerals from the earth elements, and they comes as a black smoker. So this area called as a hydrothermal vent. But the hydrothermal vent is a like a heaven of organisms. There are a lot of vent communities present nearby the black smoker because of this some sulfur reducing bacteria is available, which having the symbiotic relationship with all these organisms like giant clams. Then this is the tubes, Ripsa pachyptella, and then a lot of other shrimps, animals. So different type of organisms, they do not have to go to the any other area for their food, because the bacteria, they have the symbiotic relationship, and from there they get the energy. So this is the basic formation in the hydrothermal vent communities, and we do have in Indian Oceans this hydrothermal vent. Though still from Indian scenario, Indian context, it is not been discovered till now, but from the outside of India, it has been discovered in the Rodriguez triple junctions and some other areas. 2 3 hydrothermal vent already discovered in the Indian Oceans, and you can see some photographs from the different parts of the world, including the Indian Oceans here. The figures E, and this figure is like from the Indian Ocean. So, and also another ecosystem is a cold ship. It's a like a vent, hydrothermal vent. Similar thing is like a cold ship, but their formation is different. The methane gas hydrate, they trap inside that their sediments, and then once they come out, that gas seepage happen in that region. And the similarly, the methanotropes bacteria and then other vent communities started growing in these areas. So that area also consider kind of a very high biodiversity hotspot, and that also we have in our Indian EEZ area. It's called a KG basin. So recently our NIO scientists, they have discovered this cold ship near that KG basin, Krishna Godavari basin in that region. So now we talk about biodiversity in abyssal plain. Abyssal plain, it's a very deep oceans where it's in, and also the one of the largest ecosystem on Earth, we can say. This abyssal plain mostly more than 4,000 meter available in this Arabian Sea as well as Central Indian Ocean. So in abyssal plains in Indian Oceans having the very high amount of polymetallic nodules, which is a very uh, high resource of, you can say, cobalt, nickel, aluminium, iron, all these different elements. And we have in India, Indian Ocean, 1,50,000 square kilometer area. These polymetallic nodules zone have been discovered by India, and it has been designated for this mining purpose first to the 50% of that. But there are a lot of data has to be generated before we go for the mining and the permissions and under International Seabed Authority. So that research and that study is continuing under the Ministry of Earth Science, and NI is also one of the major part for these EIA studies. So this is the some basic pictures and some information about the benthic community, because you can see this polymetallic nodules here in the town, and these organisms found in that region, like different type of isopods, tanids are very much diverse in that region. Apart from that, polychaetes are also available. So some associated communities. So I'm not going for the detailed name of the species. I'm just showing some example of the different ecosystems, how it looks like, and the ecosystem, and then what is the importance, and how the communities. So now I'll talk about some methodology, how we study the marine benthos, like sample collection, analysis, and data interpretations. This is some example of intertidal sampling, how we go for the intertidal sampling, then for the macrofauna, for the meofauna, and for the megafaunal survey, the line transect survey. So we go and collect that some different method, like for meofauna use a simple core and like 3.5 centimeter, while the macrofauna, and then we use quadrant method. And for this megafaunal line intercept transect method we use. And then we, here you can see some pictures of subtitle sampling. We go in the boat and we collect different samples, like for chemistry, for biology, we for benthic we use grab mostly. We then we collect, then we process these samples on board, and after that we come to the lab, and then we go through several process, like washing, then they have centrifuge, then after that microscopic sorting. So that we do for these coastal samples. And for these deep sea samples, now we are having two ships, like one is a big ship over here, you can see this RV Sindhu Sadhana, and another small ship 56 meter, that is RV Sindhu Sankalp. And we have a very good facility in the ship. We have a multi-core, then box core. I'm talking about the benthic collections, multi-core, hard, then box core, sped core, and then we have a good lab facility on board, so we can process all the samples over there. Then we have microscopes, very high-end microscopes also there. So whatever the basic processing we do on board, and after that we come back to the lab and we do the further study. So these are some photographs example on board. And also, as well as we do that AUV survey, the automated underwater vehicle, that we do for the different kind of megafauna, as well as that estimation of polymetallic nodules. So these are some example pictures, how we see under this underwater, like deep water. This depth of these photographs is around 5,500 meter. So this what we do program all these instruments AUB, and it goes to that certain depth. So that depth may be 5 meter above from the sea bottom, and then it continues and takes the photograph. So suppose we have program for 1 kilometer by 1 kilometer. So it goes through that wide and length 1 kilometer by 1 kilometer and takes continuous photography. Might be 2 lakhs or 2 lakh 50,000 photographs it takes, and then comes to the surface, and then we collect it and then download all the images. Then after that we have several series of processing of these data, and then after that, after taking those image, we do a lot of other processing to identify those. So this way we do the image processing studies, and some kind of video observations also is there, and these are some examples how we do video observations, and then we collect and process the data. And some examples of photographs we observed in the underwater video images. So these are photographs from the Carlsberg Ridge area, we already showed in earlier slides. Some holothurians, some poriferans, sponges, corals, then you have crinoids, brittle stars, like that way. And at the left side we decide the different type of habitat categorization. Based on that habitats, we quantify how the organism distribution pattern available in that area. So these are some example of video how it looks like underwater. I hope everybody can see. So it's a 7 seconds video. So this is from the top of these Andaman seamounts. So see, so much of corals bed, then so much of archins, then sponges are available. So now I have shown you the various examples. Sorry.
Sorry to interrupt you, sir. It's already 27 minutes. So
Yeah,
we need
I
to
have
wrap
only.
up within 2 minutes.
This is the last slide. So I'm only.
Okay, sorry.
So this slide why I'm showing is very important, because nowadays everybody talks about the pollutions, conserving the ecosystem. So whatever I have shown you all about the basic information of the benthic community or the biology. So but then we have to be responsible to conserve those biodiversity, because it has an immense role for the ecosystem functioning. So these are some threats for the marine biodiversity, like oil spill, ocean acidification, also the domestic sewage, noise pollution. Most of these threats are man-made. So it is like achievable to be reduced so that biodiversity can flourish more. So thank you very much for listening me. If you have any question, please.
Thank you, Dr. Satya, for your elaborate talk on benthic biodiversity in Indian Ocean. The forum is open for discussion now. So if anyone is having question, kindly unmute them and ask the question. Anyone is having any question? Okay. Sir, I have a basic question. Like, sir, as you are working on Benthos, so have you encountered with any amphibian fauna? Because from the Mumbai coast, we know amphibians are available as biofouler. So have you seen it? Because you are going for snorkeling and dredging, I assume. So there any amphibians and anyone is working from your lab?
Yeah, acidians we observed in the Mumbai coast, but presently we are not working on acidians, because we focused few communities, because our most focus is in the taxonomy and their ecosystem functioning. So acidians, yeah, it is a good, but we are not working. But it is found in this one, our Mumbai coast, and we have recorded also. I have shown the picture. No, there is also acidians are there.
Okay,
Here,
might have overlooked.
there is the question, I think there is a question, Jimmy. Aritra Bhattacharya.
Yes, the question is from Aditya Bhattacharya. Have benthic been used as indicator of system health, especially for wetlands? Benthic communities are the main source of food for migratory weather birds.
Sorry, have benthic communities been
So
reduced by the
have
indicator
benthic.
health? Yes, yes. The first is yes, because there are a lot of species available. Suppose if I take example, some polychaete species or maybe some nematode species, polychaete species like Mediomestus, some species will be there, Capitalidae families. They are quite adaptable to various kind of pollutions, like some industrial effluents, you can say, like nutrient pollution also, they are adaptable. So in that case, suppose there is a pollutions, these species might not get deleted from these regions. They will flourish in that area, but the other species may not be occur or may not be seen in that area because of the pollutions. They will be vanished from the area, but these species will be dominated. So if you have the data of this pollution and like polluted area and non-polluted area, so the diversity will let you know the where the diversity is more, that area is a little bit good or better than the polluted other area. So that when the species, we know some species are indicator of the pollutions, so these species are dominated in that area. Based on that, even if you don't have the chemical data, you can say probably this area is polluted because these are indicator species. So it is a kind of ecosystem health indicating. And also, yes, especially for the wetlands where the benthic is the main source of food for, yes, it's a very important question actually. Unfortunately, we cannot. Unfortunately, we can't help in these areas because we can't help the birds to stop to coming over there in the polluted area. So they comes, they eat those foods, and especially from my observation and my experience, I have seen where the more pollutions, the more birds come over there because of the dominancy of that like benthic communities, because they have those benthic like species as a food. So based on that, they comes over there, but it's a very bad for their health actually.
I have a question, Subhayachi.
Yeah, please.
Well, this is a more of a technical question. That's like in a very big estuary like Ganges. What would be like the benthic part of the Ganges is almost unknown.
Correct.
Right. It's our most iconic river of India, but its benthic ecology is almost unknown. Do you think like what could be the especially at least on the estuarine zone? Do you think by dropping grabs and the traditional benthic techniques that you the follow would be suitable enough to considering there is a significant current in the system like Ganges? Do you think that would be applicable to study these sort of ecosystems?
Yes, this is a very good point and also the important area to be covered in future actually. And I think I agree with you. This basic study of the benthos will be very helpful because there is no data at all from this Ganges estuary. There might be few data from Sundarban that is associated to your mangrove area, but from the estuarine region there is no data, though it is a very big estuary. So I think the baseline data is very important to be generated in these areas, and for that you just collect sediment. It's a very basic work, but the work is very much you can say is a laborious, but it's a very patience work you have to be. And yes, the baseline data has to be generated. What we do, our the basic science has to be very strong. Unless your basic science is strong, so you can't go for the other step, for the further step.
Thank you, Sabhusachi. Thank you very
Yeah.
much. Thank you.
And I'm thankful to you for inviting me, and I hope that this your foundations go ahead more and more. Thank you very much. Yeah.
Thank you. Over to Jim Lee.
Thank you, sir. Thank you, Dr. Sakya, for that talk. And now we will move to our next session, next talk of this session. Our next speaker is Dr. Sean H.P. Dazel.
Dr. Mondal, you're not audible. Dr. Mondal? Dr. Mondal, you are not audible. Dr. Mondal, you are not audible.
Dr. Mondal, we cannot hear you.
Dr. Mondal, you are not audible at all. Please unmute yourself.
Sorry, am I audible?
Yeah, from now it's all right. Now it's all right. Yeah, you are not audible for the time being, so we can restart this. Yeah, you can restart.
Sorry for this technical problem. So thank you, Dr. Satya, for a very nice talk. And now we will move to our next talk of the session. Our next speaker is Dr. Sean H.P. Dazel. He is Science and Data Coordinator, Plankton Ecologist at NRF Sion Wandel Coastal Node and Research Associate at Institute for Coastal and Marine Research, Nelson Mandela University, South Africa. Sean is a plankton ecologist with the South African Environmental Observation Network, where he coordinates operations, business, and data management portfolios. Sion Wandel node is responsible for establishing and maintaining ocean observation networks and to undertake long-term ecological research. Sean holds a PhD in estuarine ecology from Nelson Mandela University for research on zooplankton responses to extreme events. For the past 15 years, Sean's research has mainly focused on coastal pelagic ecosystems. Broad areas of interest are oceanography, macrozooplankton and zooplankton community ecology, climate change drivers and responses, ocean observation technologies, and information systems. He leads the Pelagic Ecosystem LTL program established in 2010 as the plankton monitoring component of Sion's flagship LTL network, the Algoa Bay Sentinel site. Current pursuit involves the development of national and a information that disseminates. Today, we of
Thank you very much. Okay, I'll take that as my cue to continue. Thank you very much for the kind introduction. I'll just start my presentation quick. I'll assume everyone can see my presentation. My slides will reflect, otherwise I'll continue. Thank you very much for the introduction, and especially to Dr. Paul and colleagues from the ECSF for the invitation to share with you today some of SCION's activities and resources in support of marine science in South Africa. And I give this presentation in the spirit of networking and collaboration, and just as an example of how we approach some of these problems in South Africa, and hopefully we can learn from these things as a group. So yes, as was said, I represent the South African Environmental Observation Network. We're a business unit of the National Research Foundation and funded by the South African Department of Science and Innovation. So this is the government-funded initiative, and we are at service to the South African community. As many of you may know, South Africa remains one of the most unequal societies in the world, and a great many of South Africans live under the poverty line and are subjected to the negative effects of climate change and global change. And it is therefore imperative that everything we do is in service of some of these problems. So how do we address some of these challenges? Prior to the establishment of the South African Environmental Network, there was no single entity tasked with thinking about and working towards long-term information. Addressing some of these challenges is rooted in information. Information informs policy and advises how we should mitigate some of these negative effects. So SCION as a concept was birthed in 2002, and we received funding shortly thereafter, and was officially implemented in 2006. We are a distributed network throughout South Africa, and our task is to conduct long-term ecological research and to establish research infrastructure in support of research and the community, as I've said many times before. But it is an imperative mandate that is almost our true north with everything we do. So we cover most of our terrestrial biomes in South Africa. There are one or two exceptions, very complex terrestrial ecosystem matrix exceptions. And then we've got two nodes that are concerned with marine ecosystems. The offshore node is based, and I'll use my laser pointer just to point on a map. If it's visible down in, so this is a map of South Africa, down towards the west part of our coastline in Cape Town, the eGagazini node is concerned with offshore systems and Southern Ocean research. And then we are based in Gqeberha, or formerly known as Port Elizabeth. As a whole, the South African Environmental Observation Network is also custodian of three massively funded research infrastructures. So these are long-term commitments by the South African Department of Science and Innovation towards very specific research themes. Shown on the right bottom part of this slide, you can see three of them. The South African Polar Research Infrastructure is executed by eGagazini node. The Extended Freshwater Terrestrial Environmental Observation Network is executed from inland and basically involves all of the terrestrial territory of South Africa. And my node, the one-layer node, the coastal node, is responsible for the shallow marine and coastal research infrastructure. The shallow marine and coastal research infrastructure is basically an extension of our Sentinel site approach, which I'll talk about more, and it's an expansion nationwide. We are based in, as I said, in the southeastern part of South Africa, in the port town of Gqeberha, formerly known as Port Elizabeth. We're nestled in a bay, in a crepuscular bay, in temperate seas. Our water temperature varies between about 11 and 24 degrees Celsius, and major features of this particular bay, and you'll see the context why I'm focusing on this a bit later, is the Gullis Current, Western Boundary Current, major feature of our area. That comes quite close to Algoa Bay before it retroflects off the shelf to the south of our country. It is a very productive ecosystem. This is where, for those of you who have heard of the massive migration of sardines along up the east coast of South Africa, is one of the great natural phenomenons of the world. They start aggregating in Algoa Bay, and these sites and photos you can see towards the right bottom corner of the slide is it's not uncommon in a bay. So extreme biodiversity and productivity with massive conservation importance in the regional sense. Because of the temperate climes, this is also a part where people interact greatly with the natural resources. We are the water sports capital of South Africa. So lots of people enjoy the ocean and the beaches and the surrounds. It's also an important aquaculture and other blue economy industry nexus in the country context. So big fisheries, we've got 2 ports, commercial ports operating in the area. And this also brings massive social responsibility, which makes it for interesting research areas. So people care what is happening in the coastline. People care about, what is happening with the ecosystems, and they pay attention to the research activities. And more importantly, they keep us honest in terms of what we research must matter. And this is one of the themes that you'll hear throughout my talk. We, as an organization, we are hosted by the Nelson Mandela University. We were very fortunate to co-design the Ocean Sciences campus. This is a brand new campus on this university grounds, where we managed over the last 5 years now. Time flies. 5 years now, we've managed to resource functional laboratories and workshop spaces and functional areas in support of our activities. So we're very grateful for this partnership with the university, and it again shows the value of establishing these networks of in the spirit of working together between organizations. So our mandate through the shallow marine and coastal research infrastructure, like I said before, is a 15-year funding commitment from the Department of Science Innovation. This is what the full extent of the mandate looks like. Our objective is clearly worded in the bottom right corner of the slide there. It's basically we want to establish research infrastructure throughout South Africa, guided by important research areas with a long-term view. And so we're responsive to short-term needs in terms of what do the research community need, but we also keep a firm eye on how do we answer long-term ecological problems and questions. These are research platforms that cannot necessarily be maintained by any one department or university, so it stretches beyond that scope, and it is always at the disposal of the research community. So all of our platforms and our data is available at the open basis, so people can come in and make use of our equipment and our resources. In total, there are 15 platforms. Some have a national distribution, so I will talk to some of these in more detail. And then some are more clustered in specific areas. And the reason for this has got a lot to do with the bioregions around South Africa. As you can see the model animating in the top right corner there, the influence of the Gullis Currents on the east coast of South Africa, and brings, you've got subtropical bioregion towards the eastern part of South Africa, which is quite different and contrasted by the cool, temperate region on the west coast of South Africa, as is influenced by the Benguela Current. And then you've got this very, very interesting section along the south part of our country with the extension of the Gullis Bank. And you can see how complex the current interacts with this bank. So roughly, we've got 3 biogeographical regions that affects the biodiversity and distribution of organisms, also productivity and how humans interact with these spaces. So part of our strategy is to place some of these research infrastructures very strategically in areas where it can offer reliable information and supportive research. And that is pointing to the Sentinel site concept that we have implemented from the start. And we started with our Go Bay Sentinel site. And it is in essence an area of intensified investment in research infrastructure. We established our Go Bay Sentinel site was the first thing we did in 2008. And this is the full extent. This map shows about 300 kilometers of coastal reach. And each of those symbols represent either a mooring that is permanently deployed, that offers continuous measurements of mostly physical oceanography variables, temperature and currents, and also repeat sampling stations. So these are stations that we visit at periodically, either monthly or quarterly for other purposes, and I'll go into more detail. Our reach also extends into specific estuaries. There are 5 within this region that we do very similar things that we do out at sea. We also do in the estuaries. And the objective is quite simple: maintain this indefinitely. And so that we can contribute to the time series and catch up to the many international long-term data sets that are already available. We're quite behind. Even though there are good examples of long-term data series in South Africa, they were never collated, they were never coordinated and backed by solid funding opportunities. So this is basically our DNA and of what we do, and I'll just unpack some of the components of a typical Sentinel site. And what we do here, we intend to expand into other Sentinel sites. So this is one of the programs entrenched in the Sentinel sites. We call it our continuous monitoring platform. It's basically a study of physical oceanography over the long term. We've got over 40 moorings that have been deployed over the years. These provide delayed data, so it's not real time yet. These are underwater temperature recorder arrays that we place in specific areas. And to that rope, you can attach various sensors, mostly temperature sensors, but we also got acoustic receivers and hydrophones and other instrumentation. And then the second element is acoustic Doppler current profilers for profiling currents. And this has greatly improved over the years the way we understand the physical oceanography of the area. And we also find that this is one of the most useful data sets that support ecological research. This is extremely popular, and constantly we make our data available for those type of studies. Most of these moorings we used to service on scuba, so that restricted where we could deploy these moorings. Hence you can see the pattern of deployment along 30-meter contour lines, so that's for safe diving. Nowadays, most of our moorings are on acoustic releases, so that allows for deeper deployments in areas. The second program I would like to highlight is the Pelagic Ecosystem Long-Term Ecological Research Program. This is one of the programs I'm leading. So this is a long-term study of plankton dynamics. We started in 2010. It is based on a set located stations that we sample on a monthly basis. The scale here is about 65 kilometers across the bay. Sorry, nautical miles, I beg your pardon, nautical miles, so it's quite wide. And it's a full day expedition. So we are quite proud of the rate. So our objective is always to maintain a monthly sampling protocol. To date, we've achieved 142 cruises out of a possible 171 months. So our success rate's 83%, greatly impacted by the COVID period, of course, and other elements, boats not being available and crew. But we're quite proud of this data set, and it's growing. And it's standard variables. So with standard, I mean we conform to essential biodiversity and ocean variable principles, the GOOSE principles, and so that our data become useful and relevant internationally. And then it also integrates most state-of-the-art and integrated approaches to unlocking this biodiversity information. And we've got a whole team resourcing this particular initiative. Next is estuaries. So this is actually a national program, but it started in the Algoa Bay Sentinel site. As I said before, we've got 5 estuaries within this reach, quite all permanently open systems. And the configuration is we've got moorings that we deploy that measure continuously conductivity, salinity, and temperature. And specific parts, key parts of the estuary, mainly lower, middle, and upper, so that we can track how the water changes and salinity profiles and temperature seasonally and those type of parameters. Anyone who's worked in estuarine ecology would know a mere 15, 20 years ago, I would have probably killed for data like this to have continuous salinity measurements. And now we've got hourly measurements to our disposal that's extending more than a decade. So this is a very valuable data set, very useful to ecologists as well. But we also sample other measures. So on a quarterly basis, we go out and we measure a suite of water quality, including nutrients, concentrations, etc. We've also got a network of rod set elevation tables in specific areas to measure sediment accretion. And there the particular focus is to see whether our salt marshes can keep pace with sea level rise. This particular part of the coast is subjected to sea level rise, albeit small, but storm surges and such are having an effect. And then we just started kicking off blue carbon variables, collection of blue carbon variables, and implementing some of those technologies. One of our newest initiatives is a benthic ecosystem LTR program. So this utilizes non-invasive technologies, mainly video and photo image technologies. In the past, we used to, the only way to really quantify fish communities and counts was by scuba diving or tag and release. And it was quite intensive, and diving comes also with its own risk. We've got big sharks in the ocean over here, etc., etc. So BRUF work is a global phenomenon and fast-paced phenomenon that is growing, especially with the application of artificial intelligence techniques and machine learning techniques for the analysis, automated analysis. So it's quite versatile. You can take these equipments wherever you need to go, provided you've got a boat, and you can deploy it, and with minimal impact on the ecosystem. It's very fast growing, and we're building on a data set. It comes with its own challenges, of course. It's quite intensive, the amount of information you get off these systems. This is the most used data set of our collection, the National Coastal Temperature Network, very low-tech applications. Excuse me, you've got a temperature logger that you basically attach to a small railway line, a metal anchor, and you can hide these in gullies. And you can do this across your full extent of where you are interested to observe temperatures. So these are very shallow water temperatures, close to the coastline. So always less than 5 meter depth, and but always submerged. And in this particular case, it's a collaborative effort. As you can see, many organizations contribute to maintaining these systems. These loggers you can leave in the water for up to a year. The only impact here is people are curious creatures, so they would dive in and pull out these moorings and leave it ashore, so many go missing. But the data it produces is very useful. So in a South African context, we're quite interested in marine heat waves, especially when it follows an instance of upwelling that may result in fish kills. And in several occasions, we were able to be quite responsive in writing policy notes and advising government how to deal with this and how to communicate it with the community as to what is happening. So a very useful resource and easy to maintain. And then, of course, there's a whole range of supporting infrastructure. And here I need to emphasize also staff. So as much as we've invested in infrastructure, we've also invested in staff. And these are 3 platforms, coastal craft platforms. So we've got a fleet of vessels, various sizes and purposes. We've got the dive team with a hyperbaric chamber for safer diving resource. And then recently we procured an airplane. So this is a 2-seater fitted with a LiDAR system and high definition georeference imagery. And we're doing coastal surveys and surveys of estuarine functional zones. Very popular platform, but quite new to us. So the LiDAR science is very specialized, but it's steadily growing. We also resource many laboratories here at Nelson Mandela University, specifically for nutrient analysis, fluorometry. We've got a carbon lab just established. We've got resource phytoplankton, zooplankton laboratories, benthic invertebrate laboratories, microplastics, and such. But the point to be made here again is the importance of networking. So some of this equipment were kindly leveraged by partners. CFAS, for example, assisted us with resourcing our microplastics laboratory. It is also very useful for inter-laboratory collaborations and networking, and it gives birth to a lot of collaborative research. So this is a very exciting component for us, and that is steadily growing. Of course, we need to make use of this data. So we spend a lot of time and effort building state-of-the-art data systems, and it conforms to all sorts of standards. And we're the only entity in Africa with a core trust seal, meaning that our data is systems and the way we serve it is certified, and we will try and keep that certification. All of our data is available free of charge, and we work on a principle of keeping the time from the point of collection to serving it to the community as short as possible. Then going into the future, I just want to see if I skip the slide. So our immediate priority for the next few years is establishing new sentinel sites. We just established a 2-ocean sentinel site on West Coast, and this is the exciting bit of work. It's always nice to build things. So but we're still doing it remotely. So it's very intensive on staff, and you can't do this work alone. So it's always, again, you need to work with the local entities within that region, both for resources, but also to make sure that what you do is useful. I'll skip through the last few slides quite quickly. We will, as part of the SMACRI deployment, deploy multiple real-time data buoys throughout South Africa. The aim is 6, although we'll start in Algoa Bay and along the West Coast for the next few years. These, the usefulness of this particular technology is, of course, you can attach multiple instrumentation on it. And then we simultaneously building the data systems to receive the real-time data and make it available to those who need it, but also to feed into global data systems and initiatives. Part of this will be instrumentation specifically geared towards carbon variables. And the plan is, along with the repeat sampling stations through the PELTA project, to contribute carbon data towards the coastal carbon observation, to establish it as a coastal carbon observation network and link it with the integrated carbon observing system. We've been involved with blue carbon work for the last 10 years, and we've resourced our laboratories towards this. This is quite a new field. There's been several talks this morning on this topic, and we're widely collaborating on this and trying to resource our network of instruments just to make sure that we can get going with this. Most of these initiatives will kick off in 2024, this year. Then uptake and impact. These are just some of the metrics that, that has very little context given the platform here, but this is how we make sure that we do the right thing. So, we've been quite good at establishing the networks. Our main priority for the next few years will be to put this data where it needs to be, to make sure that it's useful to decision-making and policy formation and implementation. And there are a great many initiatives underway, especially working with local government to make sure that this is happening. And I just want to end off, in the spirit of witnessing the growth of ECSF. It reminded me very much about our own evolution through time. We started off as a very small team, and with a massive mandate of entire coastline with very few resources. This is an expanded team at the end of the first year of our establishment. Most of the people you see there are interns, volunteers, and students. There were only 4 or 5 staff. I joined the organization as an intern while I was doing my PhD because I thought it was the most exciting thing. And it's amazing how much you can do with very little resources. If you've got the right people around you, if you've got good objectives, and you've got a sense of adventure. And this has been our guiding light throughout. It doesn't matter how big we are. We always remember fondly the small little room that we converted into a laboratory that sustained many masters and PhD students, our single boat and vehicles, and taking impossible, adventures. And so I'm quite proud of this. And then the second thing, and the last slide that I want to end off with, at the center of all of this lies people. We built, without people, instruments will just be instruments and ideas will just be ideas. And it's we've also stayed true to this concept of growing our own timber. And I'm emphasizing one of my good friends and colleagues here, Dr. Mfundo Bizani, who joined us as a PhD student after doing a master's in the terrestrial field. On the left there, you see a very dejected young student, very seasick, never been at sea before, and but absolutely motivated to build a marine science career. And he came back day after day and he said, "Sean, please, can I go back to sea?" And I said, "Mfundo, but you get sick. Why would you like to go back at sea?" And he persisted. Mfundo is now early career scientist with Scion. He leads plankton, zooplankton ecology projects and the laboratory and field expeditions. He's a colleague and he will hopefully remain with us for a very long time and one of our success stories. But it is he's also a symbol of what we stand for. So with that, I want to end and thank you for the opportunity to share with you our activities. And I'm happy to take questions. Thanks.
Thank you, Dr. Sean, for your presentation on South African Environmental Observation Network. Now the platform is open for the discussion. If anyone is having any question, please unmute yourself and ask the question. Anyone is having any question?
How is it, Sean?
Very well, sir. How are you?
I'm doing good. I'm doing good. With I was reminding some of your last talks were reminding me 2014.
Yes.
So I would not ask you any specific question, but rather I would ask you something of your experience of how you keep yourself motivated for like now almost 15 years, like building nations from very scratch in terms of infrastructure and things. We are a young organization. ECSF is a very young organization in that terms. What would be the kind of, there are lots of students, there are workers, there are researchers, there are professors who have long distinguished careers, but yours is a bit different in terms of building infrastructure, going out day together. How you keep yourself motivated? If I just, an World Ocean Day, put it completely in a different perspective.
So the most important thing, and this is, you often hear people say this, but a clear vision and really believing in that vision and making sure everyone around the table believes in that vision. People often say it, but to have it as a guiding light when things get really tough, when resources are low, when funding is low, and when no one else is around to pick up the morale of the staff, because that's the most important thing. A lot of what we do is repeat work. So you have to pour in an immense amount of energy into keeping staff aware of what we're trying to achieve. And then also to show the achievement is very important. So we often pause and we stop and we take stock of what we've done. Where are we along this journey? And then we fueled by the critics. A lot of people will tell you what you do is a waste of time, and especially when we set up the initial Sentinel site, we received a lot of criticism. But we believed in our approach, and we knew years later people will come back and say, "Oh, the data is available and it's good and it's useful. Well done, guys," you know. And then you pat yourself and say, "Okay, it worked." And many things don't work, so resilience is key. You know, when mistakes are made and you lose moorings or data is corrupted, 6 months of data lost and the heads hang, you have to pick them up and say, "Guys, let's take it on the chin and move on." So grit, yeah, I would say resilience and just understanding and knowing the vision, reminding people of the vision, and taking stock every now and again. Growth is easy. It's easy to motivate people with what is to come. This is where we're going. So let's keep growing. It's always exciting starting something new. You've got blind, ignorant passion to grow things. It is when things become operational or mundane that you need to really, from a management point of view, put in the hard yards and listening to people and understanding those human emotions and what motivates people. Yeah.
Yeah. That's and do you think that's I remember while we were in South Africa together, and then Prof. Ulrich, he used to come up with piles of data collected laboriously from his book, and somebody kind of pruning out even some of this data, and so that was a phase of South Africa, and now this Seon being running like a machine. Do you think that the science, the estuarine and coastal science itself has benefited from it? If you think of the quality of the research work being published or practiced in South Africa right now?
Oh yes, and we actually put in quite a bit of effort to track those parameters and to make sure that it's useful. If we're not improving the quality and the quantity of research, quality and quantity, quality first, then we're failing. So we spend, from a management point of view, an inordinate amount of time convincing our funders that what we do is making an impact. And we've got specific metrics that we follow. We don't just hand over data. We try and understand how the data is implemented, the type of outputs that are produced, and how the outputs produced are affecting policy. So the full value chain is monitored. And I think that's essential, and it's only fair, especially if you had service to society. So we're very careful and very strategic in how we apply our personal science. We've got a science mandate as well. We employ 5 scientists to do their respective science, to execute their scientific endeavors. But they have to skip through with understanding the science that you do, how is it going to benefit society. It's central to what we do.
Thank you. Thank you, Sean. If someone else has a question, Prakash, Mr. Yes.
Sir,
Yes.
hello. Normally, the coastal research and assurance research is difficult to study through satellite images. Recent years, there are high resolution spectral images or hyperspectral images, and so many radiometric. So several images are coming. Which is the best for image? What is its resolution of the image? This is best for the coastal and assurance study, because a lot of predictions are going on. INCO is also practicing finding the potential fishing advisories, but they are failing the coastal waters.
Yeah.
There is no proper prediction.
Yes. So very exciting field is I did highlight some of the initiatives where we work with remote imagery products and initiatives, and the integration of observations with remote products. But we are contributing and working towards early warning systems, particularly for coastal ecosystems. So we just completed an initiative in collaboration with NASA, where we're using remote imagery to try and monitor biodiversity in all ecosystems, including coastal ecosystems. So there are many challenges, as I believe. This is not my field, but as I understand, resolution closer to shore becomes a problem and is almost impossible in estuaries. But the technology is moving very fast, and there's a lot of resources devoted to this. And I foresee and predict many advances in this field in the next 10 years, at least in our region of the world.
Thank you, sir.
Anyone else is having any question? Thank you, Dr. Sean, for your nice talk and presentation. So,
thank you, Sean.
Next talk will be moderated by Dr. Saurabh Pal, plankton and estuarine ecologist and the director of Estuarine and Coastal Studies Foundation. Over to you, Dr. Paul.
Thank you, Dr. Mondal. The next up with us is Professor Robert Costanger. Good afternoon, sir. You are
Good afternoon. Yeah, can you hear me?
I'm very sorry that we are running late. As scientists too.
Shocking. Yeah.
Well, Professor Costanger needs no introduction. In terms of its own, he's a kind of a global guru when it comes to ecological economics. But since it's a World Ocean Day, and he needs many of this audience is not familiar with the world of economics, ecological economics. So Professor Costanger is an ecological economist, and he is based at the Institute of Global Prosperity, University College of London, and he is an ambassador of the Wellbeing Economy Alliance. He is also co-founder and past president of International Society for Ecological Economics and the founding editor of the prestigious journal called Ecological Economics. In the perspective of World Ocean Day, we requested Professor Costanger to have some deliberation regarding ecosystem services, how that can be valued, especially in terms of estuaries and coasts, because this is something not being taken up in India. But in a country like India, this is much more, this sort of integration is much required because we do not have the science or the integration of science and the social science or the economic science together as per these coastal and marine sciences are concerned. Dr. Costanger has authored or co-authored over 600 scientific papers, 30 books, and his newest of it, Addicted to Growth. Yes, sir, we are all addicted to growth. Societal therapy for a sustainable well-being future. But are we looking for a future that is like with degraded ecosystem services? That's the question. His work has been cited more than one. We are Indians, so we are talking these terms 160,000 times in Google Scholar with an H index of 141. More than 360 interviews he has given and reports on various works. And he has written over 75 articles for the popular press. But this is, today we would really love to listen because, the India is heading to an economic boom. It's all right. It's like people deserve it. But does people deserve it, or does, as a humanity, we deserve it in expense of degrading our ecosystem service, the ecosystems for long term? We would love to have your views on it, and especially considering that most of our ecosystems, as per the estuaries and coasts are concerned, they are not economically valued. We do not practice that sort of science. So your talk, I don't know, are you talking first time to any Indian audience, or is or you have talked before to any Indian audience before?
I think I have talked before to Indian audiences. Yes, thank you.
Okay, yeah.
In fact, we had a major conference of the Society for Ecological Economics in Delhi. I think it was a decade ago or so. But yeah.
Yeah. Okay, so that's with that. The floor is yours. We would love to know about your views and perspectives of Indian context too.
Okay,
Thank you.
great. Thanks. Great to be with you, and it's a lot to cover. Let me see if I can share my screen here. All right. Well, and I'll cut it short, and maybe we can just have a discussion at the end because I think many of you have probably heard about some of the things I'm going to talk about. I was going to talk about the value of estuarine and coastal ecosystems and ecosystem services in particular, and the fact that I'm sure you're all familiar with the term, the benefits that people derive from functioning ecosystems, and that coastal and estuarine systems are some of the most valuable in those terms, in terms of contributing to the various constituents of human well-being. I was going to show a slide of the Millennium Ecosystem Assessment diagram of the division of ecosystem services into provisioning, regulating, cultural, and supporting services, and all of their connections to the various constituents of human well-being. So it's not just for provisioning, it's not just for food and water and other resources. It's really to regulate the climate, to regulate, to protect against storms, to have recreational and aesthetic benefits. So there's a whole range of contributions of these services, which have been undervalued in many ways, underappreciated. And it's not that these services derive exclusively from the natural system. They have to be combined with other assets, our built, our human, our social capital. And it's really the interaction of those components, the free gifts of nature with the things that we have constructed in order to take advantage of those gifts that lead to sustainable human well-being. There's I was going to show a plot. What the hell? Of just the various uses of ecosystem services valuation. So it's valuable not just for, but partly for raising awareness about these contributions. Without without being very precise about the valuation, but just making the point that these contributions are huge. But they also can be used in modifying national income and well-being accounts, and that's certainly something that's happening more and more. That for specific policy analyses, so if you want to ask the question, what are the costs and benefits of a particular policy? Well, if you leave out the benefits and the costs to the damages of ecosystem services, you're leaving out a major component of the impacts of what you're doing. For land use planning, for this idea of payment for ecosystem services, I think is also quite important. And that sort of system has been quite useful. That we can use economic incentives to change the behavior of people in terms of rewarding them for providing these ecosystem services that are usually not accounted for. If we and just accounting for the prices of everything that we buy in the market, that we're leaving out the value of many of the ecosystem services in the prices that we pay. So we need to bring those into the pricing system in a slightly better way if we want to use that information. And finally, this idea of common asset trust, that we need to start to think of how we manage these systems, not from a market point of view, but from a point of view of thinking of them as assets that benefit all of us. They're community assets rather than private assets. And how do we build institutions that can do that? There have been surveys of marine and coastal management professionals that asked the question, how important do they think this valuation of ecosystem services has been? I'm looking at a diagram now that shows that across this large range of different services, they consistently think that they're very important. This issue of valuation is very important. But they also asked them how much trust they have in these valuation exercises, and their trust was significantly lower, particularly in some of the ones that asked people through surveys, to estimate those values. So there's a range of trust in the different valuation techniques and estimates, and I think there's a lot more work to be done to understand better how these ecosystems and the functions and services that they provide, how they connect with human well-being. There's a whole range of different methods for doing this. So there's no one right way to do it, and a lot of it depends on what kind of service you're talking about trying to estimate. And many, if not most of these services are outside the market. And even the ones that are in the market, things like the value of fish, for example. Well, it's really the value of the ecosystem that produces the fish that you're trying to get at. And you can sort of work back from that, from the market value of the fish, and then sort of how much does the ecosystem contribute to that. But it becomes a much more complicated thing than just relying on market values. And one has to understand ultimately how these systems function in a dynamic sense over space and time if you really want to get at how those interactions work. So all of the techniques that have been used, I think, are estimates, with a capital E. They certainly don't get at everything, and they can generally, I think, they tend to be underestimates of the true value because of the uncertainty and our lack of knowledge of many of the relationships here. I won't read this list of different valuation techniques, but I'll talk about one particular example. And without slides, it's going to be hard to describe this, but one method that's often used is something called avoided costs. So the fact that we have these ecosystems in place means we avoid certain damages or costs that would have otherwise occurred. And in particular, I'll talk about the example of storm protection, the storm protection value of coastal ecosystems. But before I get to that, I also want to recognize that much of the valuation work that has been done has been from the point of view of economic efficiency, thinking about individuals' willingness to pay at some scale or another. And in fact, there are other goals that we need to value these services against, including fairness and sustainability. And those are quite different techniques that would be needed. For fairness, we need to really look at the community's preferences as a whole, not just lumping together individual preferences. And for sustainability, we need to look at the whole system and how it's functioning and how we model that system over time. So getting at much better abilities to predict or to project at least what will happen to these systems is going to be important. And also recognize that that economics is not just about the market. Economics is really about how we manage the system more broadly. And so to manage it efficiently, we have to consider all of the things that contribute to human well-being. And that valuation of these services is not the same as privatization or commodification or trading, because many of them are not traded in markets, shouldn't be traded in markets, and shouldn't be privatized either. But that doesn't mean that they don't have value in an economic sense, in the sense of contributing to human well-being. And that expressing these values in monetary units is not the same thing as market or exchange values, because they are not. That's not where their values are being estimated. But doing it in other ways is what gets complicated. And finally, we can't avoid this valuation exercise. It's not like you can, because every decision we make about ecosystems is an implicit valuation. So the real question is, do we want to leave it implicit or make it more explicit? And finally, we have to recognize that most of these services are non-rival and non-excludable kinds of things, and markets don't really function well when it comes to allocating and understanding the value of those kinds of services. They function reasonably, or can function okay, for excludable and rival goods and services, but not for these public goods and common pool resources, etc. So we need new kinds of institutions as well. How is this going, by the way? Are you guys, is this following along? Is this?
So this feels like quite an engaging podcast. We can't really see your screen, but then we are following what you say.
Okay. So I should keep going. Is it making sense without the PowerPoint? Yeah.
That's all right. The talk is making sense. That's right. Yeah, I know it's for a well, it would have been much easier for us to comprehend if we could see the slides, but it's making sense. So you just please carry on.
Okay. Yeah, I really don't understand why that didn't work. Okay. Anyway, where was I? The interest in this ecosystem services has been expanding quite dramatically. There's the IPBES, the Intergovernmental Panel on Biodiversity and Ecosystem Services, you probably heard about. It's kind of the IPCC equivalent for ecosystem services, and they do regular assessments and status and trends reports about what's happening there. The Ecosystem Services Partnership is another global organization that consists of researchers and practitioners around this area. The academic interest in ecosystem services has been increasing dramatically. I would show you a slide of the number of publications in Scopus on the topic of ecosystem services. It's up to 50,000 scientific articles that have been published over the lifetime, and up to over almost 7,000 per year new publications on this topic. So there's a lot of academic interest and research going on in this area. The most highly cited of those papers is one we published back in 1997, which tried to estimate the total value of these global ecosystem services and 17 different ecosystem services across 16 different biomes, including open ocean, including coastal and estuarine systems. So it wasn't just the terrestrial biosphere, and it wasn't just country by country, as a lot of previous estimates of national values. So GDP really only covers the national borders, but we go well beyond that and look at the value of the whole planet. Our estimates, came up with, and again, conservatively estimated, and certainly underestimated values that were significantly larger than GDP at the time. So I think the impact of that paper was it made it clear that even though we were basing this on a limited set of studies at the time, we were still coming up with numbers that were much larger than people had perhaps expected. And since then, I think that those estimates have only gone up further. So recognizing how much these ecosystem services contribute is really the something that has driven or project a lot of the interest and research and policy in this area. And I think it has also helped to recognize the value of these systems and the fact that they need to be protected, restored, and valued. I was going to do an example of how this kind of valuation is done in terms of the value of coastal wetlands for storm protection. And I was going to show you a nice set of slides of the coastal, the Mississippi Deltaic Plain in Louisiana, which in 1839, was very continuous. And in 1970, it had started to break up. And by 1993, it was really losing a lot of those wetlands. And by 2020, that loss has continued, partly due to the levying of the Mississippi River, so that the sediments that were flowing out into the Deltaic Plain and maintaining those coastal marshes were now being lost over the edge of the continental shelf. A lot of oil and gas exploration that were digging access canals through the wetlands, etc. And the loss of those wetlands has had a tremendous influence on the ability of that coast to suppress storms. And there's a nice picture I was going to show you of the storm surge caused by Hurricane Katrina, which was huge and led to significant flooding of New Orleans and significant damages there. And this has certainly occurred again and again all over the world. And so what our study did was to look at the relationship between the path of the storm, the amount of damages that were done by the storm, the sort of swath, the intensity of the storm, and how much wetlands were in the swath of the storm, and how much infrastructure there was in the swath of the storm to be damaged. And you put all those things together into a statistical analysis, into a regression model that looks at the damages as a function of the wind speed and the wetland area, essentially. And you find that the larger the wetland area, the lower the ultimate damages for the storms are. And there's a significant relationship there that you can then use to estimate the avoided costs, the change in damages that you would expect from a unit change in wetland area. And we can map that along the coast of the U.S. And we did an initial paper just looking at U.S. coastal storms. And more recently, and from that, we estimated, the values to be on the order of, $5,000 per hectare per year in terms of avoided damages. More recently, we did a global assessment and came up with the global value of coastal wetlands for storm protection based on, new data availability. We had storm tracks that went back to 1900, and every year we have the and I would show you a nice map of the storm tracks in a particular year, but 2003. But every year we have a map like that of the storm tracks by category around the world. We can combine that data with maps of coastal wetlands and where they are, and maps of coastal infrastructure based on nighttime satellite imagery, so we know where the infrastructure is at a fairly high resolution, and put all of that data together into a nice statistical analysis, and then I would show you a nice map of the annual avoided damages, at a 1 kilometer. No, I'm sorry, a 100 kilometer by 100 kilometer cell size globally. And we estimated that in 2015, those avoided damages, the value of coastal wetlands for storm protection, were about $450 billion per year. And we can only expect those estimates to go up as hurricane frequency and intensity go up with climate change. But we can also use that kind of information to say, what is it worth to protect these coastal wetlands? And the alternatives are often thought to be, well, we'll just build levees, we'll somehow, solidify the shoreline that will protect us against these hurricanes, which it may to some extent, but not really as well as these coastal wetlands can do the job. And at the same time, they're providing this whole range of other ecosystem services that I mentioned in terms of, fish production and recreation and nutrient removal, etc. So the obvious implications are that these kinds of coastal systems are so valuable in so many ways that they need to be protected and restored. And not ignored, and those values not ignored as they have been more in the past. We were also able, with this analysis, because we had data not only on the economic damages from each storm, but also on the number of lives lost from each storm in our analysis. So we could estimate the number of lives that were saved by these coastal wetlands that would have that would have been saved, I guess. So it ended up being about 4,500 lives that were saved by coastal wetlands being there as opposed to not being there. Okay. And we know that these changes or losses of wetlands lead to significant losses of human well-being in the various categories that I've talked about. And we've been able to look to then sort of estimate, okay, well, what's the benefit cost ratio of protecting these natural systems? And I'd show you an estimate from a paper that we did back in 2002 on the total, based on a scenario, a global scenario that said, well, let's expand the global reserve network to cover 15% of the terrestrial biosphere and 30% of the marine biosphere. And that was estimated to cost about $45 billion a year. It's interesting that was in 2002, and you probably heard the latest proposals for biodiversity protection, of 30 by 30. So 30% of both marine and terrestrial areas being protected. So it's not that inconsistent with what's currently being proposed. But we estimated the net benefits of that proposal in terms of the difference between what the protected land use scenario would look like compared to what it would probably turn into if it were not protected, and that difference was those benefits, the difference in those two was about $4 to $5 trillion a year. So the benefit cost ratio of 100 to 1 or so in terms of the value of protecting natural ecosystems. Let's see. Yeah, and I was going to show you a map of the current protected areas around the globe, which now are around 15% of the terrestrial regions and 3.4% of the oceans, and that's rapidly expanding, I think, toward those 30 by 30 goals. And then there's other estimates that I was going to show you some figures for of the benefits and costs. benefits, including all of these ecosystem services versus the costs, and how those benefit cost ratios are significant. I was then going to talk about what the more recent analyses of the benefits of these different ecosystems, and show a paper that we did showing the global estimates of ecosystem services and their values, boom, boom, boom. And ultimately get to our estimate of how the values had changed from that 1997 paper until 2011. And based on changes in land use over that time period, losses of coral reefs, desertification, deforestation, etc., over that time period, and also the updated estimates of the value of each of those ecosystems from that, all of that additional research that had gone on over that period. And in the end, we estimated that over that period, we've lost about $20 trillion worth of ecosystem services due to those changes. And finally, we were talking about future projections. What's going to happen in the future? And there's a range of land use of scenarios that we could talk about, including the traditional market forces, business as usual scenario, a policy reform scenario, what's called the Great Transition scenario, if we really take all of this seriously and start to recover and rebuild and restore ecosystems, and a fortress world scenario. And then I was going to show you land use maps for each of those scenarios and what they imply in terms of the value of these ecosystem services going forward. And the map I'm looking at of market forces shows, continued decline in those values. Policy reform is kind of a stabilization. The Great Transition is a recovery and rebuilding scenario of all of those, the value of those services. I was then going to go into some more regional examples. We did a study, for example, in Australia on the Great Barrier Reef, on the catchment and reef ecosystem services, making the point that you really need to look at the whole system, not just the marine part of it, but also the upland part and how those two interact with each other. Because a lot of the impacts on the coral reefs are from a combination of global warming, increasing temperatures, increasing acidification. I think if you heard of in previous talks. But also runoff from the land. And so what's the relative impacts of those different sources? We did a study there looking at 4 different scenarios for that coastal region, and with different combinations of dealing with the global and the regional impacts. And you get 4 different scenarios. We were able to look at also the implications of that for various ecosystem services, and sort of map what the changes would imply for the whole range of ecosystem services and their values, and show, I think, quite clearly that in the best of both worlds, if we could deal with the global system and those changes and the regional runoff, that we could maintain a fairly good fraction of coral reefs. It doesn't seem that we're doing either of those, right? Especially the global warming part, as we've seen with recent bleaching events in the Great Barrier Reef and other reefs around the world. And finally, I was going to show a slide of some of the potential interventions that we could try to do on coral reefs to deal with these various climate stressors, including warming, acidification, and storms, and how we could affect how that ecosystem is functioning at various levels, including new genetic combinations to breed versions of the coral organisms that could deal with the heat stress, etc., all the way up to protecting the ecosystem as a whole. And finally, I was going to talk about management institutions and new kinds of management institutions that would be needed to actually deal with managing these complex systems, and this idea of common asset trusts as a way to effectively manage these systems, to think of them as assets that need to be protected as a whole, rather than systems that we extract resources from as much as we can. And this is based on the work of Eleanor Ostrom and her work with managing the commons, and she came up with a set of design principles for what it would take to build institutions that can manage commons effectively and sustainably. And I won't go through that list, but they can't be left as open access resources. They have to have clearly defined boundaries. But those boundaries and those property rights can be on behalf of the whole community, not just on behalf of specific individuals or corporations. So that's a key thing. And also that there needs to be some co-production of the rules and norms and enforcement mechanisms for dealing with that. And so it's possible, I think, to develop these kinds of common asset institutions that we could use at multiple scales, all the way up to the atmosphere as a common asset, or the oceans and coastal regions as a common asset. And I was going to show a paper that we just published in Marine Policy titled Common Asset Trust for Blue Commons Stewardship. Marcelo Hernandez and myself and several others were the authors for that. But trying to develop these new kinds of management institutions that might better deal with the reality that we're facing, that we have some these global and regional commons that are being impacted negatively because they're not given appropriate property rights, they're not valued appropriately, we're not recognizing how important they are to our sustainable well-being. All right, I'm going to stop there and maybe take some questions. And sorry,
That's all right. No, that's kind of very insight. I mean, like this is very interesting. So it's indeed, because as I mentioned, that's in case of India, that's we are an aspiring economy, a growing economy with a lot of young people, but yeah. We are possibly keeping aside the ecological balance from the economic the growth. So the floor is open. If someone wants to have a question or a discussion, please go ahead. Mr. Mehta? Mr. Yes?
Thank you, sir. Sir, ecological valuations, can we add in the GDP of the country GDP? The values are ecosystem values.
Can we add it to the GDP? Well, I think it overlaps with GDP to a certain extent, because some of the things that we're measuring do enter into the market economy and are picked up in GDP, but many of them are not, and they contribute directly to well-being without becoming part of GDP. So there's a bit of overlap. I know that in China, they're doing something called the gross ecosystem product, which is similar to what I was talking about, and trying to at least, display that in combination with GDP. I'm working now on a project funded by the European Union to come up with, new alternatives to GDP, new metrics that are more inclusive, more comprehensive, that include ecosystem services, social, services, community, all of the things that contribute to well-being. So I think there's a lot of interest in that now. There's one measure that I've worked on in the past called the Genuine Progress Indicator, which I think has been estimated for India as well. But it at least tries to modify, because GDP was never designed as a measure of societal well-being. And there's a lot of things left out, and there's a lot of things that are included that shouldn't be counted as positive. So if there's an oil spill, somebody has to go clean it up. That's going to add to GDP, but that's not a good thing. If there's more crime, if there's more, divorce, that's all added to GDP, because it's just measuring activity. But what the GPI does is, and also there's nothing about how that GDP is distributed. So, if one person gets all of the GDP or it's equally distributed, there's, GDP doesn't tell the difference. And you would want it to be more equitably distributed to improve well-being as opposed to just activity. So GPI accounts for the distribution, the inequality. It adjusts for that. It adds a few things that are left out, like the value of volunteer work and household labor. Things that are positive but are not counted because they're not marketed. And it subtracts a bunch of things like environmental damage, air and water pollution, climate change, all of those things. When you do that, and we did a global synthesis that showed that GDP per capita was going up, over this whole time period. But after about 1980 or so, GPI, the genuine progress, had leveled off and started declining because of increasing inequality and because of increasing environmental damage, essentially. So just because GDP is going up doesn't mean things are actually getting better. It means that there's more activity. You're spinning the wheels faster, but it doesn't mean that necessarily that things are getting better. It could be, but you have to do it. You have to do it properly. You have to do it in a way that is equitable, that doesn't damage the environment, and etc. Right?
Sir, another one thing is in Indian context, the indirect values like aesthetic value, cultural value, these are the formula which you mentioned in your paper. We put that formula for cultural value. It's very difficult. It's a high. It's a Indian rupees and American dollars. It's coming to American dollar. It's a very high rate. Cultural value and aesthetic value particularly. We can't measure it properly.
Well, the normal approach to doing that is to ask people in surveys, in one way or another, how much they'd be willing to pay for those values, and you could do that in several different ways. It could be different scenarios, that have different trade-offs. It could be more direct surveys. I think one of the limitations there is that they ask individual people their individual value. How does it affect their individual well-being? And it could be done differently, and then ask the whole community how they think their community values are impacted. Like I said, I think that there's the fairness approach or the community preference approach that needs to be expanded on. And there's some work going on in that regard. Can we do this valuation from the perspective of a deliberative community rather than just aggregating individual values? And finally, there's the sustainability part. And to do that, I think you have to look into the future. And to be able to do that, you have to be able to model what's going to happen in the future. So we need more of the sort of dynamic modeling approach and scenario analysis in order to get at that. So, but there's always going to be limitations and uncertainty in these valuations. It's not; these are estimates. They are not precise measurements one way or the other. And I think the interesting conclusion is that they always come up with values that are much higher than people expect, shall we say. That the value of an intact forest just for recreation purposes is probably much higher than the value of that forest for timber, for example. So if you leave out those values, you're just leaving out a lot. Exactly how much, it's hard to say, but chances are it's going to be an underestimate of how much you're leaving out. And that brings us back to the precautionary principle. So if there is uncertainty, who bears the burden for that uncertainty? Should we try to cover up those uncertainties, or should we make those values sort of incumbent on the parties that stand to gain? And one policy suggestion we've made is that we should require assurance bonds for these uncertain impacts. So if somebody wants to put in a mine and they don't know, they don't think there's going to be a lot of damages, but it's uncertain, well, they should be required to post a bond large enough to undo those damages after the mine has left. And if they're not willing to do that, then we shouldn't allow the operation to go forward. And I think that relates to a lot of different private activities that have social costs that are unknown or uncertain. We should estimate the worst case scenario, require a bond, which could be returned if those damages don't occur. So if they're right and things go the way they say, that's fine. But they should bear the risk up front rather than pushing that off to the public.
Anybody else? Anybody else have a question, please? Anyone else have a question, please? I have a question. Well, so let's take I have two questions. One is just a suggestion, and one is a question. So for an emerging economy like India, which is really aspiring to, in the last couple of decades or so, what would be the difficulties, do you think, to internalize the externalities of that we generally don't even pay attention to? Like what do you how do you think India's economy would be hit if we internalize these externalities?
Well, I think part of the problem is that when you pose that question, they would try to interpret it as how would GDP be affected?
Well, not only the GDP, but the aspirations, the growth, yeah, absolutely.
But that's the problem. If you focus on GDP, then I think you're taking the wrong approach, because what you should be focusing on, well, how would well-being of the population and the sustainability of that well-being, how would that be affected? And that may mean that GDP might not go up, but well-being could increase. And part of it would be, how are you going to distribute that GDP among the population? So it becomes a question that has to be answered from the point of view of a different societal goal than just the economy as GDP. And that's part of the trap. It's part of the addiction. Is that it's always thought of as GDP growth at all costs. That's what that's the underlying goal of these economic assessments. When in fact it shouldn't be. GDP is a means to an end, but it's not the end in itself. And as I said, it has a lot of. It was never designed for the purpose that it's being used for. So. One way to do that is, to survey the population and see how well they think they're doing. So there's been some work on, surveying people's life satisfaction. And there's the World Happiness Report that comes out every year that does that. And they've tried to analyze the differences in life satisfaction across countries and say, well, how much of those differences can be explained by, GDP per capita? And it ends up being roughly 10% of the variation in life satisfaction is attributable to the GDP. So it's not, it's not that it's not important, but it's not so important as it often comes across in a lot of the policy decisions. And is that what you were getting at?
Yeah, that's all right. And the other question that I was thinking of, that's in terms of coastal ecosystems, for its natural resilience. I think there's always a thrust on the mangrove, the plantation of mangroves as natural barriers. But how much mangroves are fast regenerating species? Still, we have to a lot of the money we channelize to plant mangroves in the the habitats, in the shoreline habitats or in the coastal habitats. Do you think it's the right policy, or we should leave it open, and what the economics says about it?
or the ecological economics says about it. Because this
Right.
is the big trust that India and most of the NGOs and a lot of foreign funding and all these sort of things are actually channelizing their money in terms of plantation and all this to the estuaries and coasts of India. So in that sense, that do you think this is the right policy or we should leave it open?
Yeah.
What about the cost benefits of it?
Right, right. And I think that's where the studies that we've been doing on the value of mangroves and salt marshes for storm protection, for example, are relevant. And they certainly do have a high value for that purpose. And combined with the other ecosystem services that they're able to provide, I think our conclusions were, yeah, it makes a lot of sense to invest in restoring, planting mangroves. That the cost benefit ratio is really pretty good for mangroves. So, yeah, like I would go along with most of those. Of course, it could be on a case by case basis as well. You know, there could be some situations where, depending on the local, the local conditions, that may not be the most effective thing to do. But I think in general, planting, restoring, managing coastal mangroves, coastal salt marshes, those sorts of systems have much more benefits than the cost of doing that.
I see Mr. Ashish has a question.
Yes, my question is also related to mangroves essentially and carbon credits. Like, I have no idea, but is it cheaper to sort of use or give out carbon credits to the developing world than to do your own cleanup yourselves in the Western world?
Well, I think a lot more needs to be done in terms of reducing carbon emissions and not just trying to buy trade-offs. So, and I think a big problem there is the activities of the fossil fuel sector in sort of, preventing the transition that needs to happen in various ways. And so I think we could do a lot more, perhaps, in focusing on how do we address that problem, the misinformation, the political influence, and the subsidies that are going to the fossil fuel sector that are preventing that transition from happening as quickly as it should be happening. And back to the common asset trust idea, one of the ideas that we've proposed is we should think of the atmosphere as a common asset that is owned by all of us. Once you've established that there are property rights, that we claim these property rights, then you can start charging for damages to the property. And where are the damages coming from? Well, it turns out there's 90 entities in the world that are responsible for 2/3 of the carbon emissions, all of the major fossil fuel producers, etc. So we could begin to charge them for the historical damages and potentially future damages, and essentially reduce the profitability of continuing to mine fossil fuels and make that transition much more quickly. So, and that's probably maybe a more effective approach than allowing them to buy offsets, for planting mangroves. Although at the same time, we should be planting mangroves and other forests and trying to sequester carbon from the atmosphere as quickly as we can as well, because reducing emissions by itself is not going to be necessarily enough. I mean, they both have to go hand in hand, of reducing emissions and sequestering carbon to the extent that we can.
Okay.
Yeah.
Professor Raut or Professor Kumar, if you have questions, Dr. Akhan, anyone else?
Sir, my one question is that, sir,
Yeah.
every year by year, the value, ecosystem value is changing. For example, mangrove stock. That 1 year it is stock is growing in next year. What is the range? Means we are doing in India every year valuation or 5 years valuation, which is on constant year which is the time range is the best for the evaluating the ecosystems?
Well, I think we should be doing those assessments and valuations much more frequently, certainly than we have been. And I think that's something that's starting to happen with the system of environmental and economic accounts. You know, they're starting to build the infrastructure to assess at least the changes in forests and other ecosystem areas and health. So yeah, ultimately, I think we need to put at least as much effort into assessing the value of our natural capital as we do into assessing, you know, the value of our GDP and our economic activity. Is that what you're getting at?
Yep.
Yeah.
So,
thank you, sir.
Anyone else? Anyone else? Okay. If not, sir, I have two questions from a completely student point of view, because some of us. Are you open to take PhD students?
Yes. Yeah. Yes.
Are they necessarily need to be economics or?
No, definitely not necessarily.
Yeah, because I grew up in India. I can tell because I see there are students here. I grew up in India, which had a lot of passion for ecological economics, but I was a bioscience student, so never been encouraged to take up that sort of career research path. Well, when I moved to New Zealand, they encouraged me to take up this sort of studies. So finally, I'm able to do little bits over here. But then that's a personal story. But is it somebody like a completely biological background can also practice this sort of ecological economic science?
Sure. Yeah. No. Ecological economics is a very transdisciplinary approach. So it's not just economics. It's not just ecology. It's I don't know. You could call it systems. You know, it's a systems approach to ecology and economics and psychology, and trying to understand how to understand and manage the whole planet as an integrated whole.
Mm-hmm.
So yeah.
And would you be?
So you want to get a PhD? You want to get a PhD? Is that what you're saying?
And I think I have done one. No, thank you for the offer. I would say like this is a perspective from the foundation. The foundation definitely wants to start some work on ecological economics. We are not well equipped for that, and I have no obligation saying that we are not well equipped for that, because we hardly have people which work in this here. It's mostly traditional. The ecological economics community of India, I know some of them definitely. Nilanjan, I know from ORF, and some people, and the meeting that you were actually mentioning, I know people from there also. But traditionally, it's either economics or ecology, or some developmental economics, and within that fraction of developmental economics, some people get interested in ecological economics. So anyway, the foundation is definitely interested to pursue and evaluate the ecosystem services of Indian Sundarbans, the largest mangrove patch on the world. Okay. Because one of the things that we lose, the biologists lose argument sometimes when we sit with the policymakers. That's my observation, is that the policymakers wants to pursue more in terms of economic terms, which is not often holistic, not often, it's more of a hardcore GDP or a hardcore, yeah. So it's even if we approximate, as you said, that this is not a real world value, it's more of an approximation into the value of an ecosystem services. We would definitely love to have that for Indian Sundarbans. And I don't know whether in future would it be possible for you to guide us a little bit through, and we can do the work.
Yeah, sure. Definitely.
Thank you.
Yeah, we should talk. Okay.
Thank you.
And I can put you in contact, I think, with some other colleagues I know in India who have been doing similar kinds of things. So,
Yeah. Thank you so much, sir. Thank you so much for being with us. With all the technical issues, but it was a pleasure to meet and to exchange ideas. And thank you on behalf of the foundation. Thank you. Thank you very
you're
much.
welcome. And I'm sorry the PowerPoint didn't work.
No, that's a part
I
of
don't
life.
understand. Yeah, I don't understand what wrong there. It seemed like it should be. Yeah. Oh well. Okay. Thank you. Bye.
Thank you.
Bye now.
Yeah. The next up in the talk is Professor Biju Kumar. Sir, Professor Kumar, you are with us? Yes? Yes, sir. I'm very sorry on behalf of the foundation because we keep you on the loop for a long period of time as we had some technical issues as well as people were enthusiastic. They were always engaging in the talk. Introducing the audience, Professor Biju Kumar. First of all, I must say that on behalf of the not only the foundation, he is kind of an idol to many young people like us, looking up to practicing science, marine science, in terms of coastal and estuarine biodiversity. When we talk about these sort of science, we basically talk about the currency. Here, the currency is species. Nowadays, it is getting devalued because we sometimes see it as an old-fashioned science. But this is the basics, the building blocks of any sort of biological science or too many system science. Professor Kumar is the Dean and Dean Faculty of Science, University of the Kerala, and he is also heads the Department of Aquatic Biology and Fisheries, University of Kerala. He has served in the Science and Technology Department of the state and the Biodiversity Board. He is a trained aquatic biologist. He received his PhD from the University of Kerala. For his contribution, it's a kind of a lifetime achievement award. He received the Padma Shri Professor N.B. Nair Environmental Excellence Award of Society for Advancement of Biological Science, Bangalore. His area of expertise, as I first mentioned, taxonomy, aquatic biodiversity, ecology, invasion biology. We talk about those things, but we are forgetting the basic blocks. That's science, and that's the taxonomy. He described one new family of parasitic copepods, 8 new genera, and over 55 species of aquatic organisms. That's a staggering number for one country itself. There are many countries in the world which have very less biodiversity. And sir, you have done us like a long serving to the nation. He deployed different techniques like morphotaxonomy, DNA barcoding, which he learned from various universities across the world. And currently, he is leading the Erasmus Ecomarine program of the European Union as an Indian counterpart from the University of Kerala. He has published 225 research papers, 26 books, and he guided about 20 students, the PhD students under him. And he is always with us, with all the young people. I still remember traveling in Trivandrum, giving sir a phone call, or can I present some of my initial talks or initial thoughts as a young people about estuaries? And he was in flash, okay, here goes your flyer. That's how he supports young people, motivates us. Over to you, sir. Thank you very much for being with us, and I'm very sorry that we kept you a bit on delay. It's part of the program. Thank you, sir.
Thank you, sir, for the nice introduction. And then, shall I get the same time, or shall I have to reduce my talk? What do you feel?
Yeah, just take your time, sir. That's fine. Like whatever time is required to express yourself.
Yeah,
that's fine.
Yeah. So I'll talk for 40 minutes or 35 minutes.
Yeah, 35 minutes is fine.
Yeah, and then we can have a discussion on that. Okay.
Yes. Sure.
Let me present my slide. I think the sharing option is not enabled.
One person, 1 minute, sir. I just okay. I just talked to the IT person.
sharing.
Yep, sir. The IT guy, as per the IT person, it's from our side. It's all right. We just had a quick check. What's the message that you are getting?
That the share option is disabled.
Okay. Just hold on.
I'm trying all the options, presenting the entire screen, and then.
Okay. Okay, Doctor. When he's trying to share, okay, what's up? One.
Yeah, I'm trying to share the entire screen, but only the cancel button is enabled and share button is not enabled. So that's.
It's share screens. Yeah, we have the right tick.
Yeah. I have the option of sharing the screen, but when I share the entire screen, the share button is enabled. Probably you have to within the Google Meet, you have to do that.
Sir, once you click on the present now button, the screen that appears on your screen, you will have to select which tab you want to present, whether it is the window or the entire screen. Once you select the window, you have to click on the small eye which appears beneath it. Then the share button will be enabled. Then the share button will be enabled and you can click on the share button.
1 minute of it. Yeah, can you see it now?
Yes, have you shared it? No, I think ECSF is presenting.
Can you see my slides now? Or?
Yes, sir. Yes, sir. Yes, sir.
Okay. Yeah. Okay. I'm going to talk on marine biodiversity documentation and conservation in the era of climate change, the role of youth. In this talk, primarily I wanted to address some of the issues regarding biodiversity documentation, as well as how the young the researchers can actually play a lead role, specifically in India, in both documentation as well as conservation of biodiversity. And specifically, I wanted to address how the marine biodiversity is different from the other biodiversity in other biomes, and how much diversity exists in the ocean, and the status of marine biodiversity research in India, and how we can actually prioritize biodiversity documentation, particularly using the modern technology. And also, finally, how do we actually enhance international linkages and collaboration for enhancing the quality of the work, as well as promoting good research, especially in the era of the ocean sciences for sustainable development. Okay. And there are two paradigms when I speak about marine biodiversity. And one, a global paradigm where many of the scientists argue that most part of the ocean is still unexplored. And this is true with regard to India as well. When you look at the published data so far, and we can see that majority of the marine biodiversity assessments have actually come from the coral reef areas. You must understand that definitely coral reef areas are richer in biodiversity. But if you look at major estuarine ecosystems, coastal ecosystems, the marine biodiversity is relatively well documented. But what about large number of smaller estuaries across the Indian continent, and where there are specific quality work, not only about the marine biodiversity, but ecosystem services, economic evaluation, these are not available. So that means there's a lot of areas, gap areas, which probably we have to identify and prioritize, particularly in the era of research where the funding for the fundamental research or basic research is coming down. And this is a global scenario, but in India, you will understand that majority of the money is allotted for the so-called cutting-edge science, so that the basic sciences like taxonomy or ecosystem services, these are not well funded. That is another thing. At the same time, there is a lot of thrust coming up for blue economy and blue growth. There also, the priorities basically for extractive kind of economy, where the priorities always for mining, not taken to sustainability, not fully addressing the question of sustainability. And these are some of the initial arguments. And then what are the kinds of diversity systems or profiles which probably we need to address, and beyond species level. But many of the documentation primarily lies at the species level documentation. But in specifically with regard to the coastal as well as marine ecosystem, and we need to have a stronger orientation towards alpha, beta to gamma level, especially in documenting biodiversity and its ecosystem services. And one is ecosystem diversity, community and species diversity, and where our primary focus in India research is on community and species diversity. And then what is a kind of interactive, intraspecific diversity which is available, and that will ultimately help in planning larger conservation programs. And especially after the molecular, the beginning of the molecular taxonomy era, what we understand about marine ecosystem is something very, very different. For example, now we understand after molecular taxonomy that many species have a wider distribution. What we initially thought of present only in a specific part of Indian Ocean, we now believe that it is actually extensively distributed. And that means India can play a very, very important role in future in conservation, because many of the species which once said to be present only in specific areas of Pacific Ocean or somewhere else is now believed to be present in Indian Ocean as well. So even in some of the threatened species globally, which are now believed to be distributed in Indian Ocean as well. That means we need to refocus our attention in a larger perspective towards integrative taxonomy, in understanding the gene flow mechanisms as well as the molecular phylogeny of this organism, so that we can also plan about something with regard to conservation genomics. And that is the reason why we need to document that. And also looking at the functional diversity of this organism will actually provide you with a lot of input for ecosystem services. In the last lecture, we got a lot of information about the ecosystem services from Professor Costanzo. But here, questions are where the ecosystem value, service value is something very, very important for conservation. And so that means probably in the new era, especially the youngsters take up the research, we need to have a more focus on integrity taxonomy, particularly looking at the functional diversity and the genetic diversity. Okay. And the reasons why we need to focus our attention on marine biodiversity is very simple, primarily because we have around 33 animal phyla. And if you look at compare the freshwater, terrestrial, and marine systems, we understand that if you look in terms of conservation through endemism window, then you understand that in freshwater ecosystems, no phylum, animal phylum is endemic. At the same time, in terrestrial ecosystem, there is only one phylum, probably it's Ochiophora, which are velvet forms, which have marine fossils as well. And if you look at the marine ecosystem, 28 phyla occur in marine ecosystem. Out of that, 13 are endemic to the oceans, which clearly tells us that in terms of diversity of phyla, marine ecosystems are much more important than other ecosystems. Okay, and also about the species richness. You understand, especially after in the era of bioinformatics and technological revolution, that many of the species which earlier believed to be distinct species are now synonymized, primarily because of the modern technology. And species richness is evaluated in terms of area of distribution, environmental stability for a longer period of time, immigration and emigration, then speciation, habitat, and biodiversity, and we don't know whether temperature has a role specifically in speciation, particularly the Indian waters. And also population, the status of the population is addressed by looking at abundance. It's the nature of the distribution, especially whether it is widespread or not, the productivity, pathogens, environmental stress. So if you look at all these aspects, we should understand that the tropical areas, specifically the Indian waters, have a long-term environmental stability, which essentially means, and also highly productive, particularly the surface waters, and which essentially means the possibility of more species diversity in this water is much more compared to the cooler waters and the deeper waters. And that means, we need to have a stronger focus on the intertidal ecosystems and coastal ecosystems as well, compared to the coral reef ecosystems. That means we have a more chance of getting a new species and a very different kind of ecosystem services when we have a look at the coastal ecosystems in general. Okay. And the reasons why we support the stability time hypothesis is primarily because if you look at the tropical areas, we have a long-term stability, which ultimately and ultimately promote more diversity. And similar is the case with the deep sea environments. But remember, deep sea environment, the productivity is less, and that means the chance of meeting more species is there in the surface waters than in the deeper waters. And this and also, if you look at the number of species which are synonymized because of the duplication of names, and this is also coming down primarily because, thanks to informatics, we have the informatics platform which actually can compile metadata, and metadata will give you a right picture about what exactly is the amount of biodiversity available in the marine ecosystems. That means, if you look at the discoveries across the centuries, then you will understand that in the earlier past, many of the discoveries were duplications, and now we have more percentage of wild species, primarily because we have integrative taxonomy, molecular taxonomy, which gives us actually basically right clues regarding the new species descriptions. Okay, and also we have the informatics platforms and stronger databases which provide us with more and more information, and that means the chance of error is getting reduced over the period of time. And also, this is actually a map, basically a model developed based on the primary data, so far the species discovered. And you can also see that, the areas around Indian waters, especially Indian Ocean and the tropics, they are believed to harbor more number of species. And most of the species discovered from the marine ecosystems across the world, they live in the tropical areas. Okay. And that means when we look at for new species, look at some of the interesting aspects, especially look at the species interactions, the ecosystem functions, functional the values of these ecosystems, and more and more biological. Look at more and more biological units, and then the chance of the getting a better picture of diversity will be there. And also, if you look at the hotspots of both endemism and species richness, and you can see that the waters, as you can see here, the waters around the India, particularly along the Lakshadweep in the Western Indian Ocean. This is one of the highly species rich as well as highly and rich in endemism. And that means, these waters are very important in terms of conservation as well. And if you look at the biodiversity hotspots as explained in the WWF Global 2000 report, and you can see that the Western Indian Ocean is one of the biodiversity hotspots. And this is another interesting area to work on. Okay. And then coming to the end of the first part of my lecture, what is the possibility of marine species being discovered in huge numbers in future? And remember, as of now, 15% of the species on Earth are marine. And the highest number of marine species occur in the coastal and tropical areas. And macrobiota, more species are rich than the micro and megabiota. And discoveries of parasites, microscopic and deep sea species, unlikely to alter the current patterns. 1/3 of the species remain to be discovered. That which essentially means we need to focus on the tropical waters primarily, and also on the smaller organisms rather than the larger organisms, because many of the larger organisms have already been discovered. Okay. And then status of knowledge of marine biodiversity in India. Approximately globally around 242,000 organisms are being discovered. And out of that, if you look specifically at the Indian Ocean, and particularly around India, the species record is around 20,000 species. Okay. And that means compared to the global documentation of marine species, marine and coastal species, we have many things to do. Okay. And what we can do, rather than reinventing the wheels, doing the same thing again and again, and doing the same kind of research by multiple departments or universities or research institutions, we need to channel our resources in such a way that we have more and more collaborative projects, more and more exploratory projects, specifically which are interdisciplinary or transdisciplinary, involving and linking multiple group of the organizations. And that is actually one of the way to move ahead, particularly in the era where the research funding for the basic sciences is coming down. That means, rather than multiple departments involving the same work, we need to collaborate. We need to have a larger thinking about a larger exploratory projects, which is multidisciplinary and transdisciplinary, involving multiple number of organizations, and with a specific focus on the targets which are prioritized. Okay. And then second thing is that, we need to consolidate the database and strongly focus on metadata, so that we will have finally a very good curated data with us. And for that, we have already Ocean Biodiversity Information System, and also OBIS, which is where the CMLR is taking the initiative. But the problem is that every institution should provide the data and put the data into that curated data, so that we can have a larger metadata to play with, and also to curate the data, and also to come out with a status paper on the marine biodiversity of India. Okay. And finally, to create a digital database and of all the museum specimens or the voices specimens in India, so that we can have a stronger data with us, primarily to plan for conservation and management. Okay. And another thing is, the large an issue of taxonomic impediment. Taxonomic impediment, I told you about 33 marine total phyla, and out of that, 28 are actually marine. And out of that, if you specifically look at the taxonomic expertise of various people across India, including the organizations, we can see that at least for 10 phyla, there are no experts. How do we circumvent this issue? This is possible only through international collaborations. And you know that the Nagoya Protocol did not allow the transfer of specimens. And for that, again, what we can do, we can go for collaboration. We can go for collaboration, so that many of the species can the youngsters can be trained here, and they can also be funded here. So that the youngsters can take up the challenging topics, especially in the knowledge gap areas, and they can come out with their PhD programs and similar and bring out the information about the species which is less known or rather unexplored in Indian waters. This is one of the suggestion. And second is actually to use all the molecular barcoding techniques so that, and form a database. At present, some people, and I've seen many youngsters across India who try to do DNA barcoding. But the issue is that many of the endemic species here, or the species limited in the coastal waters of India, we don't have a database DNA barcode data to compare. Unless and you have a database to compare, it's very difficult actually to work on this kind of a science. So that means we need actually collaboration of multiple departments to work on creating a DNA barcode data so that we will have a better picture on the diversity, especially on lesser known taxa. And then don't do reinvent the wheel. It is no use. It's of no use. You can concentrate on the priority species and the knowledge gap areas, and also to work on deep sea habitats as well as the sea mounts and other and also various kinds of associations which is prevalent in the coastal as well as the marine waters, and so that we'll have a larger documentation of biodiversity. And finally, the emerging technologies, use of emerging technologies like omics, environmental DNA, artificial intelligence, and remotely operated vehicles, and these can be popularized so that we can have better documentation of the life below water. And then these are some of our recent discoveries, and many of the discoveries are primarily either new species or a new genus, primarily because it's actually one of my PhD student and postdoctoral student, they specifically work on the parasites and associations therein, because it's an area which is totally unexplored, and that means you have to work on the knowledge gap area so that the chance of getting and documenting new species are more. And how will you address this issue of taxonomic impediment? And I will tell you, who are all not taxonomists in this platform, that taxonomic impediment is an issue where the acute shortage of taxonomic expertise world over. Okay, and at the same time, we have more resources available in the tropical waters. At the same time, for many of the taxa, we don't have taxonomists. And also, in many of the leading institutes, the number of taxonomists are very, very less. And even the young taxonomists in India who are very, very brilliant, they are not getting employment. So all these kind of complications are still there. And then we can address this issue only when we understand that this kind of basic science is essential for all this kind of the so-called cutting-edge sciences. Because unless and until you know what exists in your coastal waters, it's hard for doing any kind of conservation and systematic planning. So that means we should have a better agenda on that. Okay, so the role of the biologists primarily is to strengthen the databases and work as a collective lobby to argue with the government that this is basically an essential science. And also, when the resources are less, you define a new strategy of coordinated multi-institutional projects so that and also multi-taxa inventories. You don't go to the ocean for an exploratory survey to document just a single phylum. This is happening. But at the same time, if you go for a multi-taxa inventory with different kind of people together and a single inventory and exploration, and then you will divide the samples among different groups, and then take the help of international experts, and then the amount of science which we can generate is something marvelous, going to be marvelous. Okay, and then we need actually to focus on 3 C's. One is collaboration, coordination, and communities. These are very, very important. And in India, fortunately, we have a strong the community, particularly the fishermen community, who are actually in the field every day. Take their service and use them as the citizen scientists, and then collect data. A large number of passionate ocean lovers are there. Use their service as citizen scientists and collect large amount of data. And then even the fishermen can be used as parataxonomists to give you information, collect the specimens, and provide you with a huge amount of data. And these are all possible primarily because this is a country where large number of people make their living out of these resources. So these are the other possibilities in India. And next way to avoid the public dilemma about marine biodiversity is that the public is not aware of the importance. We heard about the ecosystem services and the economic value of the ecosystem services, and similarly we should know the people are in India are quite aware about tiger, quite aware about the elephant and the very charismatic other forest species, but not about many marine species. And that especially, and also many smaller species like invertebrates, which play a very important role in terms of its functional values. And that which essentially means that we need to it's actually the duty of the scientific community to make them popular among the public and increase the public perception on that. And also, if you look in terms of red lists, many of the taxa in the marine waters are not properly listed in the conservation listing and the red listing, and that also is another priority in terms of creating a kind of public awareness. And finally, as we heard, the ecosystem services of many of these biomes as well as the species, and that also enhances the public perception about the marine biodiversity. Okay. And another thing is that bring in the people for conservation, because engage people, involve them, authorize them. That is called EIA. Engage, involve, and authorize local communities and for the conservation. And this kind of a bottom-up approach will ultimately help in conservation as well, because we have very good examples in Maharashtra, in many parts of the coastal India, where even the women self-help groups are involved in conservation, particularly mangrove conservation, and also they support tourism by serving as guides. It enhances their economics, their economy, as well as it helps in conservation aspects. So involve them, and particularly practice co-management and not which ultimately help in a kind of bottom-up approach in conservation. Okay, and we have a very good example of a group of youngsters, not primarily biologists, but that include the IT experts and the youngsters who are in different disciplines. They come together to create an awareness about the urban biodiversity in Mumbai. It's called the Marine Life of Mumbai, a network of people who create awareness regularly about the importance of the marine biodiversity, especially in a larger city, metro city like Mumbai. People are not totally unaware of the rich life in the urban waters there. So this kind of awareness programs will ultimately help in creating knowledge about the marine biodiversity, particularly for the public, general public. And also integrity taxonomy, where we can use morphotaxonomy and mix it with ecological values, ecological functions. You can bring in the genetic information, so that the study will be total and comprehensive, and that is it. And then look at the future targets like the 2030 vision or 2050 goals and 2030 Kunming Montreal Global Biodiversity Framework. Here also, the primary vision is to mainstream biodiversity to decision making across governments and business. And here, once you really wanted to achieve this, we need to have a stronger vision within the country, primarily because 2050 vision of the Montreal Protocol, Kunming Montreal Global Biodiversity Framework says that by 2050, biodiversity is valued, conserved, restored, and wisely used, maintaining ecosystem services, sustaining a healthy planet, and delivering benefits essential for the people. So if you really wanted to achieve these targets, and then we should have a national action plan, which of course is in the pipeline, and then every institution involved in that should actually have a proactive plan towards that. Okay. Then another thing is actually the use of metadata. We have centuries old information available with us about the species distribution and the species occurrence and the ecosystem services partially. And if you can combine and collate all this data, we can have a larger information about the knowledge on biodiversity, so that we can always prioritize the conservation in Indian waters as well. Okay, so what we need to do is strategically plan for compiling the metadata and come out with the status knowledge or a kind of white paper on the marine biodiversity and ecosystem services. And if you look at the information already available, and many of the publications clearly tells us that if you really wanted to conserve certain species, we need targeted recovery actions. And if you really want targeted recovery actions, and some of the priorities are conserving in situ conservation and the declaration of marine protected areas, and specifically going for habitat protection. And if you really wanted to do that, we need to identify the hotspots around biodiversity and then increase the number of marine protected areas in India. We have protected areas, but majority of the protected areas are centered around the coral reef ecosystems. But we have areas which are still richer in biodiversity, which are not part of the marine protected or coastal protective areas for that matter. Okay. And if you look at, again, the threatened species and its distribution across the world, again, you can see that India is one of the hotspots in terms of threatened species. And there also, all this tells us that, we need to have a stronger orientation towards conservation. Okay. And this is, again, a very interesting comparison. We were actually using ROVs in our recent studies, which is supported by the European Union. And this is just a comparison. On the left, what you see is actually a deep sea coral, which is reported from Gulf of Mexico, which harbor 8 primary phyla. But you look at the species on the right side, which is a soft coral, documented from the shallow waters, around 30 meters from the Kerala coast, and look at the phylum, and we could document 10 phylum, animal phylum, associated with a single soft coral, called Gorgonian coral. So it clearly tells you that these waters are tropical waters, are species rich, and these are some of our recent studies using ROVs and deep sea diving and exploring the ecosystems which are new, totally new, which are coral reefs, but these are the rocky reef ecosystems along the southwest coast of India, which of course is entirely rich in biodiversity, including some of the unknown species in India so far, as you can see from the photographs, and also the very interesting kind of associations which is available in the coastal waters up to 30 meters, and we started also using remotely operated vehicles to document the marine biodiversity using ROVs in the shipwreck sites and in the rocky reefs, and which clearly tells us very, very interesting habitats, very unique habitats of commercially valuable species like this. And also the using remotely operated vehicles, some of the deep sea shipwreck sites, which are very, very rich in biodiversity, are documented in the recent past using ROVs, and which also tells us that there are some very interesting invasive species occurring in the coastal waters when we examine the shipwreck sites along the Kerala coast at around 50 to 100 meters in various areas. This study is actually ongoing, and which provide you with a lot of information in the coming months. And also, if you look at the ocean sciences, National Ocean Science Expedition, and the contribution of the funds available, and if you look at the funds available in India, specifically for promoting ocean sciences, particularly the basic sciences, and the funds are coming down. And this is an area of concern where probably we have to join together to influence the policymakers, particularly for enhancing the funds for coastal biodiversity documentation. Okay. And many of the conservation analysis tells us that the priority should be given for declaring marine protected areas, sustainable use, and translocation. Of course, I personally will not support, primarily because it's very, very expensive, especially in terms of developing countries and their economy are concerned. Okay, and then another area probably we have to go for with a very, very stronger focus, and that is a focus of this year's Environment Day as well. Habitat restoration, particularly with regard to the coastal ecosystems. Many of the coastal ecosystems, particularly if you speak mangroves, sand dunes, the seagrass beds, as well as the sea weed ecosystem, primarily are under very, very severe stress. And for that, definitely, particularly when we speak about carbon credit and blue carbon ecosystems preservation, and conservation and habitat restoration is very, very important in India, where we have to have a specific orientation. And we have very good examples of success stories coming up from Chilka Lake and many other areas, particularly with regard to the betterment of the blue carbon ecosystems. And that is another area where we can actually focus. And also enhancing the area under marine protected area network. And specifically using the technology for marine spatial planning, where we can specifically identify the priority areas for conservation in the coastal and the marine waters in India. And also, Wildlife Institute of India has already suggested a number of new community reserves along the coastal waters of India. And none of them have actually come up in the recent past. And there is another area which is priority should be given, particularly declaring them as community reserves, because many of them are still used by the communities for their livelihood. These can be community reserves and even managed by the communities. So co-management is an option, especially in the coastal waters, and that is another area. And specifically look at the future. When you look at 2030, 2030, UN Decade of Ocean Sciences for Sustainable Development, there also India can play a very, very important role. And the first thing definitely is enhancing international collaborations, because there are a large number of the agencies using high-end technologies to conserve and document the larger marine biodiversity databases and bring out conservation planning, where we should also be part of that. And the organizations like your foundation can play a lead role in that, being part of the international network and also doing some collaborative projects so that we can have a stronger database available. And another area where India can work is actually working on essential variables and essential ocean variables and also essential biodiversity variables, which actually will ultimately help in conservation planning for the future. And as far as youngsters are concerned, using the mobile applications and getting the support of the citizen scientists in documenting marine biodiversity. And this is a specific example of the monitoring jellyfish blooms in many parts of the world using mobile application and involving citizen scientists. And large number of similar examples can come up in India. And many of the youngsters I know are part of the iNaturalist, where they try to document marine biodiversity and and employ the services of large number of taxonomists across the world through linking with iNaturalist and getting the species identified and being part of the international network and community. And that is another possibility, as you can see here. And we have actually very interesting examples in Kerala coast, where we have first documented the dolphin fishermen interactions. And now we are part of an international grant with the National Geographic, where we are actually trying to document the behavior of dolphin, as well as the interaction between fishermen and the dolphins over a period of time, including using the modern technologies like drones and underwater acoustics to document their behavior and things like that. And then finally, to conclude, for the youngsters, there are a large number of possibilities, especially using frontier technologies in marine biodiversity and coastal biodiversity documenting. And we can use all these kind of technologies in documenting biodiversity so that we can have a stronger database available, and which will consolidate ocean sciences as well as biodiversity sciences, and then will provide a lot of input for management as well as which will ultimately will help in enhancing public perception on marine and coastal biodiversity. Okay. And we have an ideal time here in India because we are part of the UN Decade on Ocean Science for Sustainable Development. A lot of initiatives are coming up, particularly with regard to use of the technologies, as well as creating a stronger ocean science platform, and also capacity building for the younger generations in documenting biodiversity. And also, since the government is particularly interested in promoting blue economy and blue growth, and then it can be the youngsters can play a very, very important role. And many of you, probably youngsters in this discussion, are aware of the Prime Minister's initiative in documenting the fishery resources and promoting aquaculture initiatives. And there also, a lot of employment opportunities are going to come up. And there are some priority areas which I suggest. And one is, the speed up of the whole process of biodiversity documentation using all the available technologies, and the creation and providing data for and information to the existing ocean biodiversity information system managed by CMLRE, and also capacity development for the youngsters, especially in the priority areas as well as knowledge gap areas, and bringing in the interest of the youth in documenting biodiversity, promoting collaboration and coordination between the departments, and promoting co-management. And there are some specific examples of youth involvement in climate change strike, as well as influencing the policymakers. It is not the story of Greta Thunberg alone, but the people are interested, especially the positive sign is that youngsters are, more aware of the impact of climate change and its impact. And also, they are getting more popularity, primarily because they speak for the people. They have a strong point of argument to make. And United Nations has already involved the youth in climate change process. They are heard, and their opinions are valued and documented and prioritized in the policy discussions. And that should happen in India as well, because some of the global leaders in environmental conservation and also the youth leaders for conservation and climate change adaptation, they are Indians. And which essentially means that within India also, we need to strengthen this kind of youth involvement in policy discussions, which is not happening at a rampant pace. And in all the conference of parties, in discussions with regard to climate change, youth are involved, and we should also involve them in multiple planes in the discussion, so that the voice of the youth are heard. And they also should be appreciated, especially for their continuous efforts, so that they will take up a career in ocean sciences or biodiversity sciences in general. And also, we need to promote transdisciplinary research, and which is not that popular as far as India is concerned. And but many of the youngsters can do that, primarily if they have an orientation right from the beginning. And there are a large number of startups in India, and actually the number of startups coming up from India is something very, very which makes us optimistic. And so the youngsters can come up with because the ROV which we use for documenting biodiversity is actually a startup based at Cochin. They invented this whole thing, and then they are using it, and so that is another scope. And also, if you look at the UN Decade, many of the youth leaders are coming up in different parts of the world, primarily to strengthen ocean science and to promote the conservation science and arguments. And again, we have a lot of scope when you look at the ocean science in India, provided we use the sciences in a positive manner, and also to channel the enthusiasm as well as the energy in the youth for ocean conservation. Thank you, sir.
Thank you, sir. Thank you. It was a very insightful one. The floor is open for questions. Ashishda has a question first.
Yeah. First, I think he's left, but I would like to thank Dr. Biju or Professor Biju for a wonderfully lucid presentation because as a layman, I'm not an academic. I come from an NGO background. That was very clear to me. That's number one. First, thanks for that. Second, the other thing that I would like to mention here is that you're talking about youth and you're talking about knowledge hubs, right? I work in the Sundarbans, as some people in ECSF know, and the point is we should include one group of people who have no formal education as such, and that is the people who go by the surname of Sardars. These are actually Jharkhandi tribals who were brought over about 150 years ago by the British to clear the jungles. And these are the people who traditionally go into the forest to gather honey and crabs. And they actually know animal species and the way of the jungle far better than any of us do.
That's true.
Okay, so that's one thing. And the second thing that you were talking about is something very close to my heart, involving the youth. All over the world now there are opportunities, even in India, of youth parliaments coming up. And I think apart from having it as a kind of a career, lots of youth could be roped in because there are issues that they feel strongly about. And today's mobile technology does help a lot because youth are glued to their cell phones.
That's true. Yeah.
So, I mean, this could be two niches that one needs to look at, especially considering the fact that Sundarbans is low technology, low literacy levels, low education levels, and things like that. So, thank you very much for a wonderful presentation. It opens up certain avenues of future work, I would think. Thank you again.
Yeah, thank you.
Anyone having a question? Anyone having a question? Yes, Chinook has a question.
Yes, sir, good evening. Really, thank you for this wonderful presentation. I have a small question for you. Coming from biological sciences background, it's still in India. People are of the notion that we are maybe not that interested or even scared of mathematics and its applications. So, as a student myself who is working on the assurance systems, I like to differ because I have always loved mathematics as a young student. I always have practiced mathematics. But in the slide, you were showing the opportunities or the avenues which are there, which involves artificial intelligence and machine learning, or in the perspectives of ecosystem, how we can involve that into conservation practices. So, being from fundamentally, a biological sciences background, so how can like an early career professional like us, how can we, get started and get involved in learning, not just learning, or to critically think that where should we use the machine learning or the modeling technologies which are available into our Indian systems, which is not available right now. So if you can give some information regarding that, that would be really helpful.
Okay, Januk. Your sound was breaking, but I got the question. Yeah, but see, the question is that, the biologists studying or learning mathematics and modeling and artificial intelligence all of a sudden. But if you read and, conversion with the new trend of papers which are coming up, see, if you look at the high quality research papers published on ecosystem services or ecosystem modeling, you will see that many of the publications may have 10 or 15 authors, and if not 100. And then how does it happen? It happens primarily because people communicate, coordinate, and collaborate. So that is essentially what we need. And I know that many of the biologists, they cannot all of a sudden, prepare, get conversion with a software and go for ecological modeling. But you should have a perception about how to do that. Okay. Once you have a perception on how to do that, And once at the beginning of your PhD program or research program, if you meet people and then discuss with them, and if you can collect the data and sit with them and plan with them and then analyze the data, then you can produce wonderful results. So it is not actually a biologist doing everything together. So what's your duty? A biologist or ecologist can collect the data on ecology and biology, but before you start the work, you sit with a expert or understand. Actually, the first you need to do is actually reading and consolidating your knowledge. Whatever you don't know, you don't worry about that. Okay, but what can be possible in your research, you should understand. Then, before you start the work, you discuss with the kind of data which is available for creating an environmental model or ecological model. And then how can we use the artificial intelligence in actually interpreting or creating a kind of data which is of high value. And that means your ignorance or your partial knowledge on biodiversity, so on artificial intelligence and software or mathematics for that matter, is not the important thing here. But that can be replaced with the support of another person who is well versed in that area. And if both of you work together in collaboration, and then you can bring a wonderful publications. And gone are the days where biologists can sit independently. And many of our recent papers are good examples where we try to work with mathematicians. One of our recent paper also. And then, see, I cannot actually, I am a biologist. I am not an expert in mathematics, but I am not an expert in ecological modeling, but I have papers in environmental modeling or ecological or trophic modeling, primarily because I collaborate. But I know what are the variables which are required for creating knowledge. And if I know that, only thing is to collaborate. You work with the people, you write to the people, and then understand this whole scenario. And then, actually, our education system actually should change. That I cannot do by myself. But especially the universities, they should actually promote interdisciplinary science. You can put a co-guide or co-researcher always in the loop, and that is the way in which actually science should promote. And now many of the organizations like ICER, they are totally proactive on that. But our conventional universities should actually change the whole perception in which the research is done in this country.
Sir, I have a question. Sir.
Thank you.
I have a question. That as you grew up as a taxonomist and like you practicing the science for almost 30 to 40 years, do you think the perception towards the taxonomic science has changed? In India, I'm talking about in Indian context.
Yeah. In Indian context, yes. See, there are two things happening. One, it's not the question of perception. Perception of the people will change over time. But the question is whether we are getting the right kind of support from the system. That has actually totally changed, because if you look at the funding priorities, if you look at the the other priorities, including by the conservation organizations, and there are lesser amount of focus towards taxonomy, and that is the reason why even I have students with who have done PhD with me on taxonomy, primarily because at point of time, because of our lobbying, Science and Technology Department offered specific taxonomy fellowship for the PhD program. It is taken away again by another, the chairperson who came, who believed that it can be part of the general life sciences, and then that is the end of it. But that is one thing, and the perception is changing. But for the youngsters, definitely you cannot actually live with conventional taxonomy alone now. But you need to actually convince the funding agencies, even for a publication. It's always good that you, I will not say molecular taxonomy, but you go for integrative taxonomy, where you can bring in the information about the ecology, ethology, and the molecular genetics together for taxonomy. But many of the people, still youngsters, believe that you can have a DNA and then you can describe a species. That's not true. But you can do it as a supporting tool for the conventional taxonomy.
Pleasure for us that the foundation actually embarked on some of the suggestions that you have laid down. Our first extramural projects that being sanctioned by TBT is actually on the taxonomy and ecology, and an integrated part of the ecology morphotaxonomy and the DNA barcoding. So yes, we are on your track, sir, with your advice. Any question from Dr. Jimli Mondal, being a taxonomist, or somebody else? And any other question? Any questions to sir?
Yeah, not right now. I think once I talked to sir, and I told sir that I want to collaborate with him, but maybe due to some reason I couldn't. Like that time I was in ZSI, if sir can remember. I met with him at ATS.
Yes,
So surely, like maybe after a few months, sure of that. So I will again contact you, sir, within after few more months, while I will be full-fledgedly back to my work that time. So
Thank you.
Thank you
Thank you, sir. Thank you for having so many slides to encourage the young people and a young organization like ECSF. We are just born in 2021. We tried to be on track. We are producing about like 8 master's theses and several papers, and our students are being representing the platform throughout the country as well as in abroad, in UNESCO headquarters also. So that's quite proud moment for us. And many of us are actually practicing basic sciences, where taxonomy is the key. So thank you for being with us. Thank you so much. And I know you are traveling to Malaysia, and you are in Malaysia right now?
I am in Malaysia, yeah.
You are in Malaysia. With this commitment you have encouraged us. Thank you so much, sir. Thank you.
Thank you.
Thank you.
And good night to you all. Yeah.
Thank you, sir. The next session is up to Professor S.K. Rao. Professor Rao is as an advisor to the foundation, and he would say the vote of thanks for today's event. I must say that this is the very last part of the event, and still we are having more than like 80 candidates listening to us. That basically says that's how much capturing the event is and how much engaging the event is. And some of them are from the very early morning hours. So on behalf of the foundation, we really thank them. It's over to Professor Rao for the vote of thanks. Professor Rao. Professor Rao?
Yes.
Yes.
Okay. Will I start?
Yes, sir.
Okay. So, good evening, everybody. Since 11 a.m. right now, perhaps we are in water, really under the grip of Debaruti, Jhimli, and subsequently Saurabh. Because ECOP program presentations were very much regulated by the Baruti, and after that, post ECOP papers were very much regulated and efficiently done their job to present the contribution of the workers who were kind enough to say few words today on World Ocean Day, responding the request of the ECSF. I was just remembering the story during 12th century, King Canute and his courtiers. Canute was more powerful, almighty. And sometimes it appeared in his mind, does the sea obey me? And experimentally, he went to the sea coast and asked the wave to stop there. But no, the wave kissed accordingly as per normal routine, the beach or the boundary. But today, on the 21st century, I should say, if anyone put the question, does the sea obey me or obey us? I should say yes. Because throughout the lecture, each and all the speakers, while presenting their valuable contribution, uttered a single word, that is anthropogenic, that is Anthropocene, that is human activities. That means what we are doing and throwing, ocean is accepting gladly, just like the nature's trash box. Good. Yes, ocean obeying us. But what happened last time while Dr. Biju Kumar and prior to that Professor Robert, they were discussing about the wealth, rather living world of our wealth and their interaction and the ecosystems, and to some extent our economy, that is ecological economics. Yes, we are throwing unscientifically everything, but we are ultimately to face the consequence. Only one example enough, Minamata case, Minamata event. So like this, every day we are just damaging the ocean, the aquatic system, the coastal belt, everything, degrading our ecosystem, their functional regularity, and at the same time their productivity. So consequently, we are losing. Question of GDP is very much related with all these facts, with all of these behavioral adaptations among human beings. So anthropogenic culture, in respect to pay due value to the nature, is yet to be scientifically addressed. Not only for our survival, not only for our satisfaction of the need day to day, but it's the eternal harmony. Land, air, water, biosphere, geosphere, hydrosphere, nothing is separable. However, we are very much enriched today with the contributions and very nice presentation of all the presenters here. I thank Professor Vijayanandan, Dr. Suresh Kumar, Dr. Vishwajit Roy, Dr. Sulakshmi, Shreya Das, Dr. Kejal, Dr. Anirban Akant, Dr. Kunal Chakraborty, Dr. Subhashachi Sudha, Dr. Son from South Africa, Dr. Robert Constanja, and Dr. Biju Kumar. Really, in his lecture, we had the opportunity to have some information to enrich our knowledge furthermore on the oceanography, on the coastal ecology, on the estuarine biology. Undoubtedly, a very recent lectures, particularly some of the lectures are really interesting. That Kunal Chakraborty, I appreciate that because that one very complicated one, but this sort of work is very much essential nowadays to understand the macro, even micrological conditions and microecological conditions so as to add Learned Biju Kumar said how to conserve the biodiversity and the status of the marine biodiversity, coastal biodiversity, and even he pointed out in quick way that there are many small estuaries, very important, and these are very much neglected. Even there are possibilities to have some new species even today, but we are not working in that way, in that ground. To all of these contributors, on behalf of the ECSF, heartiest thanks. With a hope, next time, next occasion, in our next program, they will be with us. At the same time, I must thank to the ECSF itself, to its organizer, to arrange this program today as usual, because last year also it was happened. This time, this program, rather I should say far better than we achieved last time. Also at the same time, as I am seeing at present, only 46, but at 11 or 11:15, we had the opportunity to have 110 or 15 participants in this program. So, with these words, I think that everyone should help us to develop this young ECS organization to a better way, for a better contribution, for doing something innovative, creative towards the development of the nations, at least nations, particularly to the eastern zone, Sundarbans of West Bengal or India, and finally, we must try to the part of the global ocean ecosystem, and the program and contact is very much in progress, and Dr. Saurabh Pal is leaving no stone unturned to have a success in developing the institute. So once again, I thank you all for your kind presence and to with us for the day. Thank you once again.
Thank you, everyone. It was a wonderful day, and I must say this. Thank you to Sarah also to patiently being with us from the morning. It's a true combination of multiple disciplines, multiple minds, multiple views, contrasting opinions that we have shared today in Asian and Coastal Studies Foundation. We have done like that in the previous years also. So on behalf of the foundation, I do thank all of you for being a part of the program. The foundation always caters a lot of internships, hands-on opportunities, and research opportunities for the students and the faculty members. If you feel like joining us, do join us. Write us to the foundation email address. The website for the foundation is www.ecsfindia.org. You can Google us on Google, putting down Asian Coastal Studies Foundation. For all who have participated, there is a token of appreciation in the format of the participatory certificate. You have registered with the email address and your name is there. So please allow us 2 to 3 days time, and we will send your certificate on the emails with which you have registered. So with that, I draw close. Thank you. I sincerely thank all the speakers, all the moderators that to make this event a grand success. Thank you all. Thank you.
Thank you.